Rayleigh wave and Love wave. Okay, so let's try to understand how they vibrate here. They are vibrating like snake. Okay, but hotspot volcano already they have asked mental plumes in mains examination. So जो चीज उन्होंने प्रीलिम्स में पूछी है वो मेंस में पूछते हैं, जो मेंस में पूछी है वो जरूर प्रीलिम्स में पूछते हैं. अगर समझो ऐसे क्वेश्चन आता है, इन नॉर्मल पोलैरिटी अर्थ्स नॉर्थ मैग्नेटिक पोल इज द साउथ पोल ऑफ इट्स मैग्नेटिक फील्ड, एंड इन रिवर्स पोलैरिटी अर्थ्स नॉर्थ मैग्नेटिक पोल इज नॉर्थ मैग्नेटिक पोल. लिटिल बिट कंफ्यूजिंग, बट रिमेंबर एक याद रखना है कि प्रेजेंट पोलैरिटी इज नॉर्मल पोलैरिटी एंड दिस इज द पोजीशन. सो इट इज अ ज्योग्राफी सेशन नाउ. Some of the familiar faces that I can see. Last year also they had joined, and it is a kind of fast revision to the most important topics of geography. Let me set the agenda for the session. First of all, we will focus on the physical geography part, wherein let's say UPSC is asking the concept based questions, especially from climatology, oceanography and geomorphology. And thereafter we will focus on mapping part. Okay, so some kind of static atlas reading we will do. That is also very important, and UPSC is giving more emphasis on that. ठीक है? And if time permits, we will cover the remaining economic geography part, resources and industries. ठीक है? So this will be the agenda. Now, before starting, let's try to understand which areas are to be focused. Last minute revision. So I always tell students that whatever the concepts are there, they are already understood. So it need not to be revised in the last minute revision. Okay, because that is there in your subconscious mind. Somehow you will remember that, or whatever the applied question is there. So you will be able to solve that question. But somehow more of the factual nature of question that is being asked, be it mapping aspect, places in news, or economic geography part, resources, industries, they are asking the infrastructure related points also, like airports, like the question was asked on the greenfield airports, or the question matched the following ports and their features, right? So, or the renewable energy is very favorite area of UPSC, overlapping with your environment section and geography, right? So, there they will ask about the factual aspect, like no thermal power plant is located in the coastal districts of India, or let's say the desert region of India. Such kind of questions they are asking, right? So, renewable energy that government itself is focusing. So, surely they will ask question from that. And we have tendency to forget these things because they are fact or very, let's say, specific information. So, as a part of last minute revision, mapping, that includes your static part plus places in news. Second, resources. Okay, resources and industries, or we can say that, I would say infrastructure, because directly they are not asking industries as such, because that is largely your main syllabus. So they focus on infrastructure related projects, be it roads, railways, power plants, nuclear power plants, and all these things. Thereafter, the third aspect we'll say is related to your concept. If time permits, of course, you should revise the concepts also quickly. It won't take that much time now. Yes, this session involves more of, we can say that, clearing your concepts also, because geography is that kind of subject which requires more conceptual clarity. ये तो आप रिवाइज कर लोगे, इसमें कोई डाउट नहीं है, राइट? यू विल रिवाइज दिस. That is no, let's say, a kind of understanding based topics. Rather, this is more important in terms of concepts. So, at the start, we'll understand the physical geography aspect because that is the base. उसके ऊपर ही ये सारा चीज involve है, right? So, last 2-3 years, you have seen the papers, PYQs. What they are focusing? They are focusing these areas. Anything else that you feel in geography they are asking? after PYQ analysis, right? Now, within mapping also, when we are going to do mapping, I will tell you, but briefly let me tell you here that certain areas are very favorite of UPSC. West Asia and North Africa, that region. Second is Europe. World mapping I am telling you. Okay. Second is Europe. Third is North America. So largely the questions will be from this area of the static part. Whatever the, be it rivers, mountain ranges, whatever they are going to ask, largely they will focus on this. You can see that every year, one question will be from this, be it Red Sea they have asked, or we can say that Golan Heights in past they have asked, or different kinds of places in news also. Levant region, right? So they are asking such kind of questions from this region. Or let's say North Africa, largely because of conflicts that are going on. South Sudan conflict is going now at present, that Rwanda and that region, you can see Democratic Republic of Congo and M23 rebels continuously in news. Lake Kivu, अगर समझो वो क्वेश्चन नहीं आता है तो लेक किवू पे क्वेश्चन आएगा फ्रॉम द स्टैटिक एस्पेक्ट. Rift Lake. So yes, Africa is very important after that. So try to cover these things from the static part. From India, if you see, they are surely going to ask one or two questions from rivers and lakes. This has been the trend. हर साल, ठीक है. So rivers and lakes are very important. Thereafter important is mountains and peaks. Right, mountain ranges and peaks. Match the following type of question. Nokrek or Nanda Devi, if you remember, right? And they have asked that Kumaon region, Kumaon. Now that is the regional name of that mountain region, right? So we have to remember that also, although it is very simple and straightforward from NCERT. Okay, now what I want you to do is simply till the date we have been doing like mapping session. क्या करते हैं हम atlas लेते हैं and we have been reading the maps. Now, the first task you can do hereafter is whatever the place mentioned in NCERT, 11 standard NCERTs are there, World Physical as well as India Physical. Whatever the place that is mentioned in both NCERTs, you should locate that on Atlas. Don't miss on that. Like drainage chapter is there separately, whatever the rivers mentioned in that drainage chapter 11 standard NCERT, they should be located and a brief information about that, origin, length, or which states it is passing through, important cities or located on the bank, or the dams which are built across those rivers. ये सारे important points होते हैं उसके, right? So try to prepare those rivers. Like let me tell you, once there was question that which of the following east flowing rivers originate from Eastern Ghats. If you remember that question, all rivers were from that drainage chapter NCERT. Okay. So that's why I keep telling students कि आप NCERT के जो भी है topics, because in news, let's say places in news, very small rivers also are mentioned. They are not important here. They are important for geography optional, paper 2, mapping part. There they will ask very small rivers. Okay, in your PT they will not ask very small rivers which is in news. The major river they will ask. Okay, so try to prepare from that angle, static part. Places in news separately we'll talk about that. आज के जो भी session होगा, we'll try to focus on static part. Okay, so first of all, the physical geography, and we'll try to learn in sequence geomorphology, climatology, and then oceanography, and then physical geography of India. Okay. As I told you, only most important topics will be revised. I believe that the remaining topics, you know the things, and if you don't know or if you have any doubt or question, you ask me. ठीक है, तो वो भी हम cover कर लेंगे. Yes, online students, keep interacting with me. आप जो मैं पढ़ा रहा हूँ यहाँ पे, whatever the doubts you have, you can ask me in the chat box or directly you can ask. Okay, so first of all, origin of the earth, that chapter we know. From that, the most important aspect is the differences between, we can say, terrestrial and Jovian planets. We know there are total 8 planets and they can be divided into the terrestrial planets and Jovian planets based on their unique characteristics. Now, why terrestrial planets? Because they are rocky in nature. Okay, so rocky in nature means their surface is rocky, we can say, made up of rocks, and they are called as Jovian or gas giants. So Jovian means Jupiter-like, right? So why? Because their surface is made up of gases, or they have thick, let's say, gaseous atmosphere made up of hydrogen and helium, which is, we can say, primordial atmosphere, right? So that's why we call them as Jovian. Now, asteroid belt between Mars and Jupiter, it separates these terrestrial and, we can say, that Jovian planets. So which are these 4? Mercury, Venus, Earth and Mars. And thereafter Jupiter, Saturn, Uranus, Neptune, right? So these are the basic, we can say, differences. Now, the solar wind was most intense near the sun. Now, what is solar wind? Yes, basically solar winds are the highly charged plasma particles emitted from the sun's surface. And they are very strong and they are emitted at a very high velocity. And because of that, those planets which were near the sun, their primordial atmosphere, primordial means the atmosphere which was formed along with the formation of these planets. Okay, when these planets were being formed through accretion process, whatever the gases were released from the interior at that time, that is primordial atmosphere. Now, the atmosphere of these terrestrial planets was wiped out because of these strong solar winds from the sun, while that atmosphere remained here in Jovian planet because they are farther distance. This thing we have to understand. Okay, now next aspect. Yes, evolution of the earth, and in the evolution of the earth we will see the evolution of the lithosphere, atmosphere, hydrosphere. Okay, so lithosphere means how the earth's crust is formed, we can say, or earth's interior is formed. Lithosphere. Okay, earth's crust plus upper mantle is, we can say, lithosphere, right? That how the lithosphere is formed. Now, when the earth was getting formed, it was getting basically cooled, and the cooling process started from the outer surface. Okay, so outer surface started cooling and solidifying first. At the same time, there was density differentiation process going on inside the earth. Density differentiation means what? More dense material was getting settled near the center of the earth, while the less dense material started moving towards the, right? So yes, density differentiation. That's why at the center or the core is made up of more dense material like Nife, nickel and ferrous. That's why we call it as a Nife layer, right? And comparatively, if you see the density of crust and mantle, it is less. So density differentiation process, and that led to formation of 3 layers: crust, mantle and core. Now, over the period, there was also a disturbance in this process because of giant spat event that led to formation of moon, and because of that, again the churning of material inside the earth carried out. Okay, so that further led to density differentiation within the earth and formation of present day lithosphere. Now, formation of atmosphere and hydrosphere. Now, this is very unique. Formation of atmosphere involves 3 subsequent processes. First of all, when there was a primordial or ancient atmosphere that was removed by strong solar winds. First process. When it was removed, simultaneously when the earth was getting cooled, certain gases and water vapor started coming out from the inside of it. Okay, and these gases were different than the primordial atmosphere. The primordial atmosphere was largely made up of hydrogen, helium, methane, ammonia, these kinds of gases, including CO2, carbon dioxide, and very scant oxygen. Okay, oxygen was very less. Okay, as compared to these. The new atmosphere that was getting formed, the gases, largely here the gases like nitrogen or water vapor, and later on through photosynthesis process, oxygen started flooding into the atmosphere. Okay. So basically this is the second and third process. Second process is, we can say, degassing phenomenon. Degassing means the emission of gases from inside the earth. And the third is modification of atmosphere through photosynthesis process. Understood? So that led to more and more proportion of oxygen into our atmosphere. Right? So this leads to present day composition of atmosphere. We will learn in let's say climatology, the composition of atmosphere and all these things. Right? Now the hydrosphere. The hydrosphere, of course, I told you that water vapor came from inside the earth through regassing process, and over the period of time what happened is more and more water vapor was getting condensed, and there was, we can say that, condensation, cloud formation and precipitation. This is how the hydrological cycle started. Okay, hydrological cycle started. We know that there was also extensive volcanic eruption. So there was huge amount of ash, dust in the atmosphere that acted as hygroscopic nuclei for condensation and cloud formation. सब साथ में हो रहा था ये, simultaneous हो रहा था, right? And that led to, we can say that, the formation of water bodies on the earth's surface, water bodies, and that we can say that at present continues as a hydrological cycle, right? So this is the hydrosphere, and over the period of time through that hydrosphere photosynthesis happened. Of course, first photosynthesis started in oceans, and that led to, we can say that, oxygen getting added into the oceans. Through interface of ocean surface and atmosphere, we can say that the oxygen started coming into the atmosphere. Okay? So this is how the proportion of oxygen increased in the atmosphere. Big splat event is basically the very large, we can say that, celestial body had impact on the earth's surface in the geological time scale. We need not to remember kab hua tha, kitne billion years. Basically, immediately after the formation of earth, after certain million years, there was a big splat event. So because of that, what happened is, certain amount of earth's surface got removed and started revolving around the earth. Okay, and present day natural satellite that we have, moon, is basically result of this event. And it is also said that the present day huge depression on the earth's surface that is filled with water, that is Pacific Ocean, is because of this event. Right? Okay. Now, next is, we can say, to understand the interior of the earth, we have different sources, and we can categorize them as direct and indirect sources. Direct and indirect sources. So yes, if the question is asked, like which of the following is the direct source of information, 4 ऑप्शन देंगे, उसमें से 3 indirect हो गए. इस तरीके से क्वेश्चन बेसिक आ सकता है. Okay, but very simple, we can say that. So first of all, the direct sources. Before understanding of seismicity, or we can say earthquake waves, we relied more on direct sources to understand the interior. But of course, there are limitations with the direct sources. You can see, first of all, study of surface rocks. So surface rocks are, we can say that, very different from the underlying intrusive rocks. And that's why we are not able to understand the interior of the earth from these direct sources. Second, deep ocean drilling project, like the one in Kola Peninsula in Arctic, up to 12 kilometer. Okay, up to 12 kilometer. Now, I want you to open the, let's say, atlas also simultaneously. I hope that all of you have, geography का session होता है तो कभी भी atlas तो साथ में रखना है. Now, why I am telling you Kola Peninsula? Because last year it was in news. One of the port there of Russia had been exporting the oil to India, एंड वो न्यूज में इसलिए था क्योंकि मैक्सिमम एक्सपोर्ट्स इंडिया को हो रहे थे वहां से, इसलिए वो न्यूज में था. So a small peninsula is there. You can open the map of Russia or Europe. Okay. And there you can see, or even you can open the map of Eurasia, physical. Eurasia, physical. So you can see there, Barents Sea is there, Kola Peninsula, the northwestern part of Russia. Northwestern part of Russia, Kola Peninsula. So there are huge oil and gas reserves there. And yes, it was in news. And this region is always in news nowadays because of that North Maritime route is being opened there. Kola Peninsula, Kola, a deep drilling ocean project, up to 12 kilometers we have drilled there. So that also helps us to understand the interior of the earth, but up to only 12 kilometers. Now that is within completely earth's crust, right? So that is also a limitation. Then gold mines of South Africa, up to 4 kilometers deep, these gold mines are there of South Africa. They also help us to understand the interior, but also up to limited sphere. Then volcanic eruption, yes, that is also one of the source. Why? Because it is coming from deep inside the earth, especially from asthenosphere. Okay, so whatever the magma that is reaching on the earth's surface, that also help us to understand what is the composition of material inside the earth, right? But again, there are limitations because the asthenosphere is one such layer, but what about the other layers within the earth? So we are not able to understand its composition, its structure. Now that's why the indirect sources, especially the seismic activity, that is very important one. The other indirect sources are also helpful. The study of changes of properties like temperature, pressure and density. Now last year we had asked one question like as we move from Earth's surface towards the center, which of the following properties goes on increasing? Okay, temperature, pressure, density. तीनों बढ़ेंगे? Everyone agree with this? Right? So as we move inside the earth, temperature increases, pressure increases because of overlying, we can say that load of these rocks, and density increases because of the material that is there. Starting में हमने पढ़ा density differentiation when the earth was getting formed, and because of that more dense material got settled inside. We'll see the structure of the earth, interior of the earth. There I will tell you the density. Then study of gravitation, magnetic field and seismic activity. Gravitation. Okay, now we know that earth's shape is geoid or it is oblate spheroid. That means at equator it is bulged and at poles it is flat. That is unique shape, and this shape is because of earth's rotation around its axis, right? Now because of this particular shape, the gravitational field or the value of that small g is different at different locations. Especially if you see the polar region, there is higher value of that gravitation as compared to equator. Why? Because it is nearer to the center of the earth. Poles are comparatively nearer to the center of the earth as compared to equator. शायद हमने फिजिक्स में पढ़ा होगा, क्या था वो फॉर्मूला? G is let's say inversely proportional to R square. Some place it.
Recording in progress.
All right, yes. Good morning, everyone. Online students, good morning. Okay. So it is a geography session now. Some of the familiar faces that I can see. Last year also they had joined, and it is a kind of fast revision to the most important topics of geography. Let me set the agenda for the session. First of all, we will focus on the physical geography part. wherein let's say UPC is asking the concept-based questions, especially from climatology, oceanography, and geomorphology. And thereafter, we will focus on mapping part. Okay, so some kind of static atlas reading we will do. That is also very important, and UPC is giving more emphasis on that. Okay, and if time permits, we will cover the remaining economic geography part, resources and industries. Okay, so this will be the agenda. Now, before starting, let's try to understand which areas are to be focused last minute revision. So I always tell students that whatever the concepts are there, they are already understood. So it need not to be revised in the last minute revision. Okay, because that is there in your subconscious mind. Somehow you will remember that, or whatever the applied question is there. So you will be able to solve that question. But somehow more of the factual nature of question that is being asked, be it mapping aspect, places in news, or economic geography part, resources, industries. They are asking the infrastructure related points also, like airports, like the question was asked on the greenfield airports, or the question matched the following ports and their features, right? So, or the renewable energy is very favorite area of UPSC, overlapping with your environment section and geography, right? So, there they will ask about the factual aspect, like no thermal power plant is located in the coastal districts of India, or let's say the desert region of India. Such kind of questions they are asking, right? So, renewable energy that government itself is focusing. So, surely they will ask question from that. And we have tendency to forget these things because they are fact or very, let's say, specific information. So, as a part of last minute revision, mapping, that includes your static part plus places in news. Second, resources. Okay, resources and industries, or we can say that, I would say infrastructure, because directly they are not asking industries as such, because that is largely your main syllabus. So they focus on infrastructure related projects, be it roads, railways, power plants, nuclear power plants, and all these things. Thereafter, the third aspect we'll say is related to your concept. If time permits, of course, you should revise the concepts also quickly. It won't take that much time now. Yes, this session involves more of, we can say that, clearing your concepts also, because geography is that kind of subject which requires more conceptual clarity. ये तो आप रिवाइज कर लोगे, इसमें कोई डाउट नहीं है, राइट? यू विल रिवाइज दिस. That is no, let's say, a kind of understanding based topics. Rather, this is more important in terms of concepts. So at the start, we'll understand the physical geography aspect because that is the base. उसके ऊपर ही ये सारा चीज इन्वॉल्व है, right? So last 2-3 years, you have seen the papers, PYQs. What they are focusing these areas. Anything else that you feel in geography they are asking after PYQ analysis, right? Now, within mapping also, when we are going to do mapping, I will tell you, but briefly let me tell you here that certain areas are very favorite of UPSC. West Asia and North Africa, that region. Second is Europe. World mapping, I am telling you. Okay. Second is Europe. Third is North America. So largely the questions will be from this area of the static part. Whatever the, be it rivers, mountain ranges, whatever they are going to ask, largely they will focus on this. You can see that every year, one question will be from this be it Red Sea they have asked, or we can say that Golan Heights in past they have asked, or different kinds of places in news also. Levant region, right? So they are asking such kind of questions from this region. Or let's say North Africa, largely because of conflicts that are going on. South Sudan conflict is going now at present, that Rwanda and that region, you can see Democratic Republic of Congo and M23 rebels continuously in news. Lake Kivu, अगर समझो वो क्वेश्चन नहीं आता है तो लेक क्यू पे क्वेश्चन आएगा फ्रॉम द स्टैटिक एस्पेक्ट. Rift Lake. So yes, Africa is very important after that. So try to cover these things from the static part. From India, if you see, they are surely going to ask 1 or 2 questions from rivers and lakes. This has been the trend. हर साल, ठीक है. So rivers and lakes are very important. Thereafter important is mountains and peaks. Right, mountain ranges and peaks. Match the following type of question: Nokrek or Nanda Devi, if you remember, right? And they have asked that Kumaon region, Kumaon. Now that is the regional name of that mountain region, right? So we have to remember that also, although it is very simple and straightforward from NCERT. Okay, now what I want you to do is simply till the date we have been doing like mapping session. क्या करते हैं हम? Atlas लेते हैं and we have been reading the maps. Now, the first task you can do hereafter is whatever the place mentioned in NCERT, 11 standard NCERTs are there, World Physical as well as India Physical. Whatever the place that is mentioned in both NCERTs, you should locate that on Atlas. Don't miss on that. Like drainage chapter is there separately. Whatever the rivers mentioned in that drainage chapter, 11 standard NCERT, they should be located, and a brief information about that, origin, length, or which states it is passing through, important cities or located on the bank, or the dams which are built across those rivers. ये सारे important points होते हैं उसके, right? So try to prepare those rivers. Like let me tell you, once there was question at which of the following east flowing rivers originate from Eastern Ghats. If you remember that question, all rivers were from that drainage chapter NCERT. Okay, so that's why I keep telling students कि आप NCERT के जो भी है topics, because in news, let's say places in news, very small rivers also are mentioned. They are not important here. They are important for geography optional, paper 2, mapping part. There they will ask very small rivers. Okay, in your PT they will not ask very small rivers which is in news. The major river they will ask. Okay, so try to prepare from that angle, static part. Places in news separately we will talk about that. आज के जो भी session होगा, we'll try to focus on static part. Okay, so first of all, the physical geography, and we'll try to learn in sequence geomorphology, climatology, and then oceanography, and then physical geography of India. Okay, as I told you, only most important topics will be revised. I believe that the remaining topics, you know the things, and if you don't know or if you have any doubt or question, you ask me. ठीक है, तो वो भी हम कवर कर लेंगे. Yes, online students, keep interacting with me. आप जो मैं पढ़ा रहा हूँ यहाँ पे, whatever the doubts you have, you can ask me in the chat box or directly you can ask. Okay, so first of all, origin of the earth, that chapter we know. From that, the most important aspect is the differences between, we can say, terrestrial and Jovian planets. We know there are total 8 planets and they can be divided into the terrestrial planets and Jovian planets based on their unique characteristics. Now, why terrestrial planets? Because they are rocky in nature. Okay, so rocky in nature means their surface is rocky, we can say, made up of rocks, and they are called as Jovian or gas giants. So Jovian means Jupiter-like, right? So why? Because their surface is made up of gases, or they have thick, let's say, gaseous atmosphere made up of hydrogen and helium, which is, we can say, primordial atmosphere, right? So that's why we call them as Jovian. Now, asteroid belt between Mars and Jupiter, it separates these terrestrial and, we can say, that Jovian planets. So which are these 4? Mercury, Venus, Earth and Mars. And thereafter, Jupiter, Saturn, Uranus, Neptune, right? So these are the basic, we can say, differences. Now, the solar wind was most intense near the sun. Now, what is solar wind? Yes, basically solar winds are the highly charged plasma particles emitted from the sun's surface. And they are very strong and they are emitted at a very high velocity. And because of that, those planets which were near the sun, their primordial atmosphere, primordial means the atmosphere which was formed along with the formation of these planets. Okay, when these planets were being formed through accretion process, whatever the gases were released from the interior at that time, that is primordial atmosphere. Now, the atmosphere of these terrestrial planets was wiped out because of these strong solar winds from the sun, while that atmosphere remained here in Jovian planet because they are farther distance. This thing we have to understand. Okay, now, thing like that, right? So that's why the nearer the, let's say, point, higher the value of G. And this is how we have been, let's say, able to understand that the interior or structure. Now, magnetic field. The magnetic field has helped to understand the, let's say, distribution of magnetic material within the earth. Okay, what kind of magnetic material and where we can say that is more concentrated, that is also very helpful to understand. Thereafter, seismic activity. Now, it is going to be studied in detail because this is the most reliable source of information to understand the interior of the earth. Then study of meteors reaching the earth's surface. So, this is also one of the, we can say, source. Why? Because the way earth is formed, all these meteors are also formed in the similar manner from the same origin. So, they have kind of common origin. So, studying these will also help us to understand what our earth's interior is made up of. So, this is, we can say, indirect source. Now, let's go in detail and understand the seismic studies, earthquake waves. So, seismicity is basically the study of earthquake waves and we can say resultant impact and understanding of interior of earth because of that. So, earthquake waves or seismic waves. First of all, the earthquake. Earthquake is, in simple terms, it is shaking of the earth. Now, why do we have earthquake? So, let's try to understand that first. We know that earth's surface is made up of rocks or earth's interior is made up of rocks, and these rocks are in a kind of state of equilibrium. Okay, in a state of equilibrium. That means due to force of friction, they are holding on to each other. They are holding on to each other. But a slight change at certain location inside the earth may change this equilibrium. And because of that, these rocks which are at present holding on to each other because of friction between them, this can be overcome and they may slide past each other. Okay, at present they are holding on to each other because of friction force. Now, if the external force is more than this frictional force, especially tensile force means these two rocks are being pulled away from each other. Then there is possibility that the rock will move like this or move like this. Okay, and because of that, what happens is the frictional energy that was built up there, that will be released, and that is released in the form of earthquake waves. Okay, basically these are energy waves. We will say that they are the energy waves. Understood? Now, the point where this earthquake waves are formed or the earthquake is happening inside the earth, that is called as focus or hypocenter. That is called as focus or hypocenter. You can see here, this is the location, let's say. Right. And the point exactly above that focus on the earth's surface, that is called as epicenter. This is the place to receive first the earthquake wave. Okay. So whatever the seismograph, so the first, let's say, earthquake waves are recorded at epicenter, right? So that is epicenter. This is fault plane. So we can say that the plane along which we can say these rocks are interacting with each other, that is called as fault or fault plane, right? Most of the earthquakes happen along the fault plane. Okay, fault plane. Now let me tell you few additional information here, because earthquake यहीं पे पढ़ रहे हैं हम, आगे नहीं होगा. Recently, where we had earthquake? Myanmar, Mandale. Right. What kind of earthquake it was? You may have come across the term. Yes. Strike slip earthquake. Okay. Strike slip earthquake. Now, this kind of earthquake is not happening because of this movement. Rather, it is happening because of this movement. That is, this rock is moving like this. Understood?
This is different from convergent and divergent boundaries.
Yes, largely these are formed in, along the transform boundary, we can say. Strike, we can say the transform boundary, what happens there? They move past each other like this, right? So here you have to understand strike slip means what? They are moving along the strike. Basically, this is the slip and this is the strike. This is slip. This is strike along the plane. Okay. So this kind of earthquakes, they may ask, because whatever the earthquake happened 2 years back in Turkey, it was also similar kind of earthquake. Okay, term that may be asked. Now, most of the earthquakes or almost all earthquakes happens in lithosphere. This term is very important. They can ask this statement directly. Okay, all earthquakes, all natural earthquakes takes place in lithosphere. Lithosphere is crust plus upper mantle. Okay, so origin of earthquake is within the lithosphere. And of course, seismograph records the waves reaching on the earth's surface. Now let's try to understand detailed about types of earthquake waves. And 2 years back there was question, I guess in 2023, very simple straightforward question based on characteristics of differentiate. That's why हमेशा compare करके पढ़ना है. What was the question? It was a comparison between P waves and S waves, right? So let's try to understand P waves and S waves. There are basically two types of earthquake waves, body waves and surface waves. Body waves are those waves which are moving through the body of earth. That's why they are called as body waves. And surface waves are because of, they are moving along the surface of the earth. And that's why surface waves. Now, there are two types of body waves, P waves and S waves. P is for primary, S is for secondary. Okay, so let's try to understand the differences between these two. P waves are comparatively faster, and that's why first one to arrive and record on the seismograph. P waves, they are the faster ones as compared to S waves. So that's why they are called as primary waves. They are similar to sound waves. So sound waves are basically longitudinal waves, and we have learned that in school in physics. Longitudinal waves move in the form of compression rarefaction. They move in the form of compression rarefaction. So here also primary waves, they will be moving like that, and that's why they will be vibrating parallel to the direction of the wave. That means if suppose this is the direction of the wave, then it is moving like this. Compression, rarefaction, compression in the direction of the wave.
So compression, the second word you use?
Rarefaction. Rarefaction. Expansion jahan pe ho raha hai. Okay. So yes, they vibrate to the direction, parallel to the direction of the wave. This thing. Now, the longitudinal waves, they pass through all mediums, all three mediums of the, let's say, material, that is solid, liquid and gases. Always imagine sound waves. Longitudinal matlab sound waves, and sound waves, they pass through all three mediums and their velocity maximum in solids. हमने स्कूल में ये क्लियर किया हुआ है. हमें लगता था कि हम बात कर रहे हैं तो सबसे ज्यादा स्पीड हम एयर में होगी. नहीं, सबसे ज्यादा स्पीड किस में होती है? सॉलिड में. तो वो ट्यूनिंग फॉर्क लेके हम उसको एक्सपेरिमेंट्स करते थे, राइट. So basically you can see velocity decreases in this manner. So it is highest in solids, then in liquids and then in gases. This property has also helped us to understand the interior of the earth. How? Whenever there was change of medium from solid to liquid, the velocity of these waves is found to be reduced. तो जब हमें पता चला है वेलोसिटी कम हो रहा है, तो वी हैव ऑटोमेटिकली डिड्यूस देयर दैट ओके देयर मस्ट बी सम काइंड ऑफ लिक्विड और गैसेस मीडियम्स. अंडरस्टूड? ओके. नाउ they cause stretching and squeezing of the material. This was asked in that statement. So because of compression and rarefaction, what is that is happening? Squeezing during compression and expansion के टाइम पे क्या हो रहा है? It is stretching of the material through which they are passing, that leads to density differentiation of the matter in the medium. So this is the property, and they are comparatively least destructive. So if you talk about the level of destruction caused, so they are the least destructive, right? The most destructive are basically surface waves, and we will try to understand surface waves after this. Now, comparatively, secondary waves, or we can also call them as shear waves, distortional waves, they arrive at surface or recorded in seismograph after P waves. So, of course, their velocity is comparatively less than these P waves. Now, they are similar to transverse waves. Transverse waves, we can imagine the transverse waves as a ripples on the water or lake surface. ठीक है, तो बचपन में हमने पत्थर डाला था पानी में, तो जो रिपल्स हुए थे, right? Basically, they are the transverse waves, and they are kind of sinusoidal waves. Sinusoidal waves like this. So they are forming crest and troughs. They are forming crest and troughs. So these are basically transverse waves, and we know that these waves do not pass through fluids, liquid and gases. They do not pass through fluids, rather they can only pass through solids. Now this property has also helped us to understand why these S waves are not passing through, let's say, whenever there is a kind of liquid medium, especially outer core, right? So this property is also very important. They do not pass through fluids. Thereafter, they vibrate perpendicular to the direction of waves. Let's say this is the direction of wave. So they are vibrating like this. Okay, and they are vibrating perpendicular to the direction of wave. Here they were vibrating parallel to the. Now because of this perpendicular vibration, it is resulting into distortion of the material through which they are passing. Here there was stretching and squeezing, right? So here what happens is, we can say that distort the material only through solid material and more destructive compared to P waves. So comparatively, let's say S waves are more destructive. Now regarding, we can say surface waves. Okay, surface waves. घूम नहीं रहा है क्या? Okay, so surface waves, I will tell you, and I will show that to you also how they are vibrating. Surface waves are formed because of interaction of body waves with the surface rocks. They are formed because of interaction of body waves with the surface rocks. They are the most destructive as compared to all three. They are the most destructive, and these surface waves are of two types. ठीक है, अब ये NCERT या GC Leong में नहीं दिया हुआ है. This is additional information. Okay, there are two types of surface waves. One is Rayleigh wave and other is love wave. Rayleigh wave and love wave. Okay, so let's try to understand how they vibrate here. ठीक है, कैसे vibrate होते हैं? I will show that. Look at this. Love waves. How they are vibrating? They are vibrating like snake. Okay, they are vibrating like snake. देखिए, end देखिए इसका, and look at this direction. Okay, so this is love, and that's why I tell students to how to remember. दोनों में difference कैसे याद रखना है? नाम ही love लिखा हुआ है. Love and snake की analogy करिए कुछ तो. ठीक है? Okay, and second is Rayleigh waves. Look at this. आप कोई भी एक कपड़ा लेते हैं तो उसको ऐसे करते हैं ना धूल हटाने के लिए, तो उस पे जो वेव्स तैयार होता है ना, बेसिकली दैट इज Rayleigh waves. Look at this, how it is vibrating. And this is the most destructive among all types of waves. You can understand whatever the structure is there above it, पूरा ही हट जाएगा वो surface से, right? So Rayleigh waves are the most destructive among the surface waves as well as all types of waves. Understood? दोनों में difference समझ में आया? Now let's try to continue here. Now within this.
Whenever there is an earthquake, so these waves will be there, both these one.
Yes.
But the density will be there, I mean severity will be less.
Yes, depending on the focus of earthquake. That's what I am telling here now. Okay, depending on the focus of earthquake. Shallow earthquakes produce stronger surface waves. Now, the earthquake that happened in Mandalay, have you read in detail? The focus was only 10 kilometer deep. Do you remember? Have you read that? Prelims mantra में मैंने लिख के भी दिया था, अगर आप फॉलो कर रहे हैं पीजीपी के स्टूडेंट्स और अगर टेलीग्राम चैनल पे है तो. Only 10 kilometer deep. So that is not much deeper. So it is not going to generate stronger surface waves. Okay. Sorry, it is going to generate stronger surface waves, pardon me. The reason is, it is very short distance to reach at the surface, and that's why the energy is not lost in the traveling. Now, if suppose the focus is much deeper, what happens is all the energy that is moving towards the surface in the form of earthquake waves will be dissipated through vibrations and all these things. Okay, so less, let's say, or comparatively weaker surface waves will be formed if the focus is deeper. This kind of concept will be asked. ठीक है, ये prelims में आ सकता है. So shallower the earthquakes, stronger the surface waves. Of course, it depends on magnitude, right? It requires more magnitude also, comparatively. The strength of surface waves are reduced in the deeper earthquakes. I have given here example also, Mandalay, Myanmar. Then most of the shaking felt from the earthquake is due to Rayleigh waves. Okay, because they are more stronger and more, we can say, having energy also comparatively. All right, now next concept is shadow zone. Because of understanding of properties of these earthquake waves, we are able to now draw the shadow zones. Okay, shadow zones are basically the areas on the Earth's surface where these earthquake waves are not detected on the seismograph. That is shadow zone. For P wave and S wave, different shadow zones are there. So let's try to understand. For P waves, you can see that the waves are not observed or recorded between 105 to 145. This region. This is the shadow zone for P waves. So beyond 145, they are recorded, and 0 to 105, they are recorded. So this is the shadow zone of P waves. And it suggests that P waves are passing through core of the earth also. Okay, now you must be thinking, sir ये क्यों बना फिर shadow zone? It is because of the continuous refraction. It is continuous refraction of these waves happening. No, the medium is continuously changing inside the earth. We know that waves changes the direction as well as velocity with the change of medium. Change of medium, when I say change of medium, it will be of different density. Okay, and that's why these waves are always drawn as a curved manner. Why? Because there is refraction happening. Okay, and when there is continuous refraction, somehow the waves will not be passing through certain area. ठीक है, सारे waves जो है यहाँ तक अगर आ रहे हैं तो वो ऐसे ही refract होंगे. That's why we have shadow zone due to refraction. अगर refraction नहीं होता तो ये straight आते, फिर कोई shadow zone नहीं होता. Right? Now, secondary waves, S waves, this is important. Beyond 105 here, there is no S wave recorded. This is complete shadow zone, and this region is around 40% of Earth's surface area. Around 40% of Earth's surface area, the S waves are not recorded, the shadow zone. Okay, and this has helped us to understand that these S waves are not passing through core. If they are not passing through core, and earlier we have seen the property of S wave, that they do not pass through liquid and gases. That understanding has helped us to conclude outer core is made up of fluid. Okay, fluid. We have not gone there to see whether it is liquid or gases. But we have said that it is of liquid. It is made up of liquid. Now, why not gases? Very good. So, there is huge pressure of overlying rocks, and gases will not stay under huge pressure. They will try to escape whenever there is, we can say, path to escape towards the lower density area. Towards the lower density area. That's why they will escape towards the Earth's surface. And that's why liquid can remain there in, we can say, high pressure area. So that's why we say that outer core is made up of liquid. This property has helped us to determine this. Now let's try to understand the characteristics and structure and composition of, we can say, 3 layers of the interior of Earth. The outermost layer is made up of, we can say, or it is named as the crust, and it is, we can say, brittle in nature. It is solid, it is brittle in nature, and it's having comparatively less density than the mantle and core. Now within that we can say that oceanic crust and continental crust. We can divide the crust in 2 parts, oceanic crust and continental crust. Now we know that oceanic crust is newer crust, continental crust is comparatively older crust. So nowhere around the earth the oceanic crust is older than 200 million years. Okay, but continental crust is much older and comparatively denser. Okay, so pardon me, it is comparatively lighter. Oceanic crust is more denser, but oceanic crust is thinner also as compared to continental crust. Now, continental crust is more thicker underneath the mountain ranges. Continental crust is more thicker underneath the mountain ranges. For example, underneath the Himalayas, it is said that continental crust is up to 70 to 80 kilometer. Okay, there is concept in, let's say, geography optional, that is isostasy. Okay, so that concept helps us to understand there is a kind of compensation. The more, let's say, solid material above the earth surface, उसको compensate करने के लिए earth crust भी उतना होना चाहिए. But that is not important for GS studies. Continental crust is thicker in the areas of major mountain system. Continental crust is made up of silica and aluminium, Cr. And oceanic crust is made up of Sima, silica and magnesium. Silica and magnesium. This can be asked in prelims. Now the average density is 2.7 gram per cc. Okay, average density. Specifically talking, continental crust 2.7 and oceanic crust around 3 gram per cc. Oceanic crust, comparatively denser. Now, it forms 1% of Earth's volume and less than 1% of Earth's mass. Now, this is additional information. It's not given in NCERT or GCLEO. Okay, 1% of Earth's volume. So, it is very small. Okay, Earth's crust is very small. If you see the size of Earth, volume of Earth and even mass of Earth. Second is mantle, and it is, we can say, a very big one comparatively. The mantle extends from Moho discontinuity. We will see the discontinuities inside the Earth, and they help us to understand how different structure, layers of, we can say, matter having different properties, densities is formed inside the Earth. So, Moho discontinuity is between crust and mantle. Okay. So, beyond that discontinuity up to depth of 2900. So, you can see here in this diagram, first of all, we can locate the crust up to 100 kilometer thick, it is said, Earth crust. Thereafter, lithosphere, crust plus upper mantle, it is saying. Mantle, this is the mantle. Okay, so upper mantle is in solid form. You can see here, this is upper mantle. Okay, this is upper mantle, it is in solid form. Crust plus upper mantle, it is lithosphere. All earthquakes happen in the lithosphere. Just below lithosphere, what we have is asthenosphere. As a part of upper mantle only. ठीक है, या mantle. यहाँ पे देखिए, upper portion of mantle is called asthenosphere. Astheno means weak. Okay, so it is a kind of fluid or semi-solid, and the source of magma for volcanic eruption. It is the source, asthenosphere. Okay, now the crust and uppermost part of mantle together it is called as lithosphere up to 200 km. The lower mantle extends beyond the asthenosphere and it is in solid state. Okay, so lower mantle is in solid state. The rocks that make up Earth's mantle are mostly made up of silicates. The common silicates include olivine, the kind of, let's say, rocks or minerals, garnet, pyroxene, olivine and pyroxene. Olivine, a kind of, let's say, greenish color rock. Olive होता है ना, olive color जो होता है, greenish color होता है. So they are found there, and pyroxene is also there. So largely they are made up of these rocks. Okay, mantle. Thereafter, the density at the mantle and core boundary, it is 5 gram per cc. So from 3 to we have reached to 5 gram per cc in the mantle. Now you can see here, it constitutes of 83% of Earth's volume and 67% of Earth's mass. So basically this is the largest part in terms of volume as well as mass. In terms of volume as well as, okay, 83%, right? Thereafter, core, outer core is in liquid state while inner core is in solid state. We have understood the reason. S waves are not passing through it. So if you see the velocity graph of P waves and S waves, it goes like this. Okay, so you can see the P waves are much, we can say that faster. Let's say this is from surface to core. P waves starts from here, S waves from, let's say, somewhere here. Now it moves like this. Okay, or like this. But S waves, if you see, At core, it is going to be 0. It is not passing through core. This has helped us to understand कि okay, S waves तो जा ही नहीं रहे वहाँ से.
So do S waves pass through the mantle?
Huh? Yes. Because it is a kind of semi-solid and discontinuous layer. This we have to understand. Discontinuous. That means it is not, let's say, in all parts of the earth at that layer that it is in semi-solid or liquid form. इस रीजन से हमें समझना है. Although its speed will be reduced. Its speed will be reduced. ठीक है? तो ये समझना है हमें. Now, next is, yes, the core is made up of very heavy material, that is nickel and iron. That's why it is called as knife layer. Then, according to dynamo theory, convection in the outer core and Coriolis effect gives rise to Earth's magnetic field. We are going to learn separately about this, how Earth's magnetic field is formed. Okay, so it is because of the outer liquid core, the churning of the material there in outer core. The density at the center of Earth is 13 gram per cc at the center of the Earth. So from surface to center it is increasing, and core accounts for 16% of Earth's volume and 33% of Earth's mass. So second highest we can say. So mantle, core and crust, decreasing order. कैसे याद रखना है? Mantle, core and crust, decreasing order, volume as well as mass. Okay, now next is we can say that the geomagnetism itself. Before that, quickly. Yes, composition. Density is because of composition of material only. है ना? Density material का होता है ना? Mass upon volume. तो mass and volume decides the density. Okay, discontinuities. Quickly we'll have a look at discontinuities. The first one is between upper crust and lower crust. Upper crust and lower crust, it is Conrad discontinuity. Okay, then Mohoric or Moho discontinuity between crust and mantle. Then upper mantle and lower mantle. Okay, upper mantle and lower mantle, we have Rapiti discontinuity. Thereafter, between mantle and core, we have Gutenberg. And between outer core and inner core, we have Lehmann discontinuity. तो ये याद करना है अच्छे से. ठीक है? Discontinuity, they will ask the standard question, match the following. क्या क्वेश्चन बनता है? मैच द फॉलोइंग. इसी तरीके से हम ये सब नोट्स भी दे रहे हैं आपको. ठीक है? इसी तरीके से क्वेश्चन बनेगा उसका. देयर आफ्टर. ठीक है, क्या होगा इसका आंसर बताइए. ऐसे ही फ्रेम करते हैं क्वेश्चन. ऑल ऑल ऑल, नो नो नो. करेक्ट पूछा है. ऑल अर्थक्वेक्स अकर इन अर्थ्स क्रस्ट, lithosphere, right? Then all earthquakes occurring on the ocean floor result in the tsunami.
all earth crust most.
नहीं, all earthquake occur in earth's crust. जरूरी नहीं ना. हाँ, incorrect है. All earthquake occurring on the ocean floor result in tsunami. Not necessary. It requires magnitude of more than 4 or 5. Right? So incorrect. All earthquake occur along the tectonic plate margin. Not necessary. Within, let's say, plates also happen along the faults. Bhuj earthquake. So there is fault within the plate, right? So within plate also there are faults and there earthquake can happen, right? So all three are incorrect. So none of them is correct. D is the correct answer. All right. Then volcanoes. Let's quickly revise that. Okay, so mantle part of the earth contains weaker zone called as asthenosphere and the molten magma material that finds its way to the surface from this layer of the earth, asthenosphere, right? So material in the upper mantle portion in asthenosphere, it is called as magma, and once it reaches to the surface, it is called as lava. Okay, when the magma cools and solidifies within the crust, plutonic rocks formed in intrusive landforms. Plutonic within the earth. Okay. And when the magma solidifies on the earth's surface, they form volcanic rocks in extrusive landforms. Plutonic and volcanic. Okay, difference. Then why does volcanism occur? Now we know that tectonic theories, convectional currents are continuously moving there in the asthenosphere, and whenever it finds a weak zone in the earth crust, that magma tries to reaches on the earth's surface in the form of volcanic eruption. It can be a sudden eruption, it can be a silent eruption, depending on the nature of magma as well as the weak zone. Okay, so depending on that. So convectional currents of magma are formed due to temperature differences in the inner and outer layer of the earth. Convectional currents. Okay, so there are thermal differences, and that leads to convectional currents. Okay. This movement of magma, let's say these are the layers. In asthenosphere also, these currents are moving like this within asthenosphere. They are called as convectional currents. Now why they are moving like this? Because of temperature differences, right? So here there is comparatively hotter, here cooler. So it will try to move towards the cooler region or less dense region. This is the reason. Now, what is the source of heat there in asthenosphere? Radioactive decay of radioactive elements plus residual heat. Residual heat means the heat that has remained when the earth was getting formed. When earth was getting cooled, of course, the interior remained hot. That is basically residual heat. That is also one of the source. Okay. Yes. Thereafter, wherever there is a weak zone created on the earth crust, generally along the fault, magma tries to escape towards the earth's surface, and that leads to volcanic eruptions. Okay? So the way volcanoes are formed. Fine. You are going to get this particular document. ठीक है, तो इससे additional अगर मैं कुछ बताता हूँ तो वो लिख के लीजिए. Yes, it is given in your G.C. Leong book. ठीक है, types of lavas, properties, acidic, basic lava. It is also called as andesitic or composite or basaltic or shield lava. Now I am going to give one property, and from that you are going to understand everything. The most important property of this lava is, one is highly viscous and other is highly fluid. Andesitic lava or acidic lava is highly viscous, while the shield lava or basaltic lava is highly fluid. अब इससे आपको बहुत सारी चीजें समझेगी, types of volcanoes and all these things. Okay, so first of all, that is most important. So viscosity, highly viscous, and thus gets solidified near the vent of volcano. Here it is highly fluid and thus travels to the longer distance before getting cooled. Now as it is getting solidified near the vent of volcano, that obstructs further flow of magma, and whenever it comes out, overcoming that vent, the blockage in the vent, it bursts, or it is more explosive now. And that's why the composite volcanoes are more explosive, or a kind of caldera type of volcano. This type of lava is erupted there, or magma is erupted there. Okay, so yes, temperature comparatively less hot, and they are hottest. Basaltic lava is more hot. Now imagine, if it is more hot, it will be more liquid, more fluid. I told you one, let's say, property you have to remember. automatically other will be easily, let's say, remembered from that. Then thereafter, percentage of silica and the color of lava, they are linked to each other. Here we have high percentage of silica and that's why it is light in color. Here silica is low and that's why it is dark in color. They are linked to each other. Okay, color. So how to remember this? Black soil is formed from basaltic rocks. Basaltic rocks are formed because of basaltic lava eruption in Deccan traps and they are black in color, dark in color. Remember like this. ठीक है, अगर लिंक करके रखोगे तो माइंड में हमेशा याद रहेगा, आइसोलेशन में नहीं याद रहेगा, राइट? एंड दिस इज लाइट इन कलर, अपोजिट, एंड you can remember now. And I told you nature of eruption, it is because of this viscous nature, there is loud explosion, explosive eruption happens, and this is a kind of gentle eruption or silent eruption, that not that much explosive. Then type of volcano, now based on, we can say that this kind of material that is coming out along with lava here in composite volcano or stratovolcano, what happens is the viscous lava is getting solidified near the vent of volcano immediately, and along with that it is emitting various kind of pyroclastic material. Okay, pyroclastic material includes the dust or we can say ash and different kind of material, and that gives the composite nature or look to that volcano, like Mount Fuji in Japan, Fujiyama. Okay, composite volcano or stratovolcano, they are steep sided. Why? Because all the material is getting immediately solidified near the vent, and that's why a kind of volcano that is getting formed यहाँ पे ही solidify होते जा रहा है ये सब, तो ऐसे steep sided बनता है. But if you see shield volcano, gentle sided. Why? Because it is flowing to the farther distances and then it is getting solidified, and that's why it forms shield volcano or gentle sided. Looks like a kind of shield. Shield if देखा होगा आपने warrior का, तो yes, plate boundary. Okay, now this is important. Where we have this volcanic eruption or this kind of lava, whenever there is convergent plate boundary, so plate are converging, so what happens is the earth crust is reaching to the much deeper level and then it is getting melted. Okay, and that result into formation of magma that comes up, that is basically acidic or andesitic. ठीक है, अब मैं ये भी याद रखने के लिए आपको ट्रिक दूंगा. Andes, how Andes are formed? Plate convergence, Andes, andesitic और acidic link. ठीक है, तो अगर confusion है तो वो clear रखना है ये, right? Whenever there is convergent plate boundary, so let's say Mount Stromboli, where it is located? Italy or Mediterranean, it is called as lighthouse of Mediterranean. न्यूज में भी रहता है, इरप्ट होते रहता है, राइट? सो देयर वी हैव अफ्रीकन प्लेट एंड यूरेशियन प्लेट कॉन्वर्जिंग, ओके, और बी इट माउंट फुजी और ऑल द वोल्केनोस अलोंग द पैसिफिक रिंग ऑफ फायर. सो ऑल दीज आर काइंड ऑफ these types of volcanic eruption. But if you see this one, divergent plate boundaries like Iceland. So Iceland, mid-Atlantic region, okay, mid-Atlantic Ocean. So the ridge region, or we can say that is a divergent plate boundary. There we have formation or basaltic lava eruption or hotspot volcanism. In addition to that, यहाँ पे लिख के लीजिए क्या है ये hotspot volcanism. Like for example, we have Hawaiian Islands. There we have shield volcanoes. Mount क्या है वो, किलू, बहुत सारे हैं ना वहाँ पर, मोना किया, Mauna Loa. So they are kind of hotspot volcanoes, and let's say because of reunion hotspot, whatever the Deccan traps that we have formed on the Indian plate, they are also example of basaltic lava. So that is also hotspot volcanism. याद रहेगा ये? ठीक है. Finally, examples, Mount Pelee. कहाँ पर है Mount Pelee? वेस्ट इंडीज में है. Yes. Lesser Antilles. Mount Pelee. ठीक है, एक्टिव वोल्केनो. Mount Fuji, Japan. Mount Stromboli, Italy. Fisher eruption, Icelandic eruption. So they are the examples of. ठीक है, ये याद रखिए, ये पेंडिंग क्वेश्चन है, अब तक नहीं पूछा है यूपीएससी ने. टाइप्स ऑफ लावास पे. ऑफ कोर्स दे हैव आस्क्ड द कॉन्सेप्ट ऑफ वोल्केनिक इरप्शन एंड टाइप्स ऑफ वोल्केनोस, बट लावा से रिलेटेड कॉन्सेप्ट नहीं पूछा है अभी तक. देन टाइप्स ऑफ वोल्केनोस, दिस इज फ्रॉम एनसीईआरटी ओनली. ठीक है, सो शील्ड वोल्केनो, द फर्स्ट वन. जस्ट नाउ वी हैव अंडरस्टूड basaltic lava. Okay, basaltic lava is not that let's say explosive, but if suppose the water gets trapped into the vent of that volcano, that may result into explosion. Why? Because the water will immediately evaporate and become the gas, and gases will try to evacuate or let's say come out in very faster and explosive manner. That's why it becomes explosive. ठीक है, and that's why it is also said that underwater volcanoes are more explosive. Mount Tonga 2 साल पहले 1 साल पहले न्यूज में था, पैसिफिक, सदर्न पैसिफिक ओशन, अंडर वाटर वोल्केनो, मतलब ओशन में है, तो वहां पे पानी तो आएगा ना वेंट में, तो बिकॉज ऑफ दैट एक्सप्लोसिव, राइट. नाउ volcanoes are mostly made up of basaltic lava, very fluid, and along with that we can say not steep sided. They become explosive if water gets into the vent, otherwise they are low explosive. Upcoming lava moves in the form of fountain and throws out the cone at the top, developing cinder cone. ठीक है, cinder cone तैयार करता है. Then barring the basalt flows means flood basalt provinces. Basalt flow मतलब क्या है? Basalt flow, Deccan trap example. So barring these types of volcanoes, they are the most extensive. The shield volcanoes are most extensive or the largest on the earth. Example, Mauna Loa, Mauna Kea, Hawaiian volcanoes. Composite volcanoes. Okay, so yes, they are characterized by explosive eruption because of cooler and more viscous lavas. ठीक है. Then along with lava, large quantities of pyroclastic material and ash find their way, and that's why it gives the composite character to these types of volcanoes. See, Mount Fuji का photograph है. Mount Fuji, Mount Stromboli, Mount Pelee, they are the examples. Okay. Then caldera. So caldera is a kind of variant of composite volcano or explosive volcanoes, we can say. They are so explosive that they collapse on themselves. Calderas. Okay, so most explosive of Earth's volcano, usually so explosive, they erupt, they tend to collapse on themselves, and that's why they do not build any tall structure, because they are collapsing instead of forming the structure by getting solidified. So collapsed depressions are called as calderas. So that means instead of forming a cone, what they are doing is they are forming caldera, and if they become now the, let's say, inactive, or we can say that क्या बोलते हैं उसको, हाँ, dormant. ठीक है, तो वहां पे पानी जमा हो जाएगा, and they will form the lake, crater lake or caldera lakes. Okay, they are called as crater lake or caldera lakes. So explosiveness indicates that magma chamber supplying the lava is not only huge but also in close vicinity. That's why more explosive. Reason. In geography, you can see that 2 to 3 questions which are concept based questions, they are always asking assertion reason type. Statement 1, statement 2. Whether statement 2 is explaining statement 1. Nowadays statement 1, 2, 3. ज्योग्राफी में ही आया है वो क्वेश्चन, जो एक क्वेश्चन आया था 3 स्टेटमेंट वाला, तो वो ज्योग्राफी का ही था. अब वो पूछने का स्कोप कहां पे है? ओनली इन फिजिकल ज्योग्राफी लार्जली, मतलब ठीक है, ओनली नहीं बोलूंगा मैं. Why? Because concepts are involved, no? And concept involves phenomenon. Phenomenon will have cause and effect kind of relationship. Why it is happening? ठीक है, तो इसलिए क्वेश्चंस जो फ्रेम होंगे इसी टाइप के. Then flood basalt province, they are the largest kind of volcanoes on the earth. The extensive, most extensive we can say. So highly fluid basaltic lava flows for longer distances the way we have Deccan traps. ठीक है, तो Deccan traps का वहाँ पे एग्जाम्पल है flood lava और flood basalt provinces. Then intrusive landforms. There can be matched the following type of question. Okay, intrusive landforms, and yes, intrusive means they are formed by solidification of magma inside the earth's surface. Intrusive, ठीक है. First, batholiths, they are a kind of magma chambers. The source of magma gets solidified. When the overlying material gets withered and eroded, they may be exposed in future. Okay, magma chambers. Dome shape, we can say structures. Now, laccoliths, look at this, laccoliths. It is a kind of convex shape structure with a pipe-like conduit from below, which is source of magma from bottom. Okay, so that is laccolith, connected like pipe-like conduit from bottom. Then lapoliths, lapo ऐसे याद रखने का, lap होता है ना हमारा lap, saucer shape. But the difference between the laccolith and this lapolith is that it is a horizontal movement of magma and then solidification, horizontal movement. ठीक है, तो यहाँ पे तो दिखाई नहीं दे रहा है, बट क्या होता है कि समझो यहाँ से ये साइड में चला गया है यहाँ से, and then it solidifies like this, saucer shape. That is lapolith. Then faccolith. Faccoliths are wavy mass of intrusions. So faccoliths are what? Wavy mass, and they are solidifying at the top of and at the bottom of, or we can say like this, anticline and synclines that are formed inside the compressed rocks. Anticlines and synclines. So suppose this is the movement of magma, and suppose there is scope to move like this, but these are compressed rocks. There is formation of anticlines and synclines. Sometimes the magma gets solidified here, sometimes here. They are called as faccoliths. Horizontal. Okay, vertical नहीं हो रहा है supply. Horizontal. Then silts and sheets. They are comparatively thicker, they are comparatively thinner. But both are basically horizontal linear solidification of magma. ठीक है, यहाँ से ये यहाँ पे देखिए, silts and sheets are much thinner. And dikes. Dikes are basically, let's say, when the magma is solidifying almost perpendicular to the ground. Okay. So there are several dikes in the Western Ghats, Sahyadris in Maharashtra at present, and they are exposed. Why? Because the other material is withered away. ठीक है, समझो ये ऐसे ये है या ये है, राइट, तो बाकी सब विदर हो चुका है, तो ये ऐसे के ऐसे खड़े हैं. They are considered as the source of magma from bottom. ठीक है, wall like structures. All right, let's move on to next now. Okay, mantle plumes and hotspot volcanoes. As we are learning about volcanoes, although we should learn after tectonic theories. ठीक है, but hotspot volcano already they have asked mantle plumes in mains examination, so there is always scope to ask in prelims. जो चीज उन्होंने prelims में पूछी है वो mains में पूछते हैं, जो मेंस में पूछी है वो जरूर प्रीलिम्स में पूछता है, ठीक है। और ज्योग्राफी इतना भी बहुत ही मतलब वास्ट नहीं है, स्टैटिक काइंड ऑफ सब्जेक्ट है, तो दे विल रिपीट द थिंग्स, राइट। दैट्स व्हाई इन ज्योग्राफी PYQ इज मोर इम्पॉर्टेंट, ठीक है। बाकी सब्जेक्ट हिस्ट्री और ज्योग्राफी है, पॉलिटी है, उसमें PYQs आर मोर इम्पॉर्टेंट, राइट। So mantle plume and hotspot volcanism. Let's try to understand what is mantle plume. ठीक है, it is a kind of extra plate volcanism. A mantle plume provides the continuous supply of abnormally hot magma to a fixed location in the mantle referred to as hotspot. ठीक है, let me draw here. कैसे दिखता है वो? Okay, let's say this is core, this is mantle, okay, and this is crust. Now what happens is, at certain locations along the mantle core boundary, there is abnormal heat available, and that leads to movement of this melted material towards crust in this manner. Okay, now when it is moving, it will look like this. Okay, at the bottom of this crust, it will look like this, a kind of flower. ठीक है, पुष्पा का क्या डायलॉग है? फ्लावर समझे क्या? फ्लावर, ठीक है, तो वो आग होता है ऐसे, ठीक है। तो ये क्या है? mantle. Okay, so in mantle portion or just below we can say crust, it looks like this, and it is huge supply of that molten magma or molten material, but it is localized now. In asthenosphere, it was continuously moving, right, in a kind of current. So it was not at one place, it was continuously moving from one place to other place. But here you can see that at this single location, it is continuously supplying that molten material. And if this particular part is weak, if suppose this is the weak zone, it will come up in the form of volcanic eruption. If the crust is weak zone, it will come as volcanic eruption. For example, Hawaiian volcanoes. Now, Hawaiian volcanoes are located at the center of Pacific plate. So that is example of intraplate volcanism. So what we learn in plate tectonic theory, generally the volcanic eruption is happening along the plate boundaries, right? Now this kind of intraplate volcanism is explained through concept of mantle plumes, okay, through concept of mantle plumes. And here the source of magma is not asthenosphere, it is the mantle core boundary. It is the mantle core boundary, and it is a stationary source of magma. Okay, I will explain that here with the help of this diagram. What is happening in the Hawaiian volcanoes? Open your world map or Oceania map and see the Hawaiian volcano, Hawaiian Islands. Hawaiian Islands open करिए, वहां पे देखिए. कर लिया ओपन? So there are so many islands being formed there, and some of them can be shown like this. Look at this diagram. Pacific plate is moving in this direction, northwest. Okay, it is moving like this. Direction of plate movement, it is shown like this. Now, few thousand years ago, the plate might be at this location and there is hotspot from bottom. So there is volcanic eruption and thereafter there is cooling of that magma and formation of island. Now the plate has moved ahead. The plate has moved ahead and then the new place has arrived above that hotspot. Then there is volcanic eruption happening there and because of that there is new island getting formed. Again the plate is moving ahead. This is how the chain of islands are formed there. Okay, and the active volcanoes are located here, while the let's say these are not active volcanoes now, these are proper islands formed there. Okay? So intraplate volcanism is explained with the help of mantle plumes. Understood? Then another example of hotspot volcanism is reunion islands. Now open the map of Indian Ocean there. In the Oceania you can see reunion islands are located where? Near Madagascar. They are the French overseas territory in Indian Ocean. Reunion islands. Now the Indo-Australian plate basically moved over this reunion islands, or we can say reunion hotspot. There is hotspot beneath that in the geological past, and when Indian plate was moving over it, there was volcanic eruption that led to formation of Deccan traps. But Indian plate moved ahead and over the period it cooled down, and now the present day Deccan traps, and you can see the severe weathering and the soil formation also. So that happened thousands of years ago. When Indian plate moved ahead, there was ocean also, because largely Indo-Australian plate is oceanic plate. So there also the volcanic eruption happened and that led to formation of island chains and chains, like for example formation of Maldives, formation of Lakshadweep, or formation of that Chagos archipelago. You can see that all that is in a kind of chain from that let's say reunion island. वहाँ पे दिखता है वो. अब इंडियन ओशन का मैप देखिए, ओशंस के मैप एंड में दिए होंगे. है ना? द ओशंस बोल के एक मैप है, राइट? द ओशंस. तो वहां पे इंडियन ओशन देखिए, एंड यू कैन सी दैट रियूनियन आइलैंड से निकलते हुए एक रिज जा रहा है, सेचलिस माउंटेन रेंज, देन सोकोत्रा चागोस रिज. So Indian Maldives, or we can say this Lakshadweep, they are part of that Chagos Reach. They remained largely underwater because that much huge volcanic eruption may not have happened. Some islands were formed, जो sea surface के ऊपर आ गए, they formed the islands, right? Some could not come above the sea, they are sea mounts. But as it is a tropical region, some of the sea mounts, there was formation of coral growth, and that led to formation of coral atolls. That is Lakshadweep. Lakshadweep is basically sea mount, but उसके ऊपर coral growth होके वो ऊपर आया है sea surface के. Basically that's why we call them coral island, but originally they are volcanic. ठीक है? All right. Now, okay, you have understood this concept. Now, the current development. It is being said that in Africa there is formation of new ocean, or in future there will be formation of new ocean. कहाँ पे हो रहा था ये? Very good. Afar triangle. Okay, Red Sea region. So the reason behind that is, we know there is East African fault or African fault. So that fault is being formed because of huge nature of African plate. And underneath that fault, it is said that there is a mantle plume. There is presence of mantle plume. And because of that pressure of mantle plume from beneath, that plate is getting divided into two parts. तो ऐसा बोलते हैं कि after 10 million or 20 million years after present day, there will be two plates formed from the African plate. ठीक है? So it is because of mantle plume and not because of convection current. ठीक है? Convection currents will try to come up where there is a boundary of plate. ठीक है? When there is a boundary, plate boundary. Okay. Now next. Again, the related concept from your GC Lyon. Geysers and hot springs. A minor difference that you should know. These are the fountains of hot water and superheated steam that is usually emitted with explosion. There is no explosion, there is explosion. There is no steam, there is steam. Also, you should know that they are geysers, there is periodic eruption. ठीक है, geysers में क्या होता है? Periodic eruption. There is continuous movement. Okay. Largely, geysers are located in the volcanically active region, not necessarily volcanic active region. These are the differences. Okay, so often triggered by gases seeping out in the heated rocks. Almost all world's geysers are confined to three major areas: Iceland, North Island, New Zealand, and Yellowstone Park of USA. Very famous. ये टूरिस्ट डेस्टिनेशन है, येलोस्टोन नेशनल पार्क इन यूएस फॉर दिस गीजर्स. ओल्ड फेथफुल, हाँ, वेरी गुड. ठीक है, तो वो पीरियोडिक गीजर वहां पे इरप्शन होते रहता है, राइट. नाउ हॉट स्प्रिंग्स आर फॉर्म व्हेन वाटर सिंक्स डीप इनफ बीनीथ द सरफेस टू बी हीटेड बाय इंटीरियर फोर्सेस. So it is not necessarily the volcanically active region. There can be residual heat inside the earth that may heat that groundwater. Now that heated groundwater will reach the earth's surface in the form of hot springs, and that's why they are more widespread. You can see all over the India the presence of hot springs. It's not only the Himalayan region. Himalayan region में तो है ही. Best example is Manikaran. है ना, हिमाचल प्रदेश में मणिकरण है. सो दैट इज वी कैन से हॉट स्प्रिंग. बट इवन इन डेक्कन प्लेट्यू रीजन और लेट्स से पेनिनसुला रीजन वी हैव सेवरल हॉट स्प्रिंग्स. Water rises to surface without explosion, comparatively more common, contain dissolved minerals which have some medicinal values, and that is exploited by let's say mythological beliefs that we have since ancient times, and that's why most of the let's say spring regions will have temples.
So one of them is Badrinath, near Badrinath.
हाँ, सभी जगह पे मणिकरण हो या सभी जगह पे टेम्पल जरूर होता है. वाई वी लेट्स से इट इज सेड दैट उसको मेडिसिनल वैल्यूज है. ठीक है, तो क्यों है? मिनरल्स डिसॉल्व. Icelands have thousands of hot springs and harnessed for, वहाँ पे तो प्रॉपर यूज करते हैं वो हीट को. ठीक है, हाउस होल्ड हीटिंग, कमर्शियल हीटिंग के लिए, राइट. नेक्स्ट. ओके, जियोमैग्नेटिज्म. नाउ दिस इज अ कंप्लीट डिफरेंट चैप्टर. ठीक है, 2022 there was one question on solar I guess or geomagnetic storms. There was question. Very simple question. Which of the following are the effects of geomagnetic storms? And there were 7 options. elimination method was used there. Tsunami and forest fires. So of course, they will not form the tsunami and forest fires. One can eliminate from that and easily mark that. Last year mains examination, there was question on aurora formations. So now the UPC is touching into that area. And it is not given in NCERT and GCLEO. Okay? It is not given in. Then Aditya L1 is launched. Space weather term is continuously in news. So it is related to solar winds, solar storms, geomagnetic storms. So let's try to understand this concept, geomagnetism. So there is one theory called as dynamo or geodynamo theory, which satisfactorily explains formation of Earth's magnetic field, dynamo theory. So what is happening? Earlier we learned that outer core of the Earth is made up of liquid. Okay, outer core. Let's say this is the inner core and this is the outer core. Okay. Now, core is made up of, we can say that, heavy metals like iron and Ni, or we can say nickel. Right. So they are, we can say, ferrous metals. They have magnetic properties. They have magnetic properties. Now, yes, these are, this is in liquid state. Now what happens here is, as Earth is rotating around its axis, this liquid material is also churned continuously. And because of the thermal differences from this point to this point, what is this? Between inner core and outer core and mantle and outer core. Thermal differences. This will be comparatively hotter than this. And that's why there will be movement of this material from this boundary to this boundary. This is how there is formation of a kind of currents. But it's not actually a kind of linear current. There is formation of solenoid. Solenoid शायद हमने फिजिक्स में पढ़ा हो. ऐसे होता है कॉइल. उसके अंदर से क्या होता है? मैग्नेटिक फील्ड जनरेट होता है. Solenoid. Okay, so all these iron particles, they are moving from this place to this place because of thermal differences in the form of solenoid, and that result into a kind of magnetic field. Okay, when these particles are moving from one place to other place, they are basically carrying charges. When charge moves as a conductor, there will be a kind of formation of current, and when the current passes through solenoid, there will be formation of magnetic field around it. When the current passes through solenoid or any conductor, it creates a magnetic field around it. Right? हमने वो फ्लेमिंग्स लेफ्ट हैंड रूल भी पढ़ा हुआ है उससे रिलेटेड. राइट, कि कैसे डायरेक्शन होती है, क्या नहीं है. राइट, वो आएगा नहीं एग्जाम में, ज्योग्राफी में. ठीक है, मैं बार बार फिजिक्स इसलिए बोलता हूँ क्योंकि ज्योग्राफी इज ऑल अबाउट लॉज ऑफ नेचर. ठीक है, तो आगे वो भी आएगा, केपलर्स लॉ भी आएगा. ठीक है, जब हम पढ़ेंगे प्लैनेट्स के बारे में. Alright, so what I was telling you, when the current is flowing through this solenoid, there will be magnetic field formation. Now, when these magnetic fields are formed, they are random in direction, but because of Coriolis force of Earth, they are aligned in one direction. Because of Coriolis force. What is Coriolis force? Yes, it is because of rotation of Earth. It is a kind of pseudo force, and it is experienced by large scale flow of fluids on the Earth or inside the Earth. Fluids, I am saying, liquid or gases. On the surface, we see the effect on large scale movement of ocean water, ocean currents. Large scale movement of winds, planetary winds. Deflect होता है, because of Coriolis force, and it is because of rotation of Earth. So same effect happens here on this fluid medium, liquid medium of outer core, and all these magnetic fields are aligned in a single direction, and that cumulative effect creates a larger magnetic field of the Earth. This is how geomagnetism is there. Now, how it is self-sustaining. आपने डायनामो देखा है या पढ़ा होगा. डायनामो इट इज सेल्फ सस्टेनिंग. जब तक आप वो डायनामो को मैकेनिकल एनर्जी देते रहते हैं तब तक वो इलेक्ट्रिक एनर्जी तैयार करते रहता है. पहले के जमाने में साइकिल के सामने एक लाइट लगता था, ठीक है. जब तक आप साइकिल चला रहे तो वो लाइट जलता था. बेसिकली दैट वाज बेस्ड ऑन डायनामो प्रिंसिपल, राइट. सो हियर आल्सो व्हाट हैपेंस इज these charged particles, when they are reaching here, again they are losing energy or losing charge, and they are moving again back here, and this is a kind of self-sustaining loop created here. Okay, and because of that Earth's magnetic field is not reducing, although it is changing its direction. Magnetic poles are changing its location, right? So that means the motion of these particles, it is changing its direction, and because of that it is let's say changing the overall magnetic field and its position, but it is self-sustaining. It is self-sustaining. ठीक है. तो दो तीन चीजें याद रखना है. एक तो लिक्विड आउटर कोर, आयन पार्टिकल्स, thermal difference, and that's why they are moving from this to this location in the form of a kind of conductor. Solenoid याद नहीं रखने की जरूरत है. Kind of conductor, and when the current passes through conductor, movement of charge is current. Movement of charge in a continuous manner is a current. Now the current produces magnetic field around it, and that magnetic field of all these conductors is aligned together in one direction because of Coriolis force. Geomagnetism. ठीक है. And because of this, now Earth's magnetic field, we understand it as a kind of giant bar magnet placed at the center of Earth. Of course, there is no giant bar magnet inside the Earth, but for our own understanding, we are considering it. Now, second thing, yes, of course, there are two poles in the magnetic field. One is North Pole and other is South Pole. The magnetic field lines emerge from North Pole and they end to the South Pole. Magnetic field emerge from North Pole and they end to the South Pole, and within magnet they move from South Pole to North Pole. ये पढ़ा है हमने basic. Okay, now if you talk about the Earth's polarity now, यहाँ पे हमने देखा है North magnetic pole and South magnetic pole. यहाँ पे देखिए. Okay, so this is North geographic pole. Next, अभी यहाँ पे हम ऐसे लिखा करेंगे, ठीक है. North geographic, North magnetic, इस तरीके से. Okay, so of course the geographic North Pole and geographic South Pole are the locations through which Earth's axis is passing, axis of rotation. तो वो तो हो गया geographic. Magnetic poles are different than geographic poles, because where the location where these magnetic field lines are converging, they are called as simply magnetic poles. तो यहां पे देखिए क्या हो रहा है. Magnetic field lines are emerging like this and they are going inside like this. ठीक है. तो ये हो गया आपका, अगर अंदर से देखते हैं तो ये क्या होना चाहिए अंदर से? giant bar magnet, where it is south pole of magnet, this is north pole. Look at the magnetic field lines, they are emerging from north pole. Okay, they are emerging from north pole and they are ending at south pole. I am talking about inside the earth. Now for our own convenience, what we have done is we have named this location as North Magnetic Pole. Actually inside the earth it is South Magnetic Pole. तो क्यों ये confusion? Why we have created this confusion? Rather it is to remove the confusion. For the common people, they are not the geography students, right? तो उनको थोड़ी समझेगा कि अंदर क्या है बाहर क्या है. उनको तो चलता है उत्तर दिशा की ओर चलो. तो वो कहाँ जाएंगे? नॉर्थ में जाएंगे ना. जो कंपास दिखा रहा है वो वहां जाएंगे. अगर उनको बोलेंगे कि नहीं नहीं वो साउथ है तो वो कंफ्यूज हो जाएंगे. अगर उनको बोलते हैं कि आप जा कहाँ रहे हैं तो साउथ मैग्नेटिक पोल की तरफ जा रहे हैं, ये क्या ऐसे नहीं ना. तो दैट्स व्हाई वी हैव created it as named it as North Magnetic Pole, but inside it is the South Magnetic Pole. This we have to remember. Okay, so ये क्या है? Geographic. अब दोनों के अंदर yes, at present the angle between these two axes, okay, one is the one passing through geographic poles, the other is passing through the magnetic poles. It is 11.5 degrees. Okay, it is 11.5 degrees. But at the same time, you should understand these poles wander. ठीक है, वो एक जगह से दूसरी जगह continuously move कर रहे हैं. We will talk about that. Now, what is normal polarity and reverse polarity? So at present, whatever the polarity that we have of Earth's magnetic field, it is called as normal polarity. So what is the present day polarity? Normal. अभी हमने बात की ना, inside the earth it is south and so this is normal polarity wherein the field lines are coming out and they are merging like this. Magnetic field lines. Okay. But what is reverse polarity? Reverse polarity is opposite of this. Now in geological past, the magnetic field roughly around 10,000 to 40,000 years it has been reversing. ठीक है, switch कर देता है, flip करता है magnetic field, and that is called as reversal of magnetic field of the earth. And in past there has been such instances. How we have understood this? Yes. Very good. When there were, let's say, study of rocks in the oceans, we have understood that the new rocks which are formed from the mid-oceanic ridge region, when they are, let's say, moved away, and over the period of time, there was differences in the polarity of the rocks near the mid-oceanic ridge region and away from it. That has helped us to understand that, okay, there has been reverse polarity also in the past. Rocks में magnetic material होता है. Okay, let me tell you that rocks have magnetic material, and when the rocks are getting solidified, that magnetic material gets aligned to that day's or that time's magnetic field of the earth. Align हो जाता है. ठीक है, समझो magnet है. Magnet is a kind of magnetic or material, right? Suppose the rocks are having that magnetic material, and when they are getting formed or solidified, automatically their polarity will be aligned with that times Earth's magnetic field. तो इससे समझ में आ रहा है कि कहीं जगह पे rocks जो normal polarity दिखा रहा है, कई जगह पे rocks जो है reverse polarity दिखा रहा है, right? So this thing. Now these statements are very confusing. अगर समझो ऐसे क्वेश्चन आता है, in normal polarity, Earth's north magnetic pole is the south pole of its magnetic field. Okay, and in reverse polarity, Earth's north magnetic pole is north magnetic pole of its magnetic field. Little bit confusing. But remember, एक याद रखना है कि present polarity is normal polarity and this is the position. बार मैग्नेट याद रखना अंदर का. ठीक है, रहेगा यार? ओके, नाउ two important concepts. One is magnetic declination and other is magnetic dip or inclination. Very important. ठीक है, magnetic declination. What is that? It is the angle between magnetic north and geographic north. Magnetic north and geographic north. What is that? NM and NG. From the center angle. Now that angle is basically calculated as delta. If magnetic pole or north pole is to the right or to the east of geographic north pole, this will be positive. And if it is located on this side, क्योंकि ये wander हो रहा है, ये fix है, geographic north pole fix है, ठीक है, तो इफ इट इज ऑन दिस साइड इट विल बी नेगेटिव, ये याद रखना है, ठीक है. राइट इज ऑलवेज पॉजिटिव, ऐसे याद रखो, राइट इज पॉजिटिव, ठीक है. नाउ व्हाट इज द यूज ऑफ दिस, व्हाई वी आर वरीड अबाउट दिस, ठीक है. लेट्स ट्राई टू अंडरस्टैंड सिग्निफिकेंस. लेट्स से वी आर ट्रैवलिंग इन अ शिप and the sailor of the ship is having compass and we are trying to reach to let's say North Pole. Okay, so with the help of that compass, whether we will reach actually North Pole or magnetic North Pole, but we want to go to geographic North Pole, that error has to be compensated. That's why this magnetic declination concept is there. Okay, the ships that rely on compass for navigation should do necessary corrections to account for magnetic declination at different latitudes and longitudes to stay on the right course. Okay, magnetic declination is different than magnetic deviation. Both are different concepts. Deviation is because of the error due to other magnetic material near the compass. ओके, अगर समझो हम एक मैग्नेट कंपास के साथ में रखते हैं, इट विल नॉट टू शो द ट्रू डायरेक्शन बिकॉज इट इज मोर इन्फ्लुएंस अंडर दैट मैग्नेट than Earth's magnetic field. So that is called as magnetic deviation. Understood? Deviation and declination. Now what is magnetic dip or inclination? Dip angle. ये थोड़ा मुश्किल है समझना, ध्यान दो, ठीक है. It is the angle made with horizontal by Earth's magnetic field lines. Now let's try to understand. Let's say this is the Earth and I am standing at the equator. Okay, this is the North Pole, this is the South. Let's imagine. Okay, and the magnetic fields are moving like this. Okay, now let's say this is a bar magnet and it is held by thread. Okay, it is hanged by the thread. So how it will look like at the equator? It will be horizontal. Why? Because this magnetic bar will try to align with the field lines, Earth's magnetic field lines, right? Now let's try to imagine that I am moving towards the North Pole. Look at the position. ठीक है, ये कैमरा के बाहर हो गए, ठीक है. तो ये समझो जैसे जैसे पोल की तरफ जा रहा है तो ये क्या हो रहा है, ऐसे हो रहा है. और पोल पे कैसे होगा? एग्जैक्टली वर्टिकल. Why? Because this North Pole is getting attracted by South Pole of the Earth's magnetic field inside. तो ये क्या हो गया? अब ये वर्टिकल हो गया. यहां पे कैसा था? Exactly horizontal. If we move on this side, again vertical. Okay, now let's try to understand. When I am moving like this and I have reached here, the angle from horizontal and this needle, that angle is dip angle. अब देखिए ये डायग्राम में, ये देखिए, horizontal and this needle, that is called as dip angle. What is the significance? Significance, हाँ. So aeroplanes, let's try to imagine कि aeroplanes are using the compass, but they are not moving horizontally, no. They are also changing the altitude like this. So the needle is going to change its position like this instead of like this in ships. Ship में क्या हो रहा था? हॉरिजेंटल मूव हो रहा था. प्लेन में क्या होगा? नीडल ऐसे मूव करेगा ना, जैसे मैं यहाँ पे इक्वेटर पे हूँ और मैं जा रहा हूँ पोल्स पे, ये प्लेन ऐसे जा रहा है समझो, और पोल के यहाँ डिसेंड कर रहा है, तो ये नीडल तो ऐसे जाएगा, बट डायरेक्शन तो यही दिखा रहा है ना. तो ये डिक्लिनेशन काउंट करना पड़ेगा, करेक्शन करना पड़ेगा. ठीक है, सॉरी डिक्लिनेशन नहीं, डिप एंगल. डिक्लिनेशन नहीं है वो, डिप एंगल है. ठीक है. सो लुक एट दिस, द फेनोमेनन ऑफ मैग्नेटिक डिप इज इंपॉर्टेंट इन एविएशन as it causes the aeroplane's compass to give erroneous readings during the bank turns and airspeed changes. Necessary corrections need to be made to the compass reading to stay on the right course. So ये aeroplanes के लिए है, वो ships के लिए है. And the dip angle is 0 at the equator and 90 degree at poles. ठीक है, 0 at the equator क्योंकि ये तो horizontal ही है, और पोल पे क्या हो रहा है? 90 डिग्री वर्टिकल. याद रहेगा ये दो कॉन्सेप्ट इंपॉर्टेंट है. ऑल राइट. नाउ जियोमैग्नेटिक पोल्स, दिस इज अ काइंड ऑफ
Magnetic declination. It is currently 11.7 degrees. It will remain constant.
yes, magnetic declination is a kind of fixed thing.
But it will change.
In future, of course, as the north magnetic pole will shift significantly, automatically angle changes. And north magnetic pole has been shifting from north of Canada to the north of Siberia. Last 200 years, it has significantly moved from north of Canada to north of Siberia. ठीक है, तो उस हिसाब से वो एंगल भी चेंज होता रहेगा. Now, geomagnetic poles, magnetic pole हो गया, geographic pole हो गया, geomagnetic pole. Now it is a different one. What is that? So let's imagine that there is a hypothetical compass placed at the center of the earth. Hypothetical compass placed at the center of the earth. The line passing through that needle or compass and intersecting at the earth's surface, those poles will be called as geomagnetic poles. Hypothetical compass placed at the center of the earth. ठीक है, तो these are the intersections of earth's surface and the axis of bar magnet hypothetically placed at the center of the earth. Approximately, the geomagnetic dipole and correctly tilted at an angle of 11 degrees to the Earth's rotation axis. जो हमने 11.5 बात की थी, this is 11 degree. अब ये actually fix है. ठीक है, 11 डिग्रीज का ये जो रहेगा वो फिक्स रहेगा, 11.5 चेंज होता रहेगा. ठीक है, क्योंकि ये हाइपोथेटिकल है और सेंटर पे रखेंगे तो ये चेंज नहीं होगा. दिस इज नॉट गोइंग टू चेंज. ओके, ये कॉन्सेप्ट बहुत ज्यादा डीप है और हमारे लिए इतना इंपॉर्टेंट नहीं है डीप जाना.
So what is the difference between declination and geomagnetic? मतलब इसमें जो angle है, what is the difference between that?
See, that angle is related to magnetic pole. ठीक है, मैग्नेटिक पोल्स कौन सा होता है? दे आर डिसाइडेड बाय द फील्ड लाइंस. ठीक है, तो वो तो हम ऑब्जर्व कर रहे हैं अर्थ सरफेस पे. ठीक है, कहाँ फील्ड लाइंस कन्वर्ज हो रही है उससे हम डिसाइड कर रहे हैं. बट दिस वन इज काइंड ऑफ हाइपोथेटिकल कंपास प्लेस्ड एट द सेंटर एंड हाउ इट विल बिहेव.
But the compass is also dependent on the internal magnetic field lines, right?
Yes, internal magnetic field lines.
That is the same thing. magnetic.
Yes, it is the same thing. That's why it is nearby at present. ठीक है, at present it is 11 degree. इसलिए वो same है अभी almost.
But then isn't it the same thing? Because what is the difference between these two? If we are considering magnetic field lines in both of them,
हाँ.
then what is the difference?
The difference is that hypothetical compass अगर यहाँ पे place करते हैं तो अर्थ मैग्नेटिक फील्ड का जो फील्ड लाइंस है इसके थ्रू पास होगा. ठीक है, इसके थ्रू पास होगा तो हमें ये जो लाइन मिल रही है वो बता रही है कि फील्ड लाइंस अंदर से कैसे पास हो रही है. अभी हम बाहर से ऑब्जर्व करके वो डिसाइड कर रहे हैं कि नॉर्थ मैग्नेटिक पोल और साउथ मैग्नेटिक पोल. ठीक है, तो इतना इंपॉर्टेंट नहीं है, ऐसा समझो कि क्या है डेफिनेशन याद रखो और एंगल कितना है जियोमैग्नेटिक. ठीक है, अगर पूछते हैं तो व्हाट इज दैट? हाइपोथेटिकल कंपास प्लेस्ड एट द सेंटर, उसमें से जो पास हो रहा है दैट इज जियोमैग्नेटिक. ऑलराइट, नाउ लेट्स टॉक अबाउट नेक्स्ट कॉन्सेप्ट, अर्थ्स मैग्नेटिक फील्ड एंड रिलेटेड टर्मिनोलॉजीज. अर्थ्स मैग्नेटोस्फेयर. Okay, Earth's magnetosphere. So here we have to understand first of all the solar winds. Okay, solar winds are coming from this side. Let's say there is sun. So solar winds are coming in this direction. Okay, now Earth's magnetic field, this is Earth. Earth's magnetic field around it is creating a kind of shield. It is creating a shield, and that protect us from harmful charged plasma particles from these solar winds. Now let's try to understand the structure of this shield. Yes, this side you can see there is a bow shock form. Bow shock, bow and arrow. तो bow and arrow का bow का shape जो होता है. Now this shape is due to continuous bombardment of these plasma particles of solar winds on this side. है ना, कंटिन्यूस आ रहे हैं यहाँ पे, एंड बिकॉज ऑफ दैट इट इज अ काइंड ऑफ क्रिएटिंग शील्ड ऑन दिस साइड. दिस इज कॉल्ड एज बो शॉक. नाउ मोस्ट ऑफ दी चार्ज पार्टिकल्स विल ट्राई टू मूव अवे फ्रॉम दिस. ठीक है, यहाँ पे देखिए ये डायरेक्शन दे रहे हैं एंड दे विल ट्राई टू मूव लाइक दिस, but some of them will try to enter into Earth's magnetic field. And when they enter into Earth's magnetic field, they will try to move along the Earth's magnetic field lines. They are charged particles and they will try to move along the magnetic field lines where they descend. Where the magnetic field lines descend on the Earth near the polar region. Look at this. Maximum charged particles, they are descending near the poles, creating a funnel-like structure called as polar cusp. इसको क्या बोलेंगे हम? Polar cusp. So they are concentrated there, these charged plasma particles, and these charged plasma particles near the poles are going to create the beautiful phenomenon of auroras. Right? Aurora formation is because of this. अब अगले पार्ट में हम पढ़ेंगे वो. Now, another important part of this magnetosphere is Van Allen belts, radiation belt. अभी न्यूज में था ये, कोई एक प्राइवेट लॉन्च हुआ था, मैंड मिशन, वो ऊपर जाके आए ना 100 किलोमीटर तक. So they entered into Van Allen belt also. ये न्यूज में था. So that we are able to understand how it impacts on human health in the space missions. So Van Allen radiation belts are areas where these charged particles are accumulated on large scale and then released slowly into the space. Suppose there is very huge solar storm coming here. So more charged particles will enter, and here in this particular area they will be accumulated, stored, and slowly they will be released into the space. So it also protects, the kind of protective layer, and it is thick near the equator. It is thick, इस तरीके से है देखो ये. ठीक है, Van Allen radiation belt. Okay, so it is a kind of protective mechanism. Now, कहाँ? हाँ, बिल्कुल हार्मफुल है हम अगर वहां जाते हैं तो, बट इट इज नॉट डिसेंडिंग इनटू द अर्थ्स एटमॉस्फेयर. ठीक है, तो वो ज्यादातर हम देखेंगे कि मीजोस्फेयर थर्मोस्फेयर के वहां पर है. इट इज नॉट एंटरिंग इनटू स्ट्रेटोस्फेयर और लोअर लेयर्स, एंड slowly these particles are released back into the space. This particular region is called as magnetosheath. Along these particles are moving towards the end of magnetosphere, that is called as magnetotail. ऐसे है वो magnetotail. फिश की तरह दिखता है, फिश है ना. Magnetosheath is a kind of, we can say, layer on this side. ठीक है, तो ये जो है magnetosheath होता है, और along that magnetosheath these charged particles are carried to the magnetotail.
So these plasma particles are the same as the plasma sheet is same where the plasma particles got into the polar curve and they are coming out on that plasma sheet.
पोलर कस्प में चले गए तो वो नीचे उतरने की कोशिश करते हैं. यहाँ पे जो बचे हुए हैं वो बाहर से ही जाते हैं ऐसे. मैक्सिमम दे आर एंटरिंग along the magnetosheath only. Very few are entering here when there is very strong solar wind. Okay, fine. Now, let's try to understand how they interact with the lower atmosphere to form the auroras. So, aurora formation, it was asked in mains exam. In the northern hemisphere, North Pole, they are called as aurora borealis, and in the southern hemisphere, they are called as aurora australis. Now, when these charged particles are descending near the polar region, they enter into lower atmosphere, and the gases like nitrogen, oxygen present in those layers, they are interacting with these gases. As they are charged particles, they have energy, and that energy is given to these molecules, gaseous molecules. And these gaseous molecules are now in an excited stage, and they release photons or energy in the form of light. They are releasing energy in the form of light, and depending on the molecules, nitrogen molecules, oxygen molecules, different colors are observed based on the gaseous composition. Okay, so luminous glow in the upper atmosphere of the earth, which is produced by charged particles of solar wind descending from magnetosphere. Positive ions slowly drift westward, negative ions slowly drift eastward, creating a kind of ring current. This current reduces the magnetic field at the Earth's surface. Some of these particles penetrate the ionosphere and collide with the atoms there. Okay, then this results in excitation of oxygen and nitrogen molecules or molecular electrons. The molecules get back to their original state by emitting photons of light, which are basically auroras. Okay, तो क्या याद रखना है? Molecules, ये वाला चीज जरूरी नहीं है, वो नहीं पूछेंगे. आपको याद रखना है कि when they interact with these molecules in the lower atmosphere, they create the auroras. ठीक है. Now, why are auroras mostly seen to occur in the higher latitudes? है ना, लोग घूमने जाते हैं नॉर्वे, स्वीडन, फिनलैंड to see this phenomenon. So they are higher latitudes because most of these plasma particles are descending in the polar cusp, polar region. That's why we see the aurora formation there. But sometimes it is seen in the lower latitudes also. लद्दाख से भी दिखाई देता है कभी कभी. लद्दाख से इसलिए दिखाई देता है कभी कभी क्योंकि वो क्लियर बहुत ज्यादा है, लाइट पोल्यूशन नहीं है वहां पे. बट the major reason is when there is strong geomagnetic storm. Okay, very strong geomagnetic storm, it can be observed in the lower latitudes. solar storm result into geomagnetic storm. Solar storm is because of emission of these charged particles from the sun's surface. When these charged particles are interacting with the Earth's magnetic field and magnetosphere and they are disturbing the Earth's magnetosphere, that is geomagnetic storm. It is a disturbance created in the Earth's magnetosphere by the solar wind. उसको हम geomagnetic storm बोलते हैं. ठीक है, तो ये याद रखना है. So understood how auroras are formed?
So, what is the difference between coronal mass ejections and solar wind?
Yes, coronal mass ejections are also a kind of similar ejections, but they are a kind of let's say ejections happening at a particular place on the sun's surface. Okay, particular place. Second thing, coronal mass ejections are a kind of let's say ejections happening because of interaction of magnetic field of the sun also. Okay, magnetic field. So Earth's magnetic field reverses every 11 year. ठीक है, ये भी आपको याद रखना. सोलर साइकिल बोलते हैं, सन स्पॉट साइकिल, राइट. एंड देर आर सन स्पॉट्स वेयर द मैग्नेटिक फील्ड इज बिल्ट अप. ठीक है, मैग्नेटिक फील्ड इज बिल्ट अप एंड व्हेन दैट इज रिलीज्ड, that is also a kind of coronal mass ejection. And solar winds are basically excessive heat generated at certain locations on the sun's surface. Excessive heat. ठीक है, तो वो दोनों में difference है. Coronal mass ejections is happening on the coronosphere or corona layer of the earth, sun. While the solar storms, they are generating from deep inside the sun. ऐसे याद रख सकते हैं. Okay, geomagnetic storms and its effects. Already UPSC has asked question in prelims. ठीक है, so I was talking about the ring current here. Ring current is what? Ring current is the name given to large electric current that circles the earth above its equator during magnetic storms. Okay, ring current कैसे तैयार होता है? When these charged particles are interacting with the lower atmosphere and they are circulating the earth near the equator, उसको ring current बोला गया. Okay, the varying conditions in the magnetosphere known as space weather are affected by solar activity. If the solar wind is weak, magnetosphere expands, and if it is strong, it compresses the magnetosphere. ठीक है? Periods of intense solar wind activity is called as geomagnetic storms. It can occur when coronal mass ejection erupts above the sun and sends the shock wave through the solar system. It takes just 2 days to reach the earth. ठीक है, it takes only 2 days to reach the earth, and that's why that Aditya L1 mission or that what is that, NASA's Parker probe is there ना. हाँ, तो Parker जो probe है वो भी यही चेक करता है. At Earth's surface, magnetic storm is seen as the rapid drop in Earth's magnetic field strength. तो उसको हम magnetic storm बोलते हैं. Now the effects, we know the effects. Largely it affects the radio communication, long wave radio communication. Then ionosphere expansion can increase the satellite drag. It may become difficult to control their orbits. ठीक है, satellites control from the ground. Then it disrupts the satellite communication systems like GPS. It can disrupt the GPS. Astronauts doing spacewalk, उनका health जो है उस पर इम्पैक्ट गिर सकता है रेडिएशन लेवल्स की वजह से. इलेक्ट्रिक पावर ग्रिड्स, देयर कैन बी फेलियर ऑफ पावर ग्रिड बिकॉज पावर ग्रिड्स कैरी these let's say this electricity on longer distances and they are producing their own magnetic field around it. When that magnetic field is influenced by the external changes in the Earth's magnetic field, there can be disruption in that, or there can be power failure ग्रिड फेलियर. ओके, तो ये भी याद रख सकते हैं आप. फाइन.
So geomagnetic storms, they are caused by coronal mass ejection or solar winds?
नहीं, सोलर विंड, देखो सोलर विंड्स जो है हम बोलेंगे कि कोरोनल मास इजेक्शंस इज अ सोर्स. ठीक है, सन सरफेस से. ठीक है, उसके बाद जो प्लाज्मा पार्टिकल्स के वेव्स तैयार होते हैं उनको हम सोलर विंड्स बोल सकते हैं, जो सन से तैयार होके आ रहे हैं, ऐसे हम बोल सकते हैं. ठीक है,
So the concept winds of both are same.
यस, इसेंशियली बोथ आर सेम. फेनोमेनॉन इज CME, जो सन पे हो रहा है, और जो ट्रैवल कर रहा है उसको सोलर विंड्स बोलेंगे हम. प्लाज्मा पार्टिकल्स जो ट्रैवल कर रहे हैं तो उनको सोलर विंड्स बोलेंगे. ठीक है, ओके फाइन. सो दैट इज डन. इनसाइड द अर्थ इज डन. ठीक है, largely. Now the geomorphic processes. Let's quickly revise this. Geomorphic processes are the processes happening on the Earth's surface or inside the Earth's surface. And if they are happening inside the Earth, they are called as endogenic. And if they are happening above the Earth's surface, exogenic. The source of energy for endogenic forces is, again we can say, convectional current theory or convection currents or the heat. ठीक है. Exogenic, the source of energy is solar radiation. Okay, the ultimate source of energy is solar radiation. Now within endogenic there are two types of geomorphic processes. One is dimorphic and other is catastrophic. Okay, so dimorphic nahi, diastrophic, sorry. Diastrophic. Diastrophism or diastrophic, the word has meaning slow. Okay, diastrophic means slow movement and catastrophic is sudden movement. Diastrophic movements, they are not observed by the naked eye or perceivable नहीं होता है. Catastrophic, they are perceivable, sudden movement है, like earthquake or volcanic eruption, it is catastrophic. Diastrophic is movement of continents, or we can say mountain building and all these things. Okay, so within diastrophic there are two types, apirogenic and orogenic. Apiro means continent, large landmass we can say. The movement of large landmass is apirogenic movement, and generally it is of two types, towards the center of the earth and away from the center of the earth. Towards the center of the earth, away from the center of the earth. If it is towards the center of the earth, it is submergence. If it is away from the center of earth, it is emergence. ठीक है? Then other type is orographic movement. Orographic, oro means mountain, right? So that's why it is mountain building processes. Mountain building processes. Now mountain building मतलब क्या होता है कि there are basically compressional and tensile forces. Compressional and tensile forces. So if it is compressional force, that will result into formation of folds. ठीक है? तो सिंपल है, हम कोई भी पेज लेते हैं और इसको हम दोनों साइड से compression करते हैं तो क्या होगा? Fold हो जाएगा. So all fold mountains are result of compression, right? And if it is a tensile force, there will be formation of faults, right? Breaking of rocks or whatever the tectonic plate is there. If it is moving away, there will be formation of faults, right? And it result into formation of block mountains. It result into formation of block mountains. There was a question last year or last to last year, right? The match the following type of question, right? तो block mountain and ऐसे कुछ क्वेश्चन था, और मेरे ख्याल से लास्ट ईयर ही था, 3 कॉलम दिए थे ऐसा कुछ. ठीक है? सो देयर वाज एग्जांपल ऑफ एल्प्स, हिमालयाज, राइट? 3 कॉलम वाला जो क्वेश्चन लास्ट ईयर इंट्रोड्यूस किया वो ये था उसमें एक. सो एग्जांपल्स ऑफ फोल्ड माउंटेन्स, यस, Himalayas, Alps, Rockies, Andes, and if you see the ancient mountains, The relict mountains, Aravallis and Urals, they are also examples of fold mountains, but they are ancient fold mountains. Okay. Now, block mountains. So, block mountains are result of faulting phenomenon like Vindhyas in India, or we can give example of Vosges mountains and Rhine Valley. ठीक है, वोस्गस माउंटेन्स कहाँ पर है? जर्मनी, स्विट्जरलैंड, वहां पर तो वो हॉर्स एंड ग्रैबन्स काइंड ऑफ टोपोग्राफी क्रिएट करता है, 6th स्टैंडर्ड एनसीईआरटी. ओके, हॉर्स्ट आर द अपर पार्ट्स, ग्रैबन्स आर द वैलीज. ठीक है, सो यस, ओरोजेनी. सो लेट्स ट्राई टू अंडरस्टैंड दीज इन डिटेल. एंड ये वाले जो चीज है वो भी हम सेपरेट पढ़ेंगे, लैंडफॉर्म्स एंड विदरिंग separate topics है उसमें. But before that, tectonic theories. So 3 important tectonic theories are there, right? Important ones: continental drift theory by Wegener. Then we have seafloor spreading theory of Hess, plate tectonic theory of Morgan and Mackenzie. ठीक है, तो first of all, continental drift theory, CDT. This was asked in mains in 2013. प्रीलिम्स में पूछते रहता है कुछ ना कुछ अलग वे से. ठीक है, क्विक रिवीजन टू दिस. सो दिस वाज गिवन इन 1912, जर्मन climatologist Alfred Wegener. What he said is that before 200 or 250 million years ago, all landmass on the Earth's surface was united as a single large landmass called as Pangea. And it was surrounded by a huge water body called as Panthalassa. Then 200 million years ago it started breaking, and first it broke into 2 parts. Northern part it was Laurasia, southern part Gondwana land. Between them water body started occupying the place that is Tethys Sea. Thereafter, these 2 landmasses further broke into different landmasses. The present day continents are result of this. They started moving away from each other under the influence of certain forces. He gave 2 forces. Okay, which are these 2 forces? One is pole fleeing force or force of buoyancy. Okay, pole fleeing force or force of buoyancy. And because of this force, the continents started moving towards equator. Equator word movement. ठीक है, towards equator. यानी कि क्या है? जैसे Indian plate was part of Gondwana land. It was in southern hemisphere, but it started moving towards equator. Same is with African plate. It is moving towards equator or beyond that region, we can say towards Eurasian plate. It is because of pole fleeing force or force of buoyancy. अब ये क्यों होता है? It is because of rotation of Earth around its axis. Let's imagine that this is the axis and there is Earth rotating around it, and what he assumed is that Sial floats over Saima. What he assumed is all continents are made up of Sial and all oceans are made up of Saima, and all continents are floating over the Saima. So according to him, these floating land masses, when the Earth is rotating, they will try to move towards bulge region because of this rotation. कहाँ पे जाएंगे वो? इक्वेटर की तरफ. This is force of buoyancy or pole fleeing force. Then tidal force. Okay, tidal force is basically the force exerted by the celestial bodies. It is a gravitational force of moon and sun exerted on the earth's surface. अब tidal force geography में gravitational force होता है, tides का नहीं होता है. ठीक है, tides जिस वजह से तैयार होती है उसको tidal force बोलते हैं. Right? Gravitational force. Now this force resulted in westward movement of continents. North America moved towards the west, South America moved towards the west, So westward movement, equatorward, westward, these two forces. Okay. Now, to support this hypothesis, he gave certain evidences. तो evidences ज़्यादा promising थे और UPC ने evidences पूछे थे मेंस में. The matching of continents, jigsaw fit. Okay, jigsaw fit, for example, this one, you can see jigsaw fit. So the coastlines of all these continents, they are matching, especially this South America and Africa. Second is rocks of same age across the ocean. Okay, so rocks of this Ghana and let's say it was found Brazil coast, they were of same age. So once they were together, tillites, the glacial tillites, let's say those regions which are at present near the equator, they are having tillite deposits, they are the glacial deposits. How these regions can have glacial deposits? Somehow these might have been in the polar region, because even during the ice age, the equator was not frozen. The tropics were not frozen. ठीक है, तो इसलिए ये एक सपोर्टिंग है. Placer deposits of gold, Ghana and Brazil. So the deposits of gold in Ghana, they are the placer deposit. Placer deposits क्या होता है? हाँ, डिपॉजिट्स जो प्लेसर डिपॉजिट्स उनको बोला जाता है कि वो कहीं से लाके वहां प्लेस किए गए, उनका सोर्स रॉक्स वहां नहीं है. The source of rock of that mineral is not present there. उनको placer deposits बोलते हैं. So placer deposits of gold in Ghana, their source rock lies in the Brazil coast. So that shows that they must have been somewhere sometime ago together. Distribution of fossils, like for example, look at this Glassopteris. Fossil of this fern Glassopteris, it is all over these continents. Or the fossil remains of Cyanogathus or Massasaurus, it is found spread in these areas, right? So that is, these are the evidences, but this theory was, let's say, rejected based on inadequate forces. These forces are inadequate in terms of, let's say, their ability to move the huge land masses. Tidal force is not that strong to move the land masses. Okay, or even the pole fling force, that cannot be, let's say, Earth is not rotating like any very fast around its axis, so as to move that large land masses from poles to equator. So they are inadequate forces. But the idea of horizontal movement of continents or land masses was further carried forward by all these theories, including plate tectonic theory. Seafloor spreading hypothesis. Before that, there was proposal of, we can say, this convection current theory of Arthur Holmes. And along with, before that, pardon me, before seafloor spreading hypothesis, there was, let's say, deep ocean expeditions. During Second World War, these expeditions were carried out to understand the topography that is present on the ocean floor, and that has helped us to, let's say, present this seafloor spreading hypothesis. So what was found there in this study? क्या पता चला हमें वहां पे? First thing is that there is continuous mountain range inside the ocean, on the ocean floor we can say. तो वो उसको नाम क्या किया है? जहां पर क्या हो रहा है? Continuous, there is magma coming up, or magma eruption, continuous magma eruption is happening. This is basically mid-oceanic ridge. Second.
Younger rocks.
Very good. Younger rocks near the mid-oceanic ridge and older rocks away from it. mid-oceanic ridge. Okay. Third, magnetic polarity of rocks. Then age of rocks, ठीक है, age of rocks हो गया. Density of rocks. They are denser as compared to continental rocks. Okay. Then earthquakes. Shallow focus earthquakes near mid-oceanic ridge and deep focus earthquake near trench region.
Oldest rocks were around 100 million years.
Yes, oldest rock not more than 200 million years. So age of rocks and all these properties has helped us to understand that there is continuous new crust being formed near the mid-oceanic ridge, and from this age that nowhere the rock is beyond 200 million years, that means the older rocks are getting consumed somewhere in the trench region, and this process is continuously happening and spreading the sea floor. Whenever there is a higher rate of formation of magma near the mid-oceanic ridge as compared to rate of consumption near the trench, there will be expansion of sea floor. Like Atlantic Ocean, it is expanding continuously, right? Then earthquake. So shallow focus earthquake near mid-oceanic ridge. So there is, we can say that deep focus earthquake, that means convergent plate boundary is there, or we can say that the crust is getting destroyed at the deeper level. All these observations has led to proposal of this sea floor spreading hypothesis by Harry Hess. Okay. So what is that proposal? Sea floor spreading. So there is continuous movement of magmatic currents in a cyclic manner, like this. Okay, mid-oceanic ridge regions are the regions where there is magma reaching to the Earth's surface, and thereafter when it is coming on the surface, it is getting solidified as ocean crust, but there is continuous force from the bottom. Because of that, it is getting divided into two parts. One is moving on this side, other is moving on this side. There is continuous process like this. And because of that, what is happening? This part is moving over the period of time. Why it is moving? Because the underneath magma current is moving in that direction. This magma, this is solid part, right? And it is being dragged by these substratum mantle, or we can say magma currents. Now when it is reaching to the continental plate, it is getting subducted. Why? Because oceanic plate is denser than the continental plate, and that's why it is getting subducted and it is getting consumed. When it reaches to about 100 km deep, automatically temperature increases, and that's why the crust is melted and it becomes part of that current now. This is how the magmatic currents are moving, or let's say convection currents. This theory was proposed by Arthur Holmes, and this theory supports seafloor spreading hypothesis as well as plate tectonic theory. Now, the limitation of this theory is that, of course, this theory only explains how the seafloor is working out. But what about different types of plate interactions and the other parts, like plate continental interaction? So that is not explained here. So that's why plate tectonic theory is important for the. So plate tectonic theory, it was given by Morgan Mackenzie in 1960s, and it is based on the concept of lithospheric plate. Now, what is lithosphere? Starting में हमने पढ़ा है crust plus upper mantle. According to this theory, The lithosphere is moving and not the continents. Okay? Continent is the landmass. But lithosphere includes both landmass, or we can say continent, as well as ocean floor. Okay, it will include both. And that's why certain plates will be completely continental, certain plates will be completely oceanic, certain plates will have both. Okay, so accordingly, now these plates are basically moving on the Earth's surface or freely floating on the Earth's surface above liquid asthenosphere. If you remember asthenosphere, lying just below lithosphere. स्ट्रक्चर हमने पढ़ा था जस्ट बिलो लिथोस्फेयर, तो उसके ऊपर ये फ्रीली फ्लोट कर रहा है. सो यू कैन इमेजिन अ सिंपल लेट्स से अ प्लेट that is filled with water, and if suppose let's say thermocol is there, different let's say sizes of thermocol, if you put on the plate in that liquid, it will simply float. Now the underlying convection current in the asthenosphere, their direction will decide the movement of or direction of these plates. Okay, underlying current. So accordingly, the plate are interacting with each other. There are major plates and minor plates also. Let's try to see the major plates. कितने हैं major plates? 7 major plates are there. कौन से हैं देखते हैं. So Eurasian plate is there, North American plate, South American plate, African plate, Pacific plate. कितने हो गए? 5 हो गए. Antarctic plate is there separately, and Indo-Australian plate. 7 plates. There are minor plates also. Minor plates are basically when the major plates are broken down, they form the minor plates. ठीक है, तो बड़े बड़े plates जो है वो broke हो चुके हैं. Like for example, you can see Pacific plate is broken here. There is Cocos plate and Nazca plate in between them. Cocos plate, North America, Pacific. South America, Pacific, Nazca plate, interaction leading to formation of Rockies, Andes, mountain ranges. Same, you can see that there is Arabian plate here, or Philippine plate is here. ठीक है? All right. Now, different types of plate boundaries. ठीक है? Different types of plate boundaries. हाँ. This is very important. So plates are interacting with each other. If they are moving towards each other, they will converge. That is called as convergent plate boundary. And convergent plate boundary is also called as destructive plate boundary. Why? Because the Earth's crust is getting destructed near the subduction zone, which is also called as Benioff zone. Right? So that is called as convergent plate boundary. You can see here subduction, destructive, trench, and volcanic activities is more common here. Now you tell me which type of lava will be erupted here. Yes? Acidic lava, convergent plate boundary. ठीक है? Then divergent plate. अच्छा, which type of earthquake will be there here? Shallow focus or deep focus?
Shallow.
अभी बताया मैंने. Convergent, deep focus. Because crust is reaching to much deeper levels. ठीक है, तो यहाँ पे क्या होगा? Deep focus earthquake up to even 700 किलोमीटर बोलते हैं. ठीक है, deep focus. And shallow focus earthquake कहाँ पे होंगे? Divergent में. तो divergent when they are moving away from each other. So mid oceanic ridge region जहाँ पर क्या हो रहा है? Divergence हो रहा है. And because of that there is formation of new crust. That is called as divergent plate boundary. Constructive formation of new crust, that's why constructive. Formation of ridge or rift. And yes, volcanic activity is there, but what type of volcanic activity? What type of volcanoes and lava? Basaltic lava. And shield volcanoes or simply a kind of silent eruption, flood provinces like Iceland. ठीक है, Iceland is located on mid-Atlantic ridge region. तो राइक जेनस पेनिनसुला बार बार न्यूज में रहता है, देखो, ठीक है. सो दिस इज नाउ इफ सपोज प्लेट्स आर नॉट मूविंग टुवर्ड्स ईच अदर और अवे, रादर दे आर पैरेलल to each other or sliding past each other, they form the transform boundary, parallel. Okay, so this is kind of conservative, that is no destruction, no formation, जैसे थे ठीक position, तो conservative. So no major effect in terms of, we can say, topography. Yes, it will not result into formation or volcanic eruption. Why? Because it is not creating any weak zone. ठीक है, यहाँ पे कोई वीक जोन तैयार नहीं हो रहा है जो वोल्केनो मैग्मा ऊपर आए. हाँ, यहाँ पे अर्थक्वेक होता है ऑफ कोर्स, ठीक है. रादर ये बहुत एक्टिव होती है, क्या बोलते हैं, बाउंड्री. लाइक फॉर एग्जांपल सैन एंड्रियास फॉल्ट. तो सैन एंड्रियास फॉल्ट जो है वो आपका नॉर्थ अमेरिकन प्लेट और कोकोस प्लेट, यहाँ पे ये देखिए लिखा भी है सैन एंड्रियास फॉल्ट, यहाँ पर कैलिफोर्निया एंड दैट रीजन जो है, ठीक है. इस पे ऊपर मूवी भी बना हुआ है. ये कोकोस प्लेट और नॉर्थ अमेरिकन प्लेट उनके इंटरेक्शन में हो रहा है एंड दे आर इंटरेक्टिंग लाइक दिस. यहाँ पे इसीलिए क्या लिखा है देखो, ये दिस इज ऑल्सो अ काइंड ऑफ लेट्स से, देखिए ट्रांसफॉर्म बाउंड्री. ट्रांसफॉर्म बाउंड्री इज शोन इन द लाइन. ये देखिए ट्रांसफॉर्म बाउंड्री, दिस इज कॉन्वर्जेंट प्लेट बाउंड्री एंड दिस इज डाइवर्जेंट प्लेट बाउंड्री, ये जो दिखाई हुई है. ओके, नाउ विद इन डाइवर्जेंट प्लेट बाउंड्री ऑल्सो देर आर ट्रांसफॉर्म फॉल्ट्स फॉर्म विद इन डाइवर्जेंट प्लेट बाउंड्री, वेयर in mid-oceanic ridge region. Pay attention here. Let's imagine this is the mid-oceanic ridge region, right? Mid-oceanic ridge or mid-Atlantic region. Mid-Atlantic. Now, whatever the volcanic eruption is happening or formation of new crust is happening, it is not uniform all along the mid-oceanic. Rate of formation is different at different locations. Suppose here it is very high rate of formation of crust and the underlying currents are very fast, suppose. So there will be movement of this and this. There is differential movement. There is differential movement of this part in this direction, this part in this direction. And that result into formation of transform boundary between this crust and this crust. Because they are moving parallel to each other, no? They are moving parallel to each other. Because of differential rate of movement, they form the transform fault. Boundary नहीं बोलेंगे इसको हम. Boundary is between plates, but fault is between rocks. Fault is between rocks. तो ट्रांसफॉर्म फॉल्ट क्यों तैयार हो रहा है? बिकॉज ऑफ डिफरेंशियल रेट ऑफ मूवमेंट, बट दे आर मूविंग इन सेम डायरेक्शन और अपोजिट बट पैरेलल टू ईच अदर. दैट्स व्हाई ट्रांसफॉर्म फॉल्ट्स आर फॉर्म. तो अगर क्वेश्चन आता है तो आपको पता होना चाहिए कि डाइवर्जेंट प्लेट बाउंड्री के विद इन देयर आर सेवरल ट्रांसफॉर्म फॉल्ट्स फॉर्म. अगर यूनिफॉर्म रेट होता तो ये ऐसे नहीं दिखाते ना, सिर्फ एक लाइन ड्रॉ करते हैं ऐसे. ऐसे अनइवन क्यों दिखाया है ये? दे हैव शोन इट अनइवन, राइट? आगे पीछे आगे पीछे, बिकॉज ऑफ डिफरेंशियल रेट ऑफ मूवमेंट. ओके, नाउ नेक्स्ट. Within convergent plate boundary, there are 3 types of convergences. ठीक है, कौन से हैं? ocean ocean convergence, continent ocean convergence, continent continent convergence, right? Ocean ocean convergence is very important. In 2014 there was question in mains, formation of Indonesian archipelago and that Japanese island arc, ऐसा क्वेश्चन था, Philippine islands and Indonesian islands. So it is formed because of ocean ocean convergence. There can be question on match the following: ocean ocean convergence and the landforms or the mountain range, they will ask. So ocean ocean convergence means when the tectonic plates having the oceanic crust, they are converging with each other. That is ocean ocean convergence. Not necessarily it will be complete oceanic plate. Partly oceanic, partly continental can be also interacting with other oceanic plate. For example, yes, formation of Japanese island arc, interaction of Eurasian plate with Pacific plate. Okay, so Eurasian plate, its frontier is oceanic crust. Okay, so that oceanic crust is interacting with the oceanic Pacific plate, and that result into formation of island arcs. So whenever the ocean ocean convergence is happening, there will be formation of island arc or island archipelago. Examples: Caribbean islands, Japanese islands, Philippine islands, Indonesian islands. ये सारे एग्जाम्पल है ओशन ओशन कन्वर्जेंस. ठीक है, एग्जाम्पल दिया हुआ है. Thereafter, ocean continent convergence, Pacific plate, North American and South American plate. Ocean continent convergence, क्या हो रहा है वहां पे? Oceanic is denser one, it will subduct under continental, and when it subducts, what happens? Look at this. At deeper level there will be melting. Melting will result into formation of magma. Along with that there will be gases also, and under the pressure that gases will try to escape. Whenever there is weak zone, gases along with magma will try to reach up on the continental plate. कहाँ पे हो रहा है ये? Continental plate, and that's why on the margin of continental plate there will be formation of volcanic mountain range. There will be formation of volcanic mountain range like Rockies and Andes. Okay, part of Pacific Ring of Fire. So that is, we can say ocean continent convergence. Then continent continent convergence. कौन से continent continent convergence हो रहे हैं? Like Eurasia and Africa, or Eurasia and Indian plate. Continent continent convergence. अब यहाँ पे क्या हो रहा है? फोल्ड माउंटेन्स तैयार हो रहा है. देयर इज फॉर्मेशन ऑफ फोल्ड माउंटेन्स, एंड दीज फोल्ड माउंटेन्स आर रिजल्ट ऑफ folding of sediments of geosyncline present between these plates. Okay, when these plates are trying to move towards each other, whatever the sediments that are present between these two plates, if they are of sufficient size and thickness, they will get folded and there will be formation of parallel mountain ranges like Himalayas and Alps. तो ये हो गया आपका कॉन्टिनेंट कॉन्टिनेंट कन्वर्जेंस. ठीक है, ओके. देन हाँ, यस, ठीक है. तो फोल्ड माउंटेन्स जो है हमेशा कन्वर्जेंस पे होगा, और फॉल्ट माउंटेन नहीं, ब्लॉक माउंटेन्स. ब्लॉक माउंटेन्स जो है हाँ फॉल्ट एरिया में,
मतलब कन्वर्जेंस पे फोल्ड के अलावा नहीं माउंटेन
फोल्ड ही बनेंगे. ठीक है, माउंटेन फोल्ड ही बनेंगे कन्वर्जेंस में. यस, ठीक है.
कन्वर्जेंस में से ओवरलैप भी तो हो सकता है ऐसे, तो वो तो ब्लॉक माउंटेन हो जाएगा.
नहीं, ब्लॉक इज नॉट ओवरलैप. ब्लॉक इज फॉर्म बिकॉज लेट्स से मैं आपको एक बताता हूँ. जैसे ये लैंडफॉर्म है, और लैंडफॉर्म अगर ये जो है एक दूसरे से दूर जा रहा है, ठीक है, अगर ये एक दूसरे से दूर जा रहा है तो व्हाट हैपेंस इज इसके बीच वाले जो जमीन है वो नीचे धंसे. ठीक है, और ये ऊपर रह गए दोनों एजेस, तो वहां पे ग्रैबन एंड हॉर्स टाइप ऑफ टोपोग्राफी तैयार होता है। ठीक है, जैसे नर्मदा वैली और विंध्यास तैयार हुआ है when Indian plate subducted under Eurasian plate, that resulted into faulting phenomenon there. How tsunamis are formed? Yes, first of all the causes of tsunamis. ठीक है, सुनामी वेव्स, इस बार का पंचसूत्रा दिया है आपने, पंचसूत्रा टेस्ट, उसमें एक टर्म पूछा था हमने, मेटियो सुनामी। ठीक है, तो एक थोड़ा सा एडवांस लेवल पे जाके पूछा था, हाउ सुनामी आर फॉर्म, बट सुनामीज आर बेसिकली हार्बर वेव्स, राइट, जापानीज वर्ड है सुनामी, हार्बर वेव्स। नाउ लेट्स ट्राई टू अंडरस्टैंड द कॉजेस। फर्स्ट ऑफ ऑल, we know that when there is earthquake on ocean floor, when there is earthquake happening on ocean floor, major reason for tsunami. Second, large landslide happening in the ocean floor. Let's say along the continental slope, there is a huge landslide happening. So that also result into volcanic eruption on the ocean floor. Okay, volcanic eruption on the ocean floor, that also result into meteor impact. These are the 4 major reasons. ठीक है, अब अलग टाइप के भी सुनामीज होते हैं, जैसे मेटियो सुनामी जो हमने पूछा था क्वेश्चन, meteor tsunamis are basically caused because of meteorological factors. Excuse me. Storms, cyclones, or low pressure depressions. Because of that, when the waves and their amplitude height is very high, तो वो होते हैं मेटियो सुनामीज. And if they are happening because of extraterrestrial bodies and their impact, like meteors, they are called as extraterrestrial tsunamis. ठीक है, tsunami. Now how it is happening? When there is earthquake on the ocean floor, when there is earthquake on the ocean floor, let's say this is the earthquake, there is a convergence happening there and earthquake हो रहा है, समझे यहाँ पे 2004 earthquake, Sunda shelf or Sunda let's say trench, ठीक है, Indian Ocean region, तो ये trench region पे earthquake हो रहा है. Now there will be release of energy in the form of earthquake waves, and that energy is basically gained by the water above it. When these let's say energy waves are reaching on the surface, now they are transferring that energy to the ocean water. Now that ocean water is going to get displaced above that epicenter. Okay, when it is displaced, it is going to create a ripple, because that needs to be dissipated somewhere, energy, and it is dissipated always at the coastal areas, because oceans are a like container, no? They are the depressions on the earth surface. The container पानी का, तो सेंटर पे आप कुछ भी डालिए, रिपल्स कहाँ पे एंड होते हैं? तो वैसे कोस्टल एरिया पे वो डिसिपेट करेगा एनर्जी, राइट? सो दैट विल ट्राई टू मूव टुवर्ड्स, नाउ इट विल ऑल्सो ट्राई टू मूव in this direction also, that is towards the interior of the ocean, and the one will try to move towards the coastal areas. Now problem is with these, one that is moving towards the coastal area, and now when they are in deep waters, two qualities you should remember. One is speed. Deep water, speed is high, amplitude is लो, amplitude or height, low height, and because of that they are not observed in the deep waters. That's why let's say ships which are in deep waters, they are not, let's say, getting harmed because of tsunami waves.
Submarines and also.
Yes, they are not able to observe also many a times. Okay, but as they are reaching towards the coast, the speed reduces, but their height increases. Okay, height increases. So when it is, look at this, its height or amplitude is increasing as it is moving towards the. So unique characteristics of the tsunami waves, when they are reaching here, the water recedes to the interior, to the much, let's say, deeper level, and suddenly it will splash down on the coastal areas, all that huge amount of water. ठीक है, तो of course it is a release of energy, no? So it will try to release that energy in terms of that huge amount of water reaching to the upper heights in the coastal area. वो वापस भी चला जाएगा अगर उसको नेचुरल पाथ है तो, बट हमने घर बांध के रखे हैं ना कोस्टल एरिया में, रास्ते बांध के रखे, तो वो फ्लड कर देगा. ठीक है, वो डिजास्टर अब बन रहा है, पहले से ही सुनामी होते रहे. ठीक है, अब वो डिजास्टर बन रहा है, क्यों? कि ह्यूमन हैबिटेशंस है, राइट. सो दिस इज द मेथोडोलॉजी, वी कैन से एक्टिवेशन, बिल्ड, फॉर्मेशन, अप्रोच, इम्पैक्ट. ये मेंस में काम आएगा आपको, इतना जरूरी नहीं है इसमें. ठीक है, लैंडफॉर्म्स. ठीक है, एनसीईआरटी का सबसे बड़ा चैप्टर जिसको हम बोलते हैं. चीजें याद रखने के लिए अगर देखोगे, जो फिजिकल ज्योग्राफी में यही एक चैप्टर है जो लास्ट मिनट रिवीजन करना चाहिए. बाकी तो कॉन्सेप्ट है ना सारा, बट इसमें तो इतने सारे लैंडफॉर्म्स लिखे हैं कि नाम याद रखना मुश्किल है. जैसे इस बार हमने पंचसूत्रा में आपको ग्लेशियल लैंडफॉर्म्स पूछे थे और उसमें प्लाया लिखा था एक. ठीक है, तो वो हाँ विंड लैंडफॉर्म है, विंड जनरेटेड लैंडफॉर्म प्लाया, बट अदर आर ग्लेशियल. वो ऐसे क्वेश्चन आता है ऑड वन आउट और मैच द फॉलोइंग. एजेंट ऑफ इरोजन लैंडफॉर्म, डिपोजिशनल, इरोजनल, 3 कॉलम, ऐसा भी आ सकता है अभी. ठीक है, तो अच्छा है इस साल आ सकता है. फिर यही तो है, आपको जरूर पूछा नहीं है, बहुत साल से पूछा नहीं है, बट वन वे और अदर वे दे विल ट्राई टू इंक्लूड दीज थिंग्स. जैसे अप्लाइड क्वेश्चन पूछना, हाँ मेंस में पूछेंगे. लास्ट फ्यॉर्ड्स पूछा है. ठीक है, तो कई अलग अलग वे से कुछ ना कुछ लाते रहते हैं वो. ठीक है, समझो उन्होंने कंडीशंस फॉर फॉर्मेशन ऑफ डेल्टास पूछ लिया, तो वो तो लैंडफॉर्म है ना. डेल्टा कैसे तैयार हो रहा है, वाटरफॉल कैसे तैयार हो रहा है. ठीक है, तो अगर उससे रिलेटेड क्वेश्चन आता है मतलब वो लैंडफॉर्म है. ओके, फर्स्ट ऑफ ऑल फ्लूवियल लैंडफॉर्म्स और रनिंग वाटर स्ट्रीम्स. लेट्स टॉक अबाउट फर्स्ट इरोजनल लैंडफॉर्म्स. V-shaped valley, gorge and canyon, they are the variants, V-shaped valleys. Okay, so when we learn about, quickly we'll learn about this thing also. There are 3 types of erosions carried out by rivers. PGP में हमने पढ़ाया हुआ है अभी, हेडवर्ड इरोजन, vertical erosion, three types of erosion carried out by river streams. Headward erosion, so it is carried out near the source of river. Headward erosion. ठीक है, तो headward erosion कैसे होता है? Let's say this is a kind of hill. Generally streams का origin hilly areas में होता है. ठीक है, अब क्या हो रहा है देखिए, यहाँ पे बारिश हो रहा है तो पानी जो है यहाँ पे परकुलेट होके अंडरग्राउंड फ्लो होता है. ओके, इट इज फ्लोइंग एज अ सबसर्फेस फ्लो, राइट? बट there will be some kind of, let's say, obstruction to that subsurface flow because of presence of hard rock here. Presence of hard rock. When there is a presence of hard rock, the subsurface flow will try to come out. ये क्या करेगा? अब हम अंदर बोर हो गए, अब बाहर आते हैं, चलो, तो यहां से क्या आएगा? बाहर आएगा, क्योंकि इसको ऑब्स्ट्रक्शन है अंदर से फ्लो करने के लिए. पानी की तासीर होती है बहते जाना, ठीक है? तो ये क्या है? रुकेगा नहीं जब तक उसको ग्रेविटेशनल फोर्स है या फिर स्लोप है, ग्रेडियंट है, वो बहते जाएगा, राइट? सो यहां पे उसको स्कोप मिल रहा है बाहर आने का. इट इज कमिंग आउट. बेसिकली सोर्स ऑफ रिवर इज दिस पॉइंट. सोर्स ऑफ एनी रिवर इज दिस पॉइंट. तो गौमुख और वो सब होता है ना, मंदिर होता है वहां पे और सब चीजें, तो पानी सब सरफेस से बाहर आ रहा है वहां से. अब नेक्स्ट टाइम कहीं भी आप विजिट करोगे, गंगोत्री, यमुनोत्री या कहीं पे भी, त्र्यंबकेश्वर महाराष्ट्र में, तो आप देखोगे पानी जो है गौमुख से बाहर आ रहा है. इसका मतलब क्या है? अंदर से फ्लो होते हुए आ रहा है ऊपर से, ठीक है? तो ये सब सरफेस फ्लो है. बिकॉज ऑफ हार्ड रॉक इट इज कमिंग आउट एंड दैट इज सोर्स ऑफ रिवर. नाउ व्हाट हैपेंस इज, when that water is coming out here, this water has now tendency to come out earlier. Why? Because it is also bringing some sediments and they are deposited here. Next time it will try to come out above that sediment by eroding the upper surface of that source. Headward इसीलिए बोला गया है, head उसको इरोड करते जा रहा है. अगेन नेक्स्ट टाइम इट विल कम आउट हियर, नेक्स्ट टाइम इट विल कम आउट हियर. इट इज हैपनिंग ओवर थाउजेंड्स ऑफ ईयर्स. ऐसा नहीं कि 1-2 साल में हो रहा है, ठीक है? तो शायद थाउजेंड्स ऑफ ईयर्स में गौमुख चेंज होगा, ऊपर जाएगा जहां से पानी बाहर आ रहा है, ठीक है? तो इसी इट इज कॉल्ड एज हेडवर्ड इरोजन. अंडरस्टूड हाउ इट इज हैपनिंग, ठीक है? सोर्स ऑफ रिवर. सेकेंड इज वर्टिकल इरोजन. Vertical erosion is because of, we can say, steep gradient that is present. A steep gradient will result into more kinetic energy of that water, and that will result into erosion of stream bed, ठीक है? river bed, okay, and that will result into vertical erosion. Now let's imagine a Himalayan river. So when it is flowing through that mountain ranges, there is steep gradient. When there is steep gradient, the water tries to move downward, and along with that it will carry huge rocks, boulders, and they will move along the river bed. They will carry out certain kind of abrasion activity continuously, ठीक है? abrasion एक दूसरे के साथ भी और रिवर बेड के साथ में से प्लकिंग करते हैं. abrasion and plucking, this is continuous process, and that result into valley deepening. तो vertical erosion result into valley deepening. This result into, imagine the following question है, देखिए, this result into valley lengthening, this result into valley deepening, and lastly lateral erosion. Lateral means banks. When river erodes its banks, it is lateral erosion, and that is more prominent in the middle and old age, we can say lower courses, where it is now the slope is very low, gradient is very slow. तो वहां पे क्या हो रहा है? ये lateral erode करेगा, यानी कि यहाँ पर वैली जो है, earlier it was V-shaped valley, it is going to change like this. So it is widening the valley. It is widening the valley. तो इससे क्या हो रहा है? Valley widening. ठीक है, याद रहेगा ये 3. Okay, let's talk about the landforms. So V-shaped valleys, yes, it is common feature, erosional feature, and variant of V-shaped valley, gorge and canyon. उसमें difference क्या है दोनों में? You can see here photograph. Steep sides, that means single hard rock. ठीक है? Single hard rock. It is not easily eroded. Both side. Hard rock. So that's why water is trying to follow the narrow path. Canyon, यहाँ पे देखिए, यहाँ पे क्या हो रहा है? ऊपर की तरफ सॉफ्ट रॉक है एंड दैट्स व्हाई देयर इज मोर इरोजन. नीचे की तरफ हार्ड रॉक है तो यहाँ पे इरोड नहीं हो पा रहा है. दिस इज हाउ कैनियन इज फॉर्म. सो सॉफ्ट रॉक इज लाइंग अबव द हार्ड रॉक. सॉफ्ट रॉक इज लाइंग अबव द हार्ड रॉक. ठीक है, याद रहेगा ये. ओके, नेक्स्ट इज पॉटहोल्स एंड प्लंज पुल्स एंड वाटरफॉल. ठीक है, पॉटहोल्स एंड प्लंज पुल्स एंड पॉटहोल्स क्या होता है? रैपिड्स एंड पॉटहोल्स. So they are again youthful stage features. Rapids are when simply we can say steep gradient is there and the stream water is moving in a very fast manner, and rapids are observed when the water is simply falling from one stone to other stone like this. अब यहाँ पे क्या होगा? ये पानी जो फ्लो हो रहा है ना, उसे कूदने की कोशिश करेगा यहाँ पे, है ना. यहाँ पे क्या होता है? पानी ऐसे कूदता है. व्हाइट कलर का जो पानी दिखता है ना ऐसे यहां से, दैट इज रैपिड. ओके, दैट इज रैपिड. वो अपर स्ट्रीम्स में दिखाई देता है यूथफुल स्टेज में. देन व्हाट आर प्लंज पूल्स? सो फर्स्ट बिफोर दैट लेट्स अंडरस्टैंड द वाटरफॉल. हाउ वाटरफॉल इज फॉर्म? व्हेन हार्ड रॉक इज लाइंग अबव द सॉफ्ट. Okay, when hard rock is lying above the soft rock, let's say the stream is moving like this, so it is not able to erode that hard rock, but let's say when it is falling down, it will try to erode this soft rock like this. अब ये soft rock को erode कर देगा पूरा, तो ये पूरा खाली हो जाएगा. अब पानी पूरा नीचे गिरेगा ऐसे. ठीक है, तो ये जो था ये सॉफ्ट रॉक था, ऊपर का ये हार्ड रॉक है, तो ये इरोड नहीं हो रहा है, तो इसलिए ये वाला इरोड हो गया यहां से. ओके, सो दीज आर द वाटरफॉल्स. ये याद रखना है. ठीक है, कैनियन में क्या था? सॉफ्ट रॉक लाइंग अबव द हार्ड रॉक. वाटरफॉल में क्या है? हार्ड रॉक लाइंग अबव द सॉफ्ट रॉक. नाउ व्हेन द वाटर इज फॉलिंग डाउन विथ सच ह्यूज फोर्स, देयर विल बी फॉर्मेशन ऑफ अ काइंड ऑफ पूल beneath that water. This is called as plunge pool. It will have large boulders carried by that water, and there will be whirl movement of that water, and that boulders are continuously eroding and creating a depression. खड्डा तैयार कर देते हैं बहुत बड़ा. तो वो प्लंज पूल है. हर वाटरफॉल के बेस पे एक पूल होता है, उसको प्लंज पूल बोलते हैं. ठीक है, ओके. देन इंसाइज्ड और एंट्रेंच्ड मियांडर्स. अब एनसीईआरटी में ये मेंशन तो है बट एक्सप्लेन नहीं किया है ठीक से. ठीक है, मियांडर्स क्या होता है? मियांडर्स आर बेसिकली चैनल्स ऑफ रिवर्स, बट दीज आर वेवी. ओके, दैट्स व्हाई द मियांडर. वेवी मीन्स व्हाट? its direction is not fixed and that's why it is continuously changing its direction. That's why meandering बोलता है. दारू पिया हुआ जो इंसान होता है वो कैसे meander करता है. तो रिवर उसका डायरेक्शन फिक्स नहीं है. ठीक है, तो इंसाइज्ड और एंट्रेंच्ड मियांडर. ठीक है, बट मियांडर और इनमें डिफरेंस क्या है, एंट्रेंच और इंसाइज में? लेट्स ट्राई टू अंडरस्टैंड. फॉर दैट one concept is there, rejuvenation. Although it is more of a geography optional concept, but to explain that concept, entrench or incise, ये आपको समझना है. So river undergoes through, we can say that, 3 stages. अगर हम कंसिडर करते हैं तो लेट्स कॉल इट एज दिस वन यूथफुल, दिस वन वी कैन से मैच्योर एंड देन ओल्ड एज स्टेज and old age. Okay, so generally the erosional features are observed here in youthful stage and depositional features are there in mature and old stage. So all these meanders, they are observed here in mature and old stage. Okay, meanders are observed in mature and old stage. Now what happens is we learn about the epirogenic movements. epirogenic में क्या हो रहा था? ऊपर भी जा रहा था, नीचे भी जा रहा था. No, because of that epirogenic movement or tectonic forces, let's say this particular area is uplifted. Okay, this particular area is, let's say, uplifted like this. Basically now it looks like this. Now what happened here is when the water was moving here and it was a kind of mature stage, suddenly here there is gradient created. Suddenly there is gradient created and it is regaining its youthful stage here. ये मैच्योर में था पहले, अचानक से अब ये यूथफुल स्टेज में आ गई है रिवर. And because of that youthful stage and increased vigor for vertical erosion now. यहाँ पे अब dominant क्या था पहले? Lateral erosion, mature and old stage में lateral erosion dominant. Now it is resulting into more vertical erosion. So whatever the meanders were present here, they will be deepened. Where? They will be deepened. कहाँ पे डीपन हो गए? ये देखिए, ये रिवर ऐसे फ्लो हो रहा है, राइट? अब रिवर जब मेंडर में ऐसे फ्लो होता है, वेयर वी हैव एक्टिव इरोजन अलोंग द कॉनकेव फेस एंड एक्टिव डिपोजिशन अलोंग द कॉन्वेक्स फेस. So when there is increased vigor, there will be more erosion along this concave. जो भी वहां पर मिएंडर बना हुआ है, अब वो क्या होगा? इंसाइज होगा और एंट्रेंच होगा. इंसाइज में वर्टिकल कटिंग ज्यादा होता है, एंट्रेंच में ये और ज्यादा कर्व हो जाएगा. ठीक है. हाँ.
Regarding the process, the upliftment will be gradual. So why does the river not erode through the uplifted part rather than it results in the?
Yes, it is a simultaneous phenomenon. जैसे अपलिफ्ट धीरे धीरे हो रहा है.
Go back to the diagram once again. So that upliftment that has taken place over a period of time.
Yes.
So why has not the river eroded through the uplifted portion over that period?
Yes, it is eroding. Of course, whenever, let's say, slowly it is uplifting, and slowly the vigor is also increasing, and that's why it is, we can say, further doing the vertical erosion. ठीक है. अब suddenly increase होके बाद में erosion नहीं हो रहा है. It is a simultaneous process. ऐसा समझना है इसको. ठीक है.
But in that case, it will not result in change of gradient as it is shown.
River is a small portion on that land surface. Land surface is huge area. ऐसे समझा है हमें. ठीक है. ये समझो ये पूरे रूम लैंड सरफेस है. रिवर इज स्मॉल एरिया. ठीक है. तो yes, meandering will be done by river and the upliftment will bring changes in that river valley only. Okay, बाकी लैंड में थोड़ी चेंज कर रहा है कुछ भी.
So there is no such condition that only the hard rock is there, only then it will be in a better way.
वैसा कुछ नहीं है. Of course, what happens is if suppose the upliftment is quite sudden, there will be nick points created here. These are called as nick points. And river stream will directly fall down here because it is not having time to erode that slope. उनको nick waterfalls बोलता है. हुंदरू फॉल्स जो क्वेश्चन आया था प्रीलिम्स में 2 साल पहले, लास्ट ईयर ही आया था शायद, हुंद्रू फॉल्स वाटरफॉल पे जो क्वेश्चन था 3 कॉलम्स वाला, कहां पर है हुंद्रू फॉल्स? झारखंड में। अभी पिछले साल क्वेश्चन आया है 24 में, 3 कॉलम थे, सुवर्णरेखा रिवर, हुंद्रू फॉल्स, झारखंड, ऐसे कुछ तो 3 मेंशन किए थे। पिछले साल ही क्वेश्चन है 3 कॉलम वाला, ठीक है। जोग फॉल्स भी एक था उसमें, ठीक है। तो वो क्या है, एग्जाम्पल ऑफ निक फॉल है, ठीक है। वहां पे रिजुवेनेट हुए हैं, रिजुवेनेशन काफी एक्टिव है वहां पे उस एरिया में। डोंट वरी अबाउट दीज टर्मिनोलॉजीज, ये ऑप्शनल सब्जेक्ट का है, ठीक है। व्हाट आई वांटेड टू एक्सप्लेन इज दिस टर्म, दिस लैंडफॉर्म, हाउ दे आर फॉर्म। दे आर फॉर्म बिकॉज ऑफ renewed vigor to cut vertically in the mature and old stage of the river। इतना समझ सकते हैं? तो इसलिए वो क्या होगा, एंट्रेंच होगा और इंसाइज होगा, ऐसे याद। नाउ अगेन वन मोर इंपॉर्टेंट फीचर इज रिवर टेरेसेस, दे आर ऑल्सो रिजल्ट ऑफ रिजुवेनेशन, ठीक है। ये एनसीईआरटी में नहीं है ना एक्सप्लेन, सिर्फ मेंशन किया है ना रिवर टेरेसेस। दिस डायग्राम इज देयर इन एनसीईआरटी, river terraces, but how they are formed, river terraces, let's try to understand here in this diagram only. So when the river is entering into mature stage, अब ये तो ऐसा क्रॉस सेक्शन है, समझो हम ऐसे क्रॉस सेक्शन लेते हैं रिवर का, इस तरीके से, okay। Now if this is the mature stage, now if suppose suddenly there is rejuvenation, what will happen? There will be vertical erosion, and over the period of time there will be deepening of valley. There will be deepening of valley, and because of that what will happen? Now the water channel is much deeper, but over the period of time the amount of water has not changed. Amount of water has not changed, ना, तो पानी तो उतना ही जाएगा, तो पानी का लेवल इतना हो जाता है लीन टाइम पीरियड में। तो यहाँ पे ऐसे टेरेस तैयार होता है, पहले का ये टेरेस हो, ठीक है, तो ये अभी नया टेरेस तैयार हो गया। जितनी बार रिजुवेनेट होगा, द नंबर ऑफ टाइम्स इट विल बी रिजुवेनेटेड, देयर विल बी फॉर्मेशन ऑफ सच काइंड ऑफ पेयर्स ऑफ टेरेसेस, ठीक है। तो वो हो गया आपका रिवर टेरेसेस। Then we have depositional features. Alluvial fans, so they are formed at the base of, we can say, mountains, hills, when the river is entering into plains. So large boulders, rocks, they are deposited there, creating a kind of fan-like structure like this. Okay, and then the river water is moving ahead with the finer sediments. Large boulders and rocks, they are deposited here only. ठीक है, मतलब रिवर पहले क्या है ना कि बहुत ही छोटे स्पेस से मूव कर रही थी, यहाँ पे आके अब बहुत स्पेस है नीचे प्लेन में, तो वो फैल रही है अभी। यहाँ पे देखो, ऊपर से कहाँ पे आ रही थी, नैरो वैली से आ रही थी, तो कहीं पे भी देखिए, यस। So when the river is entering into plains, जैसे हरिद्वार के यहाँ पे एंटर कर रही है प्लेन्स में गंगा, so वहाँ पे भी आप देखिए एकदम वाइड हो जाता है सब कुछ, तो वहाँ पे बहुत बड़े बड़े बोल्डर्स है, इतने बड़े बोल्डर्स है, लगता है ये रिवर कैसे ला सकता है। पहले हाँ वही, बिल्कुल बिल्कुल, ठीक है, यस। सो दैट इज कॉल्ड एज alluvial fans. Then deltas, of course, they are near the mouth of the river when the river is draining into ocean. Delta formation, right? Quickly, we'll have a look at factors which help in formation of deltas. ठीक है, delta formation, suitable factors. It is given in GC Leong, right? First, huge sediment load brought by the river, so that requires very long stretch or huge water amount, or we can say that the erosional capacity of the river. So that's why it will bring the sediment load that is deposited near the mouth. Then shallow coast. So near the coast, the gradient should be minimal or zero, so that the water is depositing whatever it has carried. So that will result into delta formation. अगर वहां पे slope है तो वो चला जाएगा ocean में. Sheltered coast. Sheltered coast means the tidal effect is less. ठीक है, sheltered coast. So high tide, low tides, if there are, let's say, very high tide, they will carry all that sediment into the ocean. Then no presence of strong ocean current flowing along the coast. Otherwise, it will remove those sediments. ठीक है. Then absence of large lake along river course. Otherwise, river will deposit all the sediments there near the lake. Lake acts as a temporary base level. तो वहाँ पे deposit कर देगा. That's why we don't want such kind of lake along its course. These are the favorable conditions for formation of delta. All right. This can be asked in the prelims. Then next is floodplains, natural levees and point bars. ठीक है, तो quickly we'll see this one. Floodplains, natural levees and point bars. ये landforms chapter complete करते हैं, उसके बाद शायद climatology है तो we'll have lunch break. ठीक है, quickly we'll cover this. Floodplains, natural levees and point bars. So it is very simple. Floodplains are basically the area where the flood water is reaching. ठीक है, तो उनको flood plains बोलते हैं, and of course there is deposition of the sediments, finer sediments through that flood plains. They are fertile plains. Natural levees and point bars. You can see here natural levees are the formations along the banks on both sides. But the point bars are generally found in the convex side. ये क्या है? Point bars है. The huge depositions happens along the convex side that result into formation of point bars. But natural levees are kind of natural, let's say, barrier created for the water channel so that it will not spilling over. ठीक है, और वो अपने आप ही रिवर तैयार करती है थ्रू कंटिन्यूअस डिपोजिशन. ठीक है, डिपॉजिट कर रहा है ना, ओवरफ्लो कर रहा है, डिपॉजिट कर रहा है, ओवरफ्लो कर रहा है, डिपॉजिट कर रहा है, तो उससे क्या हो रहा है? एक नेचुरल चैनल तैयार हो रहा है अपने आप. Okay, so that is natural levees. Okay, fine. Now, Oxbow Lake. Okay, Oxbow Lake is there. So what are Oxbow lakes? एक क्वेश्चन आया था 2023 में. कन्वर लेक. ऑक्सबो लेक जो है बुरी गंडक रिवर ने तैयार किया हुआ. ओके, तो बहुत जगह पे वो गंडक लिखा हुआ है. यूपीएससी ने दिया है क्या आंसर की उसका? क्या दिया है?
It was not Gandhar, it was Budi. तो statement was wrong.
हाँ, रॉन्ग था ना. बहुत सारे कोचिंग ने उसको सही दिया हुआ था. हमने डिस्कशन में बताया था वो बुरी गंडक है, क्योंकि ये इंटरनेट पे सर्च करो आप, वो गंडक रिवर देता है. बट एक रिसर्च पेपर में हमने देखा था, वो उन्होंने मैप के साथ बुरी गंडक दिखाया था. ठीक है. यस. नाउ ऑक्सबो लेक. What happens is when there is severe meandering of the river, severe meandering will result into small, we can say that areas wherein the water will try to jump from this location to this location instead of traveling the longer distance. है ना, कम डिस्टेंस जहां होगा वहां पानी फ्लो करेगा, लॉन्गर डिस्टेंस क्यों फॉलो करेगा. ठीक है, तो ये यहां से यहां जंप करने की कोशिश करेगा अगर वो क्लोज हो जाता है तो. दिस इज बेसिकली इन्फ्लेक्शन पॉइंट. एंड when we have such kind of, let's say, movement of water and there is cut off of this section, it will result into oxbow lake. That oxbow lake is having water and the water is supplied through annual flooding. जब annual flooding होता है तो ये पानी यहाँ पे चला जाता है. This is how these lakes have continuous water. In North Indian plains, several oxbow lakes are there. They are very productive wetlands. And many of them are declared as conservation reserves, community reserves. आप पढ़ रहे होंगे न्यूज़ में. ठीक है, तो वो होता है ऑक्सबो लेक्स. ठीक है, वेटलैंड्स की तरह एक्ट होते हैं. ऑल राइट. जैसे दीपोर बिल आसाम का न्यूज में रहता है, देखो, इट्स रामसार साइड. इट इज ऑल्सो अ काइंड ऑफ ऑक्सबो लेक. ओके, ग्राउंड वाटर, वेरी सिंपल, क्विकली विल कवर दिस. Right, groundwater is very active in areas where limestone rocks are there or dolomite is there, because it is easily dissolved in the water. Okay? So groundwater, when it is flowing on the surface of the earth, on those limestone pavements, so what happens? There is formation of sinkholes, first of all, on the surface of that limestone rocks. Right? So when it start dissolving, it will create some kind of sinkholes in different locations. When these sinkholes are connected to each other, there is kind of valley sink form. They are called as uvalas. It looks like this from the surface. Now, many times when these sinkholes are deeper enough, their bottom collapses and there will be collapse sink form here. This collapse sink is the area from where the water is entering into the, as a underground water, we can say, or groundwater. Surface water entering as a groundwater. यहाँ पे देखिए, ये collapse sink है और पानी यहाँ से अंदर आएगा. ठीक है, और ये exit होगा. And a cave is formed because of this underground formations. A cave always have opening and exit. Otherwise, it will not be called as cave. ठीक है, तो यहाँ पे देखिए, what happens is, now once it is coming as a groundwater inside the, let's say, earth surface, now there is no slope. Gradient कम हो गया है. Now there is more depositional aspect. The three important depositional features are there: stalactites, stalagmites, and pillars. So when this water is coming, some water will try to move along the terrace or roof. It will try to move along the roof and it will trickle down from that roof. When it is trickling down, many times the water gets evaporated and the dissolved content starts depositing as icicles, or simply we can say that stalactites. Okay. Now, if it is not evaporating, the water drops will fall down on the ground and on the ground it may get evaporated. On the ground, whatever the dissolved material is there, it is deposited as stalagmites. Now, it is happening one above the other, no? Upar or niche. If suppose it is growing from both sides and gets connected, that is now pillar. Okay. How to remember? G याद रखना है. G is from ground. Stalagmites. ठीक है? So that is the trick. Okay. So these are the, we can say, groundwater. Then glaciers. NCERT में डायग्राम और फोटोज ही ऐसे दिए हैं कि समझ में नहीं आता है कहाँ से ग्लेशियर मूव कर रहा है, क्या करे. ठीक है, कुछ स्टूडेंट्स पहले समझते होंगे कि ये इतना बड़ा ग्लेशियर आ रहा है. ठीक है, मतलब लग सकता है ऐसे. ठीक है. All right, first of all, the erosional landforms. You can see in the upper reaches of glacier. So glacier is very important agent of erosion, first of all. Why? Because of sheer mass of that glacier. Although it is not having kinetic energy, but because of huge mass, it is more, we can say, effective agent of erosion. ज़्यादा erode करता है as compared to rivers and wind. ठीक है, बाकी तो kinetic energy है, but इसको mass है, and because of that we can say it is more let's say effective. Now in the upper reaches you can see important, let's say, landforms. First of all, horn. Let's imagine that I am the mountain and there are 2 to 3 glaciers originating from this mountain but flowing in different direction. One glacier is moving in this direction, one glacier is moving in this direction, another glacier is moving in this direction. Now when these glaciers are moving like this, they are trying to erode and sharpen me as a mountain, and it will create a mountain peak here, pointed peak. That is called as horn. There are several horns, they are 8,000 plus in Himalayas and even in Alps. Like in Alps we have Matterhorn, or in Himalayas, in Alps we have Matterhorn, in Himalayas we have Mount Everest is there, or K2 is there, or Kanchenjunga. All 8,000 plus are horns, examples of horns. They are erosional features of glaciers. Now once they are moving down, let's say मैंने कहा था एक ग्लेशियर ऐसे जा रहा है, once it is moving down it will move like this, ठीक है, ऐसे हो जाएगा. तो जब ये यहां पहुंचता है ना, ये जो एरिया है, दिस इज कॉल्ड एज सर्क. दिस इज कॉल्ड एज सर्क. यहां पे देखिए, समझो यहां से ग्लेशियर आ रहा है और यहां से नीचे जा रहा है, ठीक है. सो दिस इज कॉल्ड एज सर्क. नाउ द रीजेस, जैसे हम देखते हैं रिवर्स के 2 वैलीज होते हैं और बीच में एक रिज होता है ना, दैट सेपरेट्स द वाटर चैनल्स. Similarly, if there is a ridge form here separating the two glaciers, यहां पे देखिए, this is called as arid. यहां से एक ग्लेशियर जाएगा, यहां से एक ग्लेशियर जाएगा, यहां से एक जाएगा. बेसिकली दैट इज द रिज. रिवर का 2 चैनल अलग अलग होता है ना, बीच में से एक माउंटेन रिज होता है, सेपरेट्स द वाटर चैनल. यहां पे ग्लेशियर्स को सेपरेट, that is called as arid. Okay, now there is mentioned coal. Coal is basically a kind of depression along the ridge. अब देखिए यहाँ पे क्या है, ये एक ऐसे जो ridge तैयार हो रही है, this is a kind of different ridge than this one. Why? Because glaciers from this side and from that side exactly opposite direction से जा रहे. But arid is this one. That means it is separating the glaciers from same side. Separating from same side. ये ग्लेशियर्स इसी साइड में जा रहे हैं ना, तो इनको सेपरेट करने वाला जो होगा वो एरिट होगा. यहां पे ध्यान दीजिए, ये दिखाया है ना, दिस इज एरिट. ओके, दिस इज कोल. Glaciers from that side and from this side, they are separated. Okay, they are opposite side now. All right, now truncated spurs. This was asked in optional subject actually last year. Truncated spurs, क्या होता है truncated spurs? ये NCERT में दिया हुआ है. Okay, there are concept of interlocked spurs. Have you visited let's say Himalayan region? Anyone? हाँ, तो मुझे बताइए, रिवर ऐसे सीधी फ्लो करती है क्या? वैली ऐसे सीधी नहीं होती है ना. रिवर always flow like this. Why? Because these mountains are like this, no? यहाँ पे ऐसे mountains है ना, ये, और ये वैली क्रिएट हो रही है. These mountains are creating these spurs. ये क्या है? ये spur है, ठीक है. ये क्या है? spur है. अब ये और ये इंटरलॉक हो गया, इसके बीच में से रिवर फ्लो हो रही है.
So what does spur mean?
Spur means a protruded landform. Spur means a protruded landform, especially in mountainous region, ठीक है, जहां पे रिवर वैली तैयार हुई है ना, that river valley is basically, the flow of river is obstructed because of protruded nature of that mountains. ऑब्स्ट्रक्ट करेगा वो, और इसलिए वो ऐसे ऐसे जा रही है. नाउ ट्राई टू इमेजिन दैट earlier this river is moving and suddenly there is ice age. ice age मूवी देखिए, मजा आता था बचपन में, ठीक है. सो आइस एज में क्या होता है, ग्लेशियर्स, पूरा ऑल आइस एंड ग्लेशियर्स. नाउ सपोज दिस वैली इज रिप्लेस्ड बाय वैली ऑफ ग्लेशियर. यहां पे ग्लेशियर तैयार हो जाता है. अब ग्लेशियर इज सो स्ट्रॉन्ग and huge mass, whatever it comes in its path, it is eroding that. River is not like that, no. River, ठीक है, आप नहीं जाने देंगे, हम इधर से चलेंगे, इधर से चलेंगे, ठीक है. But glacier is like पूरा erode करते हुए चलेगा. And now the newly formed glacier will move like this, and it will erode all the protruded parts. And now it will look like this. Look at this. ये पहले ऐसे प्रोट्रूडेड था आगे, ये यहां पे देखिए, दिस इन्वर्टेड वी वाला स्ट्रक्चर, ठीक है. दिस माइट हैव बीन अ प्रोट्रूडेड पार्ट, नाउ इट इज इरोडेड बाय दिस ग्लेशियर. ओके, प्लेन लगेगा अभी, वॉल लाइक. दिस इज कॉल्ड एज ट्रंकेटेड स्पर, ठीक है. ध्यान रखिएगा, मेंस में भी पूछ सकते हैं, तो इसलिए मैंने एक्सप्लेन कर दिया एनसीईआरटी में. नाउ आफ्टर दिस लेट्स से, ओके, यू शेप वैली ऑफ कोर्स एंड हैंगिंग वैलीज. ओके, सो यू शेप वैली इज इंपॉर्टेंट फीचर ऑफ ग्लेशियल वैलीज और ग्लेशिएटेड एरियाज. वी शेप वैली रिवर्स, यू शेप वैली glaciers. Now why U shape? Because of huge mass of the, and that creates a wall like structure, no, and mass creates a base, that's why U shape. Okay, but river is fluid, so that's why V shape, पानी ऐसे जा रहा है अंदर से. Okay, now hanging valleys, let's try to understand the way we have tributaries of rivers. Here also we have feeding glaciers to one large glacier. ठीक है, यहां पे देखिए, this is very large glacier coming like this, and there are feeding glaciers like this, small free. Large glacier is so large and huge in terms of mass that its erosion is not matched by these feeding glaciers. It has huge erosional capacity, so it is eroding its floor and making it much deeper, but that is not matched by the feeding glaciers, and that's why when they are reaching to the main glacier, it looks like simply it is falling down into the much deeper valley created by main glacier. That's why it looks like hanging valley. When the glaciers are receding back during summer, it looks like this, hanging valley. But ऐसा हम रिवर्स में देखते हैं क्या ट्रिब्यूटरीज में? नहीं, ट्रिब्यूटरी तो आ रही है, मिल रही है, ठीक है. This is called as hanging valleys. Hanging valleys feature of glaciated structure. Now depositional features. ओके, सो डिपोजिशनल फीचर्स में आप देखिए. ओके, सो फर्स्ट ऑफ ऑल moraines are unconsolidated, we can say, sediments brought by glaciers, right? And yes, of course, the glacier, when it is moving, it can bring those sediments along three areas or three ways, and that's why three types of moraines. One is lateral moraine, जो साइड से कट करते हुए लेके जा रहा है, that is lateral moraine. Second is, we can say that medial moraine. Medial moraine is because of the bottom erosion carried out by glacier, bottom erosion. And the ones which are deposited at the end of the glacier, they are called as terminal moraines. Terminal moraines, lateral moraines, medial moraines. ठीक है, थ्री टाइप्स ऑफ मोरेन्स. ठीक है, Then
And they happen only with the tributary glacier. I mean, tributary glacier, and not with the main glaciers.
which one?
Moraine.
Moraine? No.
It's
Main
part
glacier.
of-
No, largely the moraines are features of all glaciers. Okay, but depending on the carrying erosion capacity of glacier, the amount of deposition will be decided. Moraine formation is basically sediments. The amount of sediment brought, it is decided by the size of glacier, we can say that. Okay. Then other depositional features, iskers and drumlins. Okay, iskers are simply linear formations along the, we can say, direction of that outwash plains, or we can say when the glaciers are receding during summer, you can see such kind of features exposed. Okay, so iskers are linear depositions. लीनियर होता है, एक ही मतलब हाइट पे और एक ही, जैसे कि कूड़े का एक बना हुआ रहता है ना, जैसे उस तरीके से ये डिपोजिशंस का एक लीनियर फीचर बना हुआ रहता है. बियॉन्ड मोरेन्स वी आर टॉकिंग. ओके, बियॉन्ड मोरेन्स these features are found. Then drumlins, now it is having certain shape. drumlins का shape होता है, क्या होता है वो इस तरीके से, drumlins. And this is the direction of glaciers. Now why this is like, we can say, so glaciers are more active on this side, and when they are getting deposited, larger consolidated deposits are accumulated here, and the finer deposits are deposited much longer distances. Finer deposits. Okay, drumlins, direction ये याद रखना है इस तरीके से, ये सारे drumlins है देखिए. Okay. And finally outwash plain. So basically all these features are found on the outwash plain only. Outwash plain is the area beyond the glacier. When the glaciers are receding, retreating during summer, that becomes the outwash plain. Okay, जो melt water बाद में deposit करता है. Then thereafter waves, ocean waves, very simple erosional features. First, this is the sequence, pay attention here, sequence of formation. First, there will be formation of cave. Okay, so cave is a small feature, inlet, outlet will be there. Slowly, it will create arch. ठीक है, ये ऐसे बढ़ के ये क्या करेगा, आर्च तैयार करेगा ऐसे. And after some time period, that roof of arch will collapse like this, and there will be stack, independent stack, and over the period that is also eroded into stump, छोटे size का. This is the sequence. Over the period ये चला जाएगा, ऐसे ये इंटीरियर में इरोड होते जा रहा है. कौन सा? ये वेव्स स्प्लैश करके करता है. ये क्या स्टैक? ठीक है, ये जो नहीं देखो ध्यान दो यहाँ पे. ठीक है, नीचे जो है एक तरीके का हार्ड रॉक है. ठीक है, ऊपर जो है सॉफ्ट रॉक है. वो यहाँ पे कलर में भी डिफरेंस दिखा है देखो. ठीक है, ये वाला और ये जो है कंसिडरेबली सॉफ्ट रॉक है, तभी इरोड होगा कंपैरेटिवली. ठीक है, आइडियली. तो आपके हिसाब से तो नहीं, तो ये इरोड होके गिर जाना चाहिए था. ठीक है, तो ऑफ कोर्स सॉफ्ट रॉक पहले इरोड होगा. ये केव इसीलिए बन रहा है कि यहाँ पे सॉफ्ट रॉक है, ऐसे समझो. ठीक है, वेव कट लैंडफॉर्म्स जो होते हैं हार्ड रॉक एंड सॉफ्ट रॉक एरियाज में बनते हैं. डिपोजिशनल लैंडफॉर्म्स में यूनिक आपको पता होना चाहिए कि ऑफ कोर्स स्पिट. ठीक है, पहले क्या तैयार होता है, सीक्वेंस देखिए. पहले क्या होता है, बार, दैट इज फॉर्म inside the ocean at certain distance from the coast. Bar deposited by oceans. ठीक है, now when that bar becomes barrier to the waves, that becomes barrier bar. This is a Great Barrier Reef. Okay, so it is a kind of barrier to those waves, barrier bar. Now, when one side of that bar is locked with the mainland and other is open, that is called as spit. So, next formation is spit. Okay, first of all, there is formation of bar, then spit. Thereafter, there will be formation of lagoon. When this other end is also near the land, it is not locked yet, but it is reaching towards the land. And there is very narrow opening for the water, like Chilika Lake or Pulikat Lake. They are lagoon lake. Okay? So that is now lagoon. And thereafter formation of coastal plains. This is the sequence of formation of these landforms. So eastern coastal plains कैसे तैयार हुए होंगे? ये sequence में, starting से. Okay. Then many times eroded landform which is present inside the ocean is connected to mainland with depositional feature. ये eroded island है, छोटा सा समझो, rock है. That is connected to mainland through depositional aspect. यहाँ पे deposition हुआ है. That is called as tombolo. Okay, tombolo. Now you have understood all these things. Of course, beach is part of deposition only. It is made up of sand, continuous deposition by the waves. Lastly, it is winds. Erosional landforms, winds. So pediments and pediplains. Pediment is basically when the hilly areas is completed at the base of hilly areas in the desert like we can say regions, pediments are formed because of winds, wind erosion we can say. Okay. Then pediplains. Pediplains are basically the plain areas in the desert area. ठीक है, डेजर्ट एरिया में जो प्लेन्स बनते हैं उनको पेडिप्लेन्स बोलते हैं. दे आर फीचरलेस प्लेन्स. ठीक है, पेडिप्लेन्स मतलब क्या है? फीचरलेस प्लेन्स. ओके, देन प्लायाज. प्लायाज you can see here, they are a kind of, let's say, depressions in the desert area which are filled with water during the seasonal. You can see rain is there, seasonal runoff is there, and that is filled with water. Many times there is recharge of groundwater because of this. Okay, so that is called as playa. Playa is different than, we can say that, what is called that? Oasis. Okay, oasis and playas are different. Playas because of rainwater and oasis because of groundwater. Okay, oasis are found in desert and when the groundwater is reaching to the surface, that is oasis. Okay. Now deflation hollows. Deflation hollows are the deflations caused on the sand because of continuous wind movement in a certain direction that removes the sand particles from that area and deposits somewhere else. So deflation hollows बोलते हैं उसको. Okay, mushroom and table rocks, mushroom rocks and table rocks. In desert area, the erosion happens along the ground because the wind that is moving in the desert area, it carries small rock particles. They are the, let's say, responsible for abrasion activity and plucking activity. अब rock particles तो हवा में ज़्यादा नहीं उड़ेंगे ना, वो ज़मीन के साथ हैं. तो इसलिए इरोजन जो होता है डेजर्ट में हमेशा बॉटम साइड में होता है रॉक्स के. That's why it gives look like mushroom, table rocks or mushroom rocks. Okay, then have we added that? Okay, a few other things that you should know. Two landforms, yardangs and other is Geogens. It is given in GC Leong. Yardangs and Geogens. Okay, so yardangs are formed because of parallel soft rock and hard rocks, this topography. So soft rock is eroded faster, so it is a kind of बोरोज फॉर्म, ठीक है। तो आपने जो प्लो फील्ड देखी होगी, तो उसी तरीके से ये दिखता है कि सेंटर में क्या है, सॉफ्ट रॉक इरोड हो चुका है, साइड में हार्ड रॉक है। ओके, सो विंड इज ब्लोइंग इन दिस एरिया लाइक दिस। ये क्रॉस सेक्शन मैंने दिखाया है, ठीक है, क्रॉस सेक्शन दिखाया है उसका। नाउ soft rock, hard rock. Now if suppose so let's say in the areas where hard rock is soft rock is lying above the hard rock. Okay, so in these areas, oh sorry, pardon me, hard rock is lying above the soft rock. ठीक है, तो यहाँ पे क्या होगा, ये वाली टोपोग्राफी होगी इस तरीके से, इस तरीके से ऐसे ड्रॉ करिए, ठीक है। तो ये क्या है, हार्ड रॉक है, नहीं इरोड हो रहा है, नीचे का हो जा रहा है सॉफ्ट रॉक। सो दिस इज ज्यूजेंस। याद कैसे रखना है, यार यार यारदांग, यार को हम कैसे चलते हैं साथ, दोस्त के साथ कैसे चलते हैं, गले में हाथ लगा के, ठीक है। तो हार्ड रॉक और सॉफ्ट रॉक कैसे हो गए, साइड साइड हो गए एक दूसरे के, ठीक है। तो ऐसे याद रखेंगे। दूसरा है उसका अपोजिट। फाइन। देखो मशरूम रॉक्स आर आइसोलेटेड रॉक्स, ये क्या है, ऐसे फरोज की तरह तैयार हुए हैं पेवमेंट पे। डिपोजिशनल, लार्जली दीज आर द ड्यून्स फॉर्मेशन, टाइप्स ऑफ ड्यून्स, yes, barchans, or we can say that they are the crescent shaped dunes, barchans, and you can see this is the direction of wind, these are the wings. Then sieve, similar to barchans but with only one wing. Now exactly opposite of barchans is parabolic, okay, exactly opposite हो गया, wind direction same रखा हुआ है, that is parabolic. These are largely formed when there is a small kind of vegetation is acting as a barrier for shifting these sand dunes. वहां पे पैराबोलिक तैयार होता है, ये याद रखिए, ठीक है। समझो यहाँ पे सैंड ड्यून्स शिफ्ट होते हुए आ रहे हैं और यहाँ पे वेजिटेशन है थोड़ा सा, तो यहाँ पे ये अब स्विच कर देंगे, ये बारचन्स नहीं रहेंगे, अब ये पैराबोलिक बनेंगे, ठीक है। देन ट्रांसवर्स, okay, of course perpendicular to the wind direction, that's why transverse. If they are in the direction of wind, they are longitudinals.
So in parabolic, where is the vegetation in the diagram? Like it is
Here on this side there will be vegetation, ठीक है। इधर से wind direction है, यहाँ पे vegetation होगा। इसका आप कभी वीडियो भी देखना, टाइम मिलेगा तो, कैसे ट्यून्स बनते हैं, ठीक है, ये सैंड ड्यून्स, बट अभी टाइम नहीं है हमें ऑफ कोर्स, ठीक है, तो छोड़ दो, इतना इम्पोर्टेंट नहीं है। ऑल राइट, हो गया फिर ये। चलिए, तो ओके, रॉक्स एंड मिनरल्स इज वेरी स्टैटिक पार्ट, ठीक है। आपको एनसीईआरटी में जो चैप्टर है रॉक्स वाला वो पढ़ लेना है। मेरे ख्याल से नए एनसीईआरटी में वो चैप्टर हटा दिया है, तो ये चैप्टर आपको देखना होगा ठीक से, ठीक है। मेजर एलिमेंट्स इन द अर्थ क्रस्ट, इट इज लार्जली द ऑक्सीजन एंड सिलिकॉन। Oxygen 46%, silicon 27%. Largely these are the major minerals. Okay, 98% of total crust is made up of oxygen, silicon, aluminium, iron. So these are the major one. A mineral is composed of two or more elements. Okay, and the ore is basically of largely minerals. ठीक है, ये हमने ऐड कर दिया है। रॉक साइकिल, यू नो अबाउट रॉक साइकिल, इसमें कोई कॉन्सेप्ट नहीं है एज सच, ये सारा फीचर्स है, ये आ गया क्वेश्चन। नाउअडेज दे आर फोकसिंग ऑन मिनरल्स आल्सो, लाइक दे आस्क दैट रूटाइल एंड इल्मेनाइट मिनरल्स, ठीक है, टाइटेनियम। तो वैसे ही आपको यहाँ पे भी कुछ पूछ सकते हैं इससे रिलेटेड जो एनसीईआरटी में दिया हुआ है, ठीक है। ऑलराइट, सो लेट्स कंटिन्यू विथ नाउ क्लाइमेटोलॉजी. If you see the PYQ analysis of last 20-25 years, most number of questions from physical geography are from climatology. Okay, be it for prelims or even in mains. So, and concepts, so many concepts are involved here. So, concept-based questions, there is scope to ask. And first of all, we'll understand very simple concepts, what is longitude, latitude, and thereafter the standard time, Indian standard time and international date line, all these things. Then thereafter we will try to understand what is solstice, summer solstice, winter solstice, equinoxes. All these concepts are important because आपने देखा होगा पिछले 3-4 साल में they have asked once or twice that question. The sun is overhead, above that Arctic Circle, Tropic of Cancer, something like that. So if you have the clarity of concept, such kind of questions will be very easy to deal with. So first of all, it is latitudes. Okay. So latitude is what? Angular distance of a place north or south of equator measured in the degrees from the center of the earth. Simple, try to imagine the earth, and if you see the angle from the center with equator of any place to the north and south of equator, that is called as latitude. So at equator, of course, it is going to be 0 degree, and towards pole in the northern side, if you move from 0 to 90 degree north pole, 90 degree south. So in essence, how many latitudes we can understand here? How many latitudes are there total? Standard latitudes. So standard latitudes नहीं, total मतलब. हाँ 1 डिग्री पे कितने होंगे वो टोटल फिर? हाँ 179. Of course the equator is common, no? North में जितने होंगे, south में equator is common. So 179 total will be there. So now, why linear distance of degree of latitude at pole is little longer than that of equator? Now we know that Earth is the geoid shape or oblate spheroid. Now in such kind of, let's say, shape, what happens is the polar region is flat. Now because of this, what happens is the distance between 1 degree north and 2 degree north and 88 degree north and 89 degree north will not be same. Rather it goes on increasing. Why? Because of flat nature of poles or polar region. वहाँ पे distance ज़्यादा होगा. Okay, in polar region or in higher latitude, the distance goes on increasing. The reason is Earth is slightly flattened at the poles. Very simple. Now the standard latitudes, yes, equator 0 degree. And then the tropics, Tropic of Cancer 23.5 north, Tropic of Capricorn 23.5 south. Of course आप मैपिंग में कर ही लोगे इसमें कि कौन से कंट्रीज से ये पास होते हैं तीनों, राइट? वो स्टैंडर्ड क्वेश्चन होता है, बट अभी आता नहीं है वैसे क्वेश्चन. पहले आता था, आप PYQ देखेंगे तो पहले क्वेश्चन ऐसे आते थे मैपिंग पे, बट नाउअडेज दे आर नॉट आस्किंग दैट क्वेश्चन. ओके, देन द रीजन लाइंग बिटवीन द tropics is called torrid zone. Okay, torrid means high temperature, or we can say surplus heat is received in that region. That's why it is torrid zone. Now, other important, let's say, latitude is Arctic Circle 66.5, Antarctic Circle 66.5 south, and the region between these two, we can say it is temperate zone. Okay, temperate is moderate temperatures. Okay, moderate or moderation, we can say that, compared to this zone and this zone. And then beyond that, up to North Pole and South Pole, it is frigid zone because of considerably lower temperatures. Frigid zone. Okay, now what happens is throughout the year there is apparent movement of sun between these tropics, right? Apparent movement is happening. Let's try to understand in detail about that. The midday sun is exactly overhead at least once in a year on all the latitudes between the Tropic of Cancer and Tropic of Capricorn. Okay, at least once in a year. Generally it is twice if you see. Okay, so that means if we take any one location here, so if the sun is, let's say, moving from this side to this side, so once, then twice, up to this 1 year. Okay, so it will be twice overhead. Then beyond these tropics, the sun is never overhead above any location. Okay, sun is not overhead. So ये भी याद रखना है आपको. Now, what was that question last year prelims examination? ऐसा कुछ क्वेश्चन था ना, let's say this is the location if the sun is overhead over the Tropic of Cancer. ठीक है, ट्रॉपिक ऑफ कैंसर पे कब रहता है ओवरहेड? समर सॉल्स्टिस पे. हाँ, समर सॉल्स्टिस पे ये रहेगा एंड अराउंड वी कैन से दैट जून. ठीक है, तो उस डे पे क्या होता है यहाँ पर? हाँ एग्जैक्टली उस डे पे yes, maximum length of the day throughout the northern hemisphere, first thing. Second thing is that there is a 24-hour day at North Pole on that day. 24-hour day, that is sun is visible on the horizon for 24 hours continuously.
Whole Arctic circle?
No, not whole Arctic circle. 24 hours के लिए नहीं रहेगा ना.
On that day, sir.
Yes, on that day.
Whole Arctic circle because, sir, the Earth is tilted 23 and a half.
Okay, हाँ, pardon me. Yes, all Arctic circle, pardon me. On that same day, yes, 24 hours. Beyond region on this and beyond this. ठीक है, yes, so that is correct. So Arctic circle and beyond that for 24 hours. This concept is very important. Now, when the shift of sun happens from this towards the south, this time period goes on decreasing. Okay, time period goes on decreasing and it goes on decreasing from this to this. ठीक है, मतलब यह लोकेशन से यहाँ तक धीरे धीरे कम होता जाता है. ओके, एंड एग्जैक्टली ऑन नॉर्थ पोल देर इज 6-month समर and 6-month winter. Exactly on North Pole, the sun is visible for 6 months. ठीक है, exactly on North Pole, geographic North Pole we are talking. And exactly if you see for winter months, 6 months को नहीं दिखाई देगा. ऐसे समझना है, right? Okay. Now, we will understand this in detail further. Now let's try to talk about longitudes. ठीक है, longitudes similar to latitude, longitudes are basically angular distances, but now of a place east or west of prime meridian, measured from degrees from the center of the. So here we are talking about north and south of equator in latitude. Now we are talking about the prime meridian that passes through, we can say Royal Astronomical Observatory at Greenwich, London. ठीक है, that is prime meridian. And the places east of that and places west of that, they are the reference points, we can say. Okay, now, so if you talk about the total number of longitudes, the earth is divided into such kind of semicircles and we have 180 total, what we can say, on the eastern side and 180 on the western side, or international date line is also there. Okay, so earth is divided into 360 longitudes or meridians. 360 meridians. Okay, so since the earth makes complete rotation of 360 degree in one day or 24 hours, therefore it passes through 15 degree in 1 hour or 1 degree in 4 minutes. Very simple mathematics. आप कैलकुलेट करके देखिए. कितना होता है ये? 6 4 जा 6 6 जा okay, so what is that? 15. ठीक है, 1 डिग्री जो है 15 मिनट में क्रॉस कर लेगा और उसी तरीके से 15 डिग्री जो है 1 आवर में कंप्लीट करेगा और 1 डिग्री जो है 4 मिनट्स में कवर करेगा. सो दिस कैन बी द स्टैंडर्ड कैलकुलेशन. Thereafter, Earth rotates from west to east. So every 15 degrees we go eastward, the local time is advanced by 1 hour. Now, I will tell you trick to remember. Always consider that at prime meridian or this time, there is टाइम पीरियड ऑफ 12 PM, दोपहर के 12 बजे, ऐसे समझो. And try to imagine that what happens if the earth is moving, like earth moves from west to east, right? Earth rotates from west to east. So what happens? This region is moving ahead of prime meridian. That means India or this Africa, they have already moved ahead. Moved ahead means वहां पर क्या हो गया, शाम हो गई है, यहाँ पे दोपहर ही है अभी तक. ऐसे इमेजिन करके रखना है माइंड में. So then you can understand that ये लोकल टाइम एडवांस हो जाएगा. प्लेसेस ईस्ट ऑफ ग्रीनविच गेन टाइम. ईस्ट ऑफ ग्रीनविच गेन टाइम, एडिशनल टाइम होता है, एक्स्ट्रा टाइम हो. गेन टाइम मतलब क्या है, यहाँ पे 12 बजे है तो इंडिया में 5:30 बजे हो गए शाम के. ठीक है, तो दैट इज देन प्लेसेस वेस्ट ऑफ ग्रीनविच लूज टाइम. ठीक है, देन a person going eastward gains time from Greenwich. ठीक है, ये आपको पता ही है 12 hours का 180 डिग्री का होता है. Indian standard time corresponds to time of 80 degree 5 minutes east longitude. Okay, it is 5 hours 30 minutes ahead of GMT, that is Greenwich Mean Time. And this particular longitude passes through Mirzapur in Uttar Pradesh. ठीक है, जो लॉन्जिट्यूड इंडियन स्टैंडर्ड टाइम के लिए यूज होता है. देन रशिया हैज 9 टाइम जोन्स, कनाडा यूएस हैज 6 टाइम जोन्स. सो व्हेनेवर द कंट्री इज हैविंग ईस्ट वेस्ट एक्सपांस, so they will have more time zones because meridians are crossing that, no, vertically. If it is north south expanse, then there is no problem, right? But east west expanse है तो ज्यादा टाइम. Then चाय बगान टाइम. Earlier, the British planters, tea plantations, they used to have such chai bagan time in Assam. They used to have 1 hour ahead of IST, the time period, to improve productivity of or optimizing daytime. ठीक है, so chai bagan time was one hour ahead of. So आपको पता ही होगा कि क्या होता है, इंडिया का ईस्ट और वेस्ट एक्सटेंशन अगर आप देखते हैं, सो इट इज कंप्लीटली 2 hours डिफरेंस. सो मेनलैंड एंड नॉर्थ ईस्ट, so somehow there is let's say 1 hour difference if we talk about the Indian standard time and the easternmost part of India. And the people working in the mainland and the people working in northeast India, if they want to communicate with each other or want to coordinate on the work, then that becomes problem, no. यहाँ पे जब 10 बजे ये ऑफिस खोलेंगे तो वहाँ पे वो पहले से 11 बज गए, मतलब 1 घंटा खाली बैठे हैं वो, ऐसा हो गया ना. ठीक है, तो वो नहीं चाहिए ना. तो ऑफ कोर्स दे विल एडवांस द टाइम फॉर 1 hour so that, तो ये then a traveler crossing international date line, which is zigzag line, from east to west loses a day, while crossing date line from west to east gains a day. So यहाँ पे देखिए ये diagram में, if it is moving from west to east like this, he gains the day, and if it is moving from east to west, then it loses a day. सैटरडे है, दैट इज ट्रू. ठीक है, मतलब क्या है, यहाँ पे एक्स्ट्रा दिन मिल रहा है उसको, ऐसे. राइट, बट ये कॉन्टेक्स्ट अलग है. ठीक है, ये हाँ नहीं, वहाँ पे गेन नहीं बोलेंगे हम, क्या बोलेंगे कि हाँ हाँ, वो तो रोटेशन की वजह से हो रहा है, समझो.
बट सर रियल में अगर हम देखें तो 5:30 ऑलरेडी बज चुका है, हमने लूज किया ना, 5.5 घंटा आगे चल रहे हैं. बट अगर हम उधर जा रहे हैं तो हमारे पास टाइम एक्स्ट्रा मिल रहा है. तो इस कॉन्टेक्स्ट में तो ग्रीनविच के इस साइड में गेन होना चाहिए, जैसे डेट लाइन में. बिल्कुल
बिल्कुल, आइडियली वैसे होना चाहिए. बट ये जो टर्मिनोलॉजी यूज की गई है वो डे के लिए है. ठीक है, अब गेन्स अ डे मतलब क्या है कि ये पिछले दिन में चला गया है. जब ये ऐसे क्रॉस कर रहा है तो ये पिछले दिन में चला गया है, दैट्स व्हाई गेन्स अ डे, 1 कंप्लीट डे. अब ये जो है ये जम करता है अगले दिन में. ठीक है, तो अगले दिन जम करेगा तो एक कंप्लीट दिन चला गया है उसका. इस तरीके से. Now how to remember this? इसका एक शॉर्ट फॉर्म तैयार करके रखो. ये याद रखो, वेज. ठीक है, वेस्ट टू ईस्ट गेन्स अ डे टाइप का. ठीक है, तो वो फिर आप कंफ्यूज नहीं होगे उसमें.
So why there is hammer-like international dateline at the equators?
हाँ,
Why there is hammer-like dateline at the equator?
hammer like. No, it is crisscrossed, zigzag kind of thing. Not hammer like specially. Rather, it's a boundary, uneven. It is not straight line, right? Because islands are there. So many countries are located there. So they want to have a particular time zone. So if it is international date line passing through them, then country will have 2 time zones and it will be very difficult to manage. इसलिए नहीं होता है. Okay, rotation of Earth around its tilted axis. We know that Earth's axis is tilted with the plane of Earth's revolution 66.5. This is Earth's plane of revolution around the Sun. With that plane, it is 66, and with the vertical, if you see, 23.5. Okay. Now the assertion aspect. So Earth takes approximately 24 hours or this much amount of time to complete one rotation. This error is compensated as one complete day after 4 years. ठीक है, तो लीप ईयर जिसको हम बोलते हैं फरवरी में एक एक्स्ट्रा डे ऐड करके. Now day and night phenomenon occur due to rotation of Earth because zone of illumination जिसको हम बोलते हैं half of Earth, that is zone of illumination, is continuously changing because of rotation of Earth. And that's why this is day and night phenomenon, right? Then assertion reason type of question can be asked like this. The gravitation force is not the same at different latitudes on the surface. It is greater near the poles and lesser at the equator. Earlier we talked about this. It is the shape. Okay, it is the shape. Poles are closer to the center due to equatorial bulge. Also, the speed of rotation of Earth is greater at the equator than poles, and thus the centrifugal force is greater at the equator. As centrifugal force and gravitational force are counteracting forces, which is acting in opposite direction, gravitational force is slightly less at equator compared to poles. Counteract करता है उसको, and because of that, the felt gravitational force is less at equator compared to poles. दोनों रीजन है उसके. ठीक है, एट इक्वेटर वी हैव मोर सेंट्रीफ्यूगल फोर्स बिकॉज ऑफ हायर स्पीड ऑफ रोटेशन, राइट? एंड बिकॉज ऑफ दैट ऑल्सो, एंड दैट सेंट्रीफ्यूगल फोर्स इज इन आउटवर्ड डायरेक्शन एंड ग्रेविटेशनल फोर्स इज टुवर्ड्स द सेंटर, अपोज कर रहे हैं एक दूसरे को, एंड थोड़ा सा वो कंपेंसेट करता है, इसलिए वो कम आता है. ठीक है, दोनों रीजन है.
But is it only because of the, the centrifugal force counteracting against the gravity that is why?
No.
मास
ठीक.
सेम, मतलब
मास
Earth जो है वो सेम ही है. Poles में
हम जी कैलकुलेट पूरे अर्थ के लिए हो रहा है, पूरे अर्थ के लिए हो रहा है. ठीक है, तो मास सेम रहेगा, सिर्फ डिस्टेंस जो है सेंटर से चेंज होता रहेगा. ठीक है, सेंटर से डिस्टेंस जो आर की वैल्यू है चेंज होगी. ठीक है, ऐसे याद रखेंगे उसको. ऑल राइट, next is revolution. Okay, revolution 365 days, and we can say one half, 1/4 days, 1 year. Of course, let's say that extra day is added through February month, leap year. ठीक है, ये याद रख सकते हैं आप. Every year 6 hours extra surplus होता है. The movement of Earth around the Sun in elliptical path. So Sun is at one of the foci of that ellipse. This is the standard according to Kepler's law. Most of the planets, they will follow the elliptical path, and the body around which they are revolving, that will be at one of the foci. Like Sun is at one of the foci. Now look at this. Let's say what I was telling you. Let's say seasons. The seasons on the Earth are due to revolution of the Earth. So when the north pole is tilted towards the sun, of course there will be summer. Okay, when the south pole is tilted towards the sun, there will be winter here, northern hemisphere, right? Then you can see after winter there is spring, and after summer there is autumn, सितंबर के टाइम पे, ठीक है. एंड यहाँ पर स्प्रिंग, यहाँ पे जो है फॉल ऑफ लीव्स एंड ऑटम जो होता है, एंड स्प्रिंग जो है अभी जस्ट विंटर के बाद शुरू हुआ है, तो वो स्प्रिंग था, ठीक है. एंड दीज आर जनरली अलोंग द इक्विनॉक्सेस, स्प्रिंग इक्विनॉक्स, ऑटमनल इक्विनॉक्स. अभी जो हुआ था वो कौन सा था? स्प्रिंग इक्विनॉक्स था, ठीक है. और दैट इज ऑल्सो कॉल्ड वर्नल इक्विनॉक्स, ठीक है. वर्नल इक्विनॉक्स, ऑटमनल इक्विनॉक्स मार्च में जो होता है और सितंबर में जो होता है. ओके, विल सी दैट डायग्राम ऑल्सो फॉर द solstice and equinoxes. Okay, so what is solstice? Yes, when the sun is overhead above the Tropic of Cancer and Tropic of Capricorn, so that is solstice. Summer solstice around 21st of June, northern hemisphere tilted towards the sun, the rays of the sun fall directly on Tropic of Cancer. Now other features, the longest day and the shortest night all across the northern hemisphere. Whole of the Arctic region falls within the zone of illumination all day long. So I told you that is 24 hours a day, 24 hours day for complete Arctic region, complete Arctic region. Similarly, winter solstice 22nd December, southern hemisphere is tilted towards the sun and rays of sun fall directly on Tropic of Capricorn. Longest night and shortest day all across the northern hemisphere. Now let's locate that here. Okay, look at this position. This is, we can say, 21st of June, summer solstice, and this is winter solstice. Okay, अब जब आप एग्जाम में ड्रॉ भी करते हैं मेंस के टाइम पे, हम स्टूडेंट्स को बोलते हैं कि बराबर से ड्रॉ करिए. ये जो टिल्टेड एक्सिस है, नॉर्दर्न हेमिस्फीयर यहीं आना चाहिए और ये सदर्न हेमिस्फीयर इधर से होना चाहिए. सेम इज विथ इक्विनॉक्सेस. सो 21st of March and September 23rd, direct sun rays fall on the equator. At this position, neither of the poles are tilted towards the sun. So that means whole earth experiences equal day and equal night on this day. Whole earth, equal day and equal night. ये भी एक पेंडिंग क्वेश्चन है, जो जिस तरीके से क्वेश्चन पूछे जा रहे हैं, तो solstice और ये सब हो गया, अभी इक्विनॉक्स पूछ सकते हैं. So they are called as equinoxes. Look at this. Now here there is no one particular pole is tilted, rather they are evenly available, and that's why all day and night all over the earth they are same, equinoxes. Okay, now the sun remains continuously visible for one day during the summer solstice, 21st June in the northern hemisphere and 22nd December in the southern hemisphere at polar circle, or we can say Arctic circle and Antarctic circle. For several weeks, only 100 kilometers closer to the poles, and for 6 months at the pole. Just now we talked about that. ठीक है. Now what is daylight saving time? DST. ठीक है, अभी न्यूज में भी था विंटर के टाइम पे, जनरली विंटर के टाइम पे होता है, सॉरी समर के टाइम पे, पार्डन मी. Yes, it is the practice of advancing clocks during summer months by 1 hour or more, especially by certain European countries, higher latitude, those countries in higher latitude. So what they are doing here through daylight saving time, during summer, northern hemisphere beyond Tropic of Cancer, what it experiences more than 12 hours of daylight. Okay, more than 12 hours of daylight. Now by advancing their clocks, what they are doing, they are helping people to utilize the remaining sunshine or daytime for other activities. If they are not doing this, what happens? Morning some time of daylight and evening some time of daylight is divided due to office hours. ठीक है, तो वो यूटिलाइज नहीं कर पाते हैं दोनों भी ठीक से. ठीक है, तो और उनको समर इज वेरी इंपॉर्टेंट उनके हेल्थ के लिए और उनकी बॉडी के लिए, क्योंकि वो विंटर में पूरा फ्रीज हो चुके रहता है. ठीक है, उनको सनलाइट लेना, और वो देखते होगे आप बीच पे जाते हैं समर में, वो सनलाइट लेंगे, सन बाथ लेंगे, एंड दिस इज वेरी इंपॉर्टेंट एक्टिविटी फॉर देम, फॉर देयर बॉडी स्ट्रक्चर इटसेल्फ। ठीक है, तो दैट्स व्हाई दे आर एडवांसिंग इट सो दैट दे कैन यूटिलाइज द रिमेनिंग टाइम पीरियड फॉर देयर रिमेनिंग एक्टिविटीज, हाउस होल्ड एक्टिविटीज एंड ऑल। ठीक है, ओके। नाउ दिस इज वेरी इंपॉर्टेंट। Yes, in the northern hemisphere, the summer is slightly longer than winter. ठीक है, कितना होता है? अराउंड 92 डेज। ठीक है, नॉर्दर्न हेमिस्फीयर में 92 डेज का होता है, सदर्न हेमिस्फीयर में अराउंड 89 डेज का होता है। विंटर 89 डेज का होता है, समर 92 डेज का होता है। Now why it is like that? Let's try to understand. And here the Kepler's planetary motion laws, especially second law. ठीक है, तो क्या बोलता है ये लॉ? इट सेज दैट द लाइन बिटवीन सन एंड द प्लैनेट स्वीप्स इक्वल एरियाज इन इक्वल टाइम्स। लाइन बिटवीन सन एंड प्लैनेट, दिस लाइन स्वीप्स इक्वल एरिया इन इक्वल टाइम। सपोज दिस इज 1 month, the time, this is the area, this is 1 month, this is the area. This area should be same. Now, how it can be same? If the sun is at one of the foci, so of course there must be change in the speed of this planet when it is moving near the sun and moving away from the sun. When the planet is moving near the sun, it moves fast so that it is sweeping more area. Okay. When it is farther, it requires only smaller area to be covered because this is distance is more, no? Area we have to cover same. Okay. It sweeps equal area in equal time. So speed is the variant here. Okay. And look at this. Earth is farther away from sun in summer. So here the concept of aphelion and perihelion is very important. Okay. So perihelion and aphelion. Aphelion is the longer distance. Look at this. This is the actual diagram that we should remember. Aphelion, 3rd July. Okay, so this is called as line of apsides. Okay, line of apsides this is. And this is perihelion, 3rd January. Now here Earth is near to the sun. But look at the position. Here there is winter going on in the northern hemisphere. And when it is at farther distance, there is summer going on in the northern hemisphere. ठीक है, ये याद रखना है, 3rd of July, but solstice 21st of June. So solstice and aphelion do not match. ठीक है, तो अलग अलग है, ये याद रखना है. And aphelion and perihelion is the near one. ठीक है, पेरीहेलियन इज द नियर वन. कुछ तो टेक्निक आप याद रखने के लिए करिए इसको. अपोजी एंड पेरीजी इज ऑल्सो देयर फॉर मून एंड अर्थ. सिमिलरली अर्थ एंड सन. ओके, देयरफॉर लुक एट दिस. अर्थ इज फार्दर अवे फ्रॉम द सन इन समर. देयरफॉर इट्स ऑर्बिटल वेलोसिटी एट इट्स लोएस्ट. समझो यहाँ पे ये कम है ऑर्बिटल वेलोसिटी एज कंपेयर टू दिस वन. ओके, एंड इट रिक्वायर्स मोर टाइम टू ट्रैवल फ्रॉम the summer solstice point to the autumnal equinox, that is 23rd. Then it needs to move between winter solstice and vernal equinox. ठीक है, उसको टाइम ज्यादा लग रहा है. यहां से यहां तक वो धीरे से जाएगा, बट यहां से यहां तक बहुत फास्ट जाएगा. We can say that basically gravity भी बोल सकते हैं, या फिर जैसे जब ये planets तैयार हुए हैं तो ये एक ही चीज से तैयार हुए. These planets were formed from the same source. Inertia नहीं बोलेंगे, momentum is there. ठीक है, inertia से ज्यादा
मतलब वो जैसे ऑब्जेक्ट दूर होता है अगर उतना ही लगेगा तो स्लो होगा वो. जैसे वो डिस्टेंस बिगर स्पीड बढ़ जाएगी. लॉ कंजर्वेशन.
हाँ, कंजर्वेशन ऑफ मोमेंटम हम बोलेंगे. इनर्शिया इज डिफरेंट टर्म. ठीक है, मोमेंटम. हाँ, ठीक है, तो ये याद रखना है. इन रिवोल्यूशन द अर्थ स्पीड इज नॉट कांस्टेंट. ठीक है, And this idea is also utilized while for launching, spacecrafts, satellites or space missions. यही use करता है idea जो है planets का, because it is using the gravitational field. जैसे अभी पार्कर प्रोब का जो परसों आर्टिकल आया था द हिंदू में, आपने पढ़ा होगा. So what it is doing? It is using the gravitational field of Venus to swing around it and trying to reach towards the sun. समझो ये Venus है, तो ये इसकी ग्रेविटेशनल फील्ड यूज करके ऐसे स्विंग कर रहा है सन की तरफ, ठीक है, इलिप्टिकल पाथ में, सेम विद लाइक दैट. वो यही फॉर्मूला यूज करता है उसमें, ठीक है. फाइन, ओके. सो यू हैव अंडरस्टूड व्हाई इट इज टेकिंग मोर टाइम, 92 डेज, ठीक है. समर ज्यादा होता है, विंटर कम होता है नॉर्दर्न हेमिस्फीयर में. ऑल राइट, नेक्स्ट सम इंपॉर्टेंट टर्म्स रिलेटेड टू मून एंड मून्स कैलेंडर, ठीक है. तो मून इज द ओनली नेचुरल सैटेलाइट ऑफ द अर्थ एंड मून्स रोटेशन इज टाइडली लॉक टू द अर्थ्स ग्रेविटी. टाइडली लॉक क्या होता है, ऐसे दिखता है, ये देखिए. इसमें नहीं क्लिक होता है क्या? हाइपरलिंक दिया हुआ है. क्या हो गया इसको? This is tidally locked. This is not tidally locked. Tidally locked, you can see one face is always visible. ठीक है. And how it is tidally locked? How planets, satellites are tidally locked? That is explained here. Look at this. ठीक है. So initially, when the moon was getting formed, the moon is stretched by the pull of Earth's gravity as it rotates, losing the energy as it flexes. Okay, when the moon was getting formed, so it loses that energy because of gravitational force of the Earth. And ultimately, post-tidal locking, it gets locked. ठीक है. Initially वो घूमता रहता है, बट अर्थ की ग्रेविटेशन फील्ड की वजह से वो लॉक हो जाता है ऐसे. ओके, सो दैट इज टाइडली लॉक. दिस इज कॉमन सेलेस्टियल फेनोमेनन फॉर सैटेलाइट्स स्पेशली. ओके, ऑल राइट. Which one? Of course, they see tidally lock बोलने से ज़्यादा हम उसको क्या बोलेंगे कि certain they are always at one position, they are geostationary. Well, certain are always moving, right? They are supposed to be tidally locked. Why? Because they are observing the Earth's surface continuously. If they are themselves rotating, तो वो तो continuous observe नहीं कर पाएंगे ना. उनका जो फेस, जो ऑब्जर्व करने की चीज़ है, वो कंटिन्यूस अर्थ को फेस करनी चाहिए उसने. तो आइडियली देखा जाए तो वो टाइडली लॉक ही होना चाहिए, वो खुद रोटेट नहीं करना चाहिए. Yes, we can control also. Okay, now the tidal locking is a situation when the object's orbital period matches with its rotation period. So moon's rotation period around its own axis and its revolution period around the earth is same. Okay, so around 27.3 days. Like the Earth's orbit around the Sun, Moon's path around the Earth is elliptical, and there is perigee and apogee, the farther distance, and the apogee is the farther distance, perigee is the shortest distance in that elliptical orbit. Okay, assertion and reason. The Sun and Moon as seen from the earth appear to be approximately same size. Yes, of course, the distance. Size does not matter if the distance. So, moon is near one and the sun is much farther away from the earth, and because of that same size it looks, but they are of different size. Now, what is sidereal and synodic period? Now, this is important. The moon completes one revolution relative to the fixed stars in about 27.3 days. It is called sidereal month, relative to the fixed stars. Relative to the sun in about 29.53 days. This is called synodic month. इस सन का रिवोल्यूशन टाइम पीरियड के ऊपर है. ओके, विथ रिस्पेक्ट टू फिक्स स्टार आउटसाइड आवर सोलर सिस्टम, साइडेरियल. विथ रिस्पेक्ट टू सन, ठीक है, विथ रिस्पेक्ट टू और विथ रिलेटिव टू सन इट इज साइनोडिक. नहीं, अर्थ के अराउंड ही, ठीक है. मून कंप्लीट्स वन रिवोल्यूशन अराउंड द अर्थ, but when calculated with relative to, relative to the fixed stars. Now we are considering sun as a fixed position, and then we are calculating, okay, moon is taking this much amount of time for around the sun. Okay, but if you take one other star, then this solar system itself is also moving outside solar system. ठीक है, तो वो कैलकुलेशन में एरर या चेंजेस होता है. जस्ट रिमेंबर दिस टर्म पूछेंगे प्रीलिम्स में, साइडेरियल एंड साइनोडिक. सो यू कैन सी साइनोडिक पीरियड इज द टाइम रिक्वायर्ड फॉर अ बॉडी विद इन द सोलर सिस्टम सच एज प्लैनेट, मून एंड टू रिटर्न टू द सेम पोजिशन रिलेटिव टू द सन एज सीन बाय ऑब्जर्वर ऑन द अर्थ. ठीक है, रिलेटिव टू द सन, एंड हियर fixed planet or fixed stars outside the solar system. Then what is supermoon and full moon? When a full moon or new moon occurs close to the moon's perigee, it is known as supermoon. So perigee means near, no? So near होगा तो वो बड़ा दिखेगा moon, so supermoon दिखेगा. And if it is at apogee, it is micromoon. It is micromoon. अभी कल परसों कुछ तो न्यूज में था, व्हाट वाज दैट, पिंक मून और समथिंग लाइक दैट. स्ट्रॉबेरी ब्लॉसम्स काफी फेमस होता है कहीं तो यूएस में. वहाँ के जो अबोरिजिनल्स जो है दे सेलिब्रेट दिस फेस्टिवल इन जून मंथ. दे हार्वेस्ट दिस strawberries, they are in pink in color. तो उस मंथ का जो फुल मून होता है ना, जून का, उसको स्ट्रॉबेरी मून बोल के उसको नाम गिरा हुआ है. जून का जो फुल मून होता है, इट्स नॉट रिलेटेड टू साइज और कलर ऑफ मून. ठीक है, ऐसे ही उसका नाम है. हाँ, ब्लड मून होता है, रेड मून होता है. ऑफ कोर्स, व्हाट इज दैट ब्लड मून और समथिंग लाइक दैट? It is because of scattering of light from the Earth's atmosphere, and that falls on the moon. That's why it appears red. ठीक है. Next, okay, solar eclipse and all these things are very easy to understand. So when we see the solar eclipse, moon is, what is the position of Earth, Moon and Sun?
Moon is between the Earth and Sun.
Yes, when the moon is located between Earth and Sun, and that is full moon or new moon? No, it's always. हर साल मैं ये क्वेश्चन पूछता हूँ, हर साल कंफ्यूजन होता है स्टूडेंट्स को. When we see solar eclipse on full moon day or new moon day? Always on new moon day. अमावस की रात होती है, बट देखते तो हम दिन में है ना. तो अमावस की रात क्यों होती है? क्योंकि मून दिन में हमारे सामने होता है और दिखता नहीं है, रात को नहीं दिखेगा ऑफ कोर्स, तो वो चला गया ना दूसरे साइड, इसलिए न्यू मून होता है। मून होता है दिन में होता है वो मून, ठीक है, और इसलिए वो सन के सामने आता है, इसलिए हमें वो इक्लिप्स दिखता है। इट्स ऑलवेज ऑन न्यू मून डे एंड लूनर इक्लिप्स इज ऑलवेज ऑन फुल मून डे, ठीक है, लूनर इक्लिप्स इज ऑलवेज ऑन फुल मून डे। Now, talking about types of solar eclipse, there are 3 types: total solar eclipse, annular, and partial. So one can understand if the moon is completely blocking the sun and its corona, then it is, we can say, total eclipse. ठीक है? So when is the chance of total eclipse? During apogee or perigee?
When it is closer to Earth.
Yes, when it is closer to Earth, ज़्यादा block करेगा sun को, right? So during the perigee time period, there is chances of total solar eclipse. And annular solar eclipse, when it is farther from the Earth, so it is not able to now completely block. So there will be ring around it, and we can say the corona is visible. Annular solar eclipse. And partial is, means simply it is not completely blocking, partially it is blocking. So there will be umbra as well as penumbra. ठीक है, umbra penumbra क्या होता है? Total solar eclipse मतलब umbra, the complete shadow. So that means total eclipse is always visible from umbra region. Total solar eclipse. And penumbra is that region from where there is partial, let's say, solar eclipse is observed. ठीक है, तो उसको पेनुम्ब्रा बोलते हैं। यहां पे देखिए पार्शियल सोलर इक्लिप्स। ऑल राइट, देन वी हैव lunar eclipse. Okay, lunar eclipse is what? When the earth is between sun and moon. Okay, when the earth is between sun and moon. So again here also we have umbra. Umbra is the region where we can say total lunar eclipse is there. And पेनुम्ब्रा आउटसाइड, देखिए ये छोटा वाला जो रीजन है, तो वहां पे क्या होगा? पार्शियल लूनर इक्लिप्स. सो लूनर इक्लिप्स इज ऑलवेज ऑब्जर्व ऑन फुल मून डे. ठीक है, फुल मून डे पे अर्थ जो है वो ब्लॉक कर देता है मून को, उसका जो ब्राइटनेस है वो ब्लॉक कर देगा. ठीक है, अर्थ का शैडो उस पर गिरता है. ऑल राइट, कैसे न्यू मून डे होगा? फुल मून डे होता है ये. हाँ, लूनर इक्लिप्स पे फुल मून डे होता है. देखो ये वाले डायग्राम पे मत जाओ, यहाँ पे तो उसने ऑब्स्ट्रक्ट कर लिया ना. इट्स नॉट ऑलवेज ऑब्स्ट्रक्टिंग इट्स लेट्स से पाथ. दैट्स व्हाई वी डोंट सी लूनर इक्लिप्स ऑन एवरी फुल मून डे. I will explain that now. Why? Because the axis of moon's revolution around the earth and axis of revolution of earth around the sun, they are at different locations. They are tilted. 5-degree tilt is there. यहाँ पे देखिए, this one. Why don't we have lunar eclipse or solar eclipse every month? Ideally तो तीनों एक लाइन में हर मंथ आएंगे ना, तो इक्लिप्स तो हर मंथ होना चाहिए ideally. But why we are not witnessing this? Because the lunar plane of revolution and Earth's plane of revolution, उसमें 5 डिग्री का एंगल है. ठीक है, and that's why ये कैसे रोटेट होगा? समझो ये अर्थ ऐसे रिवॉल्व हो रहा है ना, तो ये मून ऐसे रिवॉल्व हो रहा है. देखो मेरी को राउंड होता है ना ऐसे टेढ़ा वाला, ठीक है, तो मून ऐसे रिवॉल्व. तो ये एक लाइन में बहुत रेयरली आएंगे अब. ठीक है, हर महीने नहीं आएंगे. एंड दैट्स व्हाई वी डोंट सी, लेट्स से इवन सेम इज अप्लाइड टू सोलर इक्लिप्स. ओके, blood moon, I told you that red moon or red light passes and falls on the moon, so that's why it is called as blood moon. ठीक है, तो ये बेसिक हो गया. देन Atmosphere. Composition of atmosphere: 78% nitrogen, 21% oxygen, argon 0.9, carbon dioxide 0.03%. Sequence याद रखना है. Nowadays UPSC is asking random question. जैसे 2 साल पहले एक क्वेश्चन आया था पानी का, वाटर साइकिल का. 2 statements were asked. Ground water is more as compared to lakes or something like that. 2 statements. Basic NCERT 7th standard. Direct question. But हम उसको इग्नोर करते हैं, बेसिक चीज को इग्नोर कर देते हैं. Okay, so this is composition. The heavier gases like nitrogen and oxygen tend to stick at the bottom of atmosphere due to gravity. Carbon dioxide and water vapor are found only up to 90 km from the surface of Earth. 90% of moisture content in the atmosphere exists within 6 km of the surface. So most of these gases, water vapor, they are between 5 to 10 km of the Earth's surface. That is largely in troposphere, and that's why we see most of the meteorological phenomenon happening within the troposphere. ठीक है, तो ये सारा वहाँ पे ही हो रहा है. Then different gases and their composition. ठीक है, तो first of all composition and then structure. So composition में major 4 चीजें हैं. First is carbon dioxide. इस पे एक क्वेश्चन बनता है हमेशा. ठीक है, एक वाटर वेपर पे लास्ट ईयर जो क्वेश्चन था यही था. कंटेंट वाटर वेपर गोज ऑन डिक्रीजिंग विथ हाइट, जैसे स्टेटमेंट था. इसी से एक क्वेश्चन बनता है हर साल. एक्चुअली एक क्वेश्चन इस पे था क्या, कार्बन डाइऑक्साइड, ग्लोबल वार्मिंग, पहला ही क्वेश्चन था वो. स्टेटमेंट 1 एंड स्टेटमेंट 2, कार्बन डाइऑक्साइड. Yes, so yes, carbon dioxide is a greenhouse gas. In a sense, it absorbs the long wave terrestrial radiations going from Earth's surface to the space, right? And it is transparent to incoming solar radiations. So, वो greenhouse gas हो गया. And it is responsible for warming the Earth's atmosphere. Now, human activities are further adding that CO2 and that is becoming problem. Ideally तो होना चाहिए, नहीं तो without greenhouse gases our Earth's atmospheric temperature would be sub-zero temperatures. ठीक है, तो वो होना ही चाहिए, बट उनका अमाउंट बढ़ा रहे हैं हम. ठीक है, तो ग्लोबल वार्मिंग, बर्निंग ऑफ फॉसिल फ्यूल्स एंड दिस थिंग. Second, ozone. Yes, it is also very important for life on the Earth. Stratosphere 10 to 50, especially the thickness is at 20 kilometer, 20 to 30 kilometer. It is thick ozone. It is a kind of protection layer. Ultraviolet rays radiating from the sun are absorbed by this layer and they are not reaching to the surface of the Earth. Highest concentration occur 20 to 30. Ozonosphere is also called as chemosphere because of lot of chemical activity. Chemosphere, ठीक है, chemical activity going on. Then water vapor. It is variable gas in atmosphere, decreases with altitude. First thing. Warm and wet tropics, it may account for 4% of air by volume, while in dry and cold areas, less than 1%. It decreases from equator towards pole. This was also asked. ठीक है, decreases towards the pole, decreases. It absorbs part of insolation from the sun and preserves Earth's radiated heat. So incoming as well as outgoing, it acts as a greenhouse gas also, and it is also absorbing incoming radiation. So that leads to, we can say, heating of the atmosphere. Also, water vapor contributes to stability and instability in the air. So stability relates to no rainfall, we can say downward movement of wind. So generally when there is no water vapor content in the air, generally there is stability. With water vapor content, increase in that content, there will be more instability. When the wind is moving up and if it is having water vapor, it will lead to condensation, cloud formation and precipitation. That is instability. Then dust particles. Of course, the dust particles acts as, we can say, hygroscopic nuclei for condensation, cloud formation. Dust particles, sea salt, fine, let's say soil, smoke, ash, pollen grains, dust, and we can say disintegrated particles of meteors from the space, dust particles. They are all part of the, we can say, dust particles. They are generally concentrated in the lower layers of atmosphere, but convectional air currents may transport them to greater heights, especially in we can say near the tropics. Higher concentration of dust particles found in the subtropical and temperate region due to dry winds in comparison with equatorial and polar region. ठीक है, तो सब ट्रॉपिकल एंड टेम्परेट में ज्यादा है क्योंकि ड्राई है वहां पर एज कंपेयर टू इक्वेटोरियल एंड पोलर रीजन. Dust and salt particle act as hygroscopic nuclei. Just now we talked about that. Now the structure. This diagram is sufficient to understand the structure. So there are different layers. First layer is troposphere, up to 13 kilometer on an average height, but the average near the height near the equator is more. ये पूछा था उसमें क्वेश्चन में प्रीलिम्स के, ठीक है. So why it is more near the equator? Yes, very good. Convection current, there is more heating of the ground, and that's why it takes to the higher altitudes with that convection movement of air. Very simple question they ask from geography, अगर concept clear है तो, ठीक है. तो ये ट्रोपोपॉज हो गया वहां पर, and thereafter there is stratosphere. Now most of the meteorological activities are happening here in troposphere, like for example condensation, precipitation, evaporation, or formation of cyclones or tornadoes, thunderstorms, or even we can say that whatever the wind movement that is happening, horizontal movement of wind, तो वह यहीं पे हो रहा है सब, ठीक है. Now stratosphere, the most important aspect here. अच्छा, ये ट्रोपोस्फेयर का एक इंपॉर्टेंट रह गया, नॉर्मल लैप्स रेट, ठीक है, 6.5 डिग्री सेल्सियस पर किलोमीटर, नॉर्मल लैप्स रेट, वेरी इंपॉर्टेंट. And that is observed only in troposphere. After that it changes, the trend changes, especially now stratosphere, the temperature increases, so it reverses because of ozone, ठीक है, एब्जॉर्ब कर रहा है ना हीट, तो वो बढ़ जाता है, अभी वापस से जीरो की तरफ पहुंच रहा है, यहाँ पे -60 की तरफ पहुंचा था. ओके, स्ट्रेटोस्फेयर में ओजोन है, बाकी ज्यादा कुछ नहीं है. तो आगे चलते हैं. यहाँ पर देखिए कि ट्रोपोस्फेयर के ऊपर जस्ट यहाँ पर दिस रीजन, दिस इज क्लाउड फ्री रीजन. Okay, or upper troposphere we can say, upper troposphere or lower stratosphere. That region is cloud-free region wherein the movement of all the planes happens, jets and planes. जहाँ पे मतलब turbulence नहीं है किसी भी तरीके का, तो वो fuel consumption कम होगा और safe रहेगा, तो यहाँ से वो fly करते हैं. Then thereafter stratosphere, stratopause है, and then mesosphere. Mesosphere 50 to 80. Here again temperature is dropping down, and this layer most of the meteors, they are coming into the Earth's atmosphere, they are burnt away because of severe friction. इस layer में होता है, mesosphere में meteors, ठीक है. Then thereafter we have thermosphere. The lower layer of thermosphere is ionosphere, ठीक है, यहाँ पर ionosphere आएगा. Ionosphere has several ions. It is very important for radio communication from the Earth's surface, and thereafter the remaining is exosphere. ठीक है. So this is how the layers.
So in outer space, the temperature is very low, right?
Yes, temperature is not very low. Rather, it is not felt directly unless there is medium, because the medium is rarefied there, right? So of course, solar radiations are very harmful there. Okay, if they are directly falling on our body, then they are very harmful. ठीक है. But if there is any container, it is not going to create or warm it. Why? Because air is not there. Air को warm करेगा ना वो. Medium चाहिए ना. Radiation सिर्फ directly गर्म नहीं करता है वैक्यूम को. वैक्यूम को डायरेक्टली गर्म क्यों करेंगे वो? When there is air, there is a medium. Medium means there is a matter. That matter is gaining that energy from radiation, and that's why it is getting heated. जहाँ air ही नहीं है तो वो कैसे heat होगा?
Because in the graph it was at the end it is shown that it is tapering towards the positive side in exosphere. So why is that?
No, it is tapering, but you can see that the temperature will increase if, let's say, simply any matter is there, any material is there, तो वहां पर टेम्परेचर बढ़ेगा.
But there is no air there, so how can temperature?
नहीं है, वही मैं बोल रहा हूँ, वहां पे नहीं है, बट रेडिएशन लेवल्स बहुत ज़्यादा है. अगर समझो हम सैटेलाइट या हम खुद भी जाते हैं या कोई भी चीज़ होती है तो वो बहुत ज़्यादा सीवियरली हीट होगा वहाँ पे रेडिएशंस की वजह से आइडियली.
Like the surface of moon, it is frozen because the temperature is very low.
Yes.
That is why.
No, same way I'm telling you, Earth's surface could be frozen if there was no, we can say, greenhouse gases, atmosphere. तो वहाँ पे नहीं है ना atmosphere वैसे. तो जितना हीट कर रहा है वो लूज भी तो कर रहा है फिर immediately. ऐसा है, ठीक है.
My question was regarding the graph only, that why it is moving in a positive direction.
नहीं, वो ग्राफ इसीलिए है क्योंकि जितना भी जो मतलब रेयरिफाइड एटमॉस्फेयर होगा उसका टेम्परेचर वो बता ऐसे. Heat budget, I guess most of you might have already understood. There is no problem.
Polar winds are dry winds, right?
Polar?
Polar winds, they are dry.
Yes, they are dry
In the
winds.
previous slide, it was written that they are not. Can you go back?
Which one?
In dust particles, the fourth point here.
Okay, due to dry winds in comparison to equatorial. Dry winds ही बोला है ना?
No, sir. Like the high concentration of dust particles is found in subtropical and temperate regions due to dry winds. In comparison.
Okay. हाँ. Okay, that part. Okay, see, concentration of dust particles, dry winds. See, of course, moisture उस angle से नहीं ले रहे हैं यहाँ पर. Rather, winds that are blowing in the subtropical areas, the desert-like regions or temperate regions, तो वहाँ पे क्या होता है कि dust particles ही ज़्यादा होता है in general, ठीक है. वहाँ पे polar area में dust particles ही कम हो गए बहुत.
So it has not to do with the dryness of the
नहीं, वो वाला नहीं होगा, but यहाँ पे dry winds हो गए
because of the
ऐसा.
particles.
हाँ, इसलिए. Okay. Yes, heat budget. Quickly, let's try to understand heat budget. Incoming and outgoing solar budget. Of course, it is balancing. That's why it is not excessively heated or cooled. ठीक है. तो whatever Earth is gaining, it is losing also. So let's try to budget that. Incoming solar radiation, solar short wave radiation. Incoming जो होगा, short wave होगा. Let's imagine that it is 100% total incoming solar radiation. Now, out of that 100%, 27% is reflected from the top surface of clouds. Clouds white surface होता है तो albedo है उनका काफी ज़्यादा, so reflect कर देगा. 27% reflected by the cloud back to the space. Now, 2% that is falling on the Earth's surface is also going back to the space through reflection. The albedo of different surfaces, especially the surface covered by ice. Surface covered by ice, 2%. So total कितना चला गया है? 29%. It is gone to the space. Now, out of remaining, we have 23% being scattered by the dust particles. 23% is being scattered by the dust particles, and scattering can happen in any direction. Out of that 23%, 6% is scattered back to the space, and remaining 17% is scattered towards the Earth's surface. And Earth is absorbing that 17%. Okay, Earth is absorbing that. Now, 14% is absorbed by the atmosphere and it is keeping that with itself. Okay, 14% it is keeping. Largely it is basically ozone. Okay, ozone layer, atmosphere, incoming solar radiation or water vapor, some amount of water vapor. So they are absorbing that. Now how much is received by the Earth's surface? Directly 34%. Directly falling on the Earth's surface and absorbed by the Earth's surface, 34%. Now, till this point, how much is absorbed by the Earth's surface? 51%. How much is there in atmosphere? 14%. So 51 plus 14, 65. Remaining 35 is gone already to the space. So Earth is having at present 65%. 51 plus 14%. Let's budget that for outgoing budget. Outgoing solar radiation. यहाँ तक समझा है? हाँ, क्या नहीं समझा है? ठीक है नहीं, ब्लैंक एक्सप्रेशन से हो तो ठीक है. लॉन्ग वेव रेडिएशन, ठीक है. लॉन्ग वेव रेडिएशन में क्या होगा? अब ये 65% इट विल गो टू द स्पेस. हाउ? लेट्स ट्राई टू अंडरस्टैंड. Out of this 51%, it is emitted in a different manner. First of all, as a long wave terrestrial radiations, 23%. Long wave terrestrial radiations, 23% radiation from the Earth, because Earth is also acting as a black body or heated body. ठीक है, तो वो क्या करेगा? Emit करेगा terrestrial radiation 23%. Out of that 23%, 6% is absorbed by the atmosphere, greenhouse gases. वो absorb करेंगे 6%, and remaining 17% is going to the space. ठीक है. Now 9%, we are talking about this 51%, no? 23% चला गया. 9% turbulence and convection. Now convection. So when the Earth's surface is getting heated, the air which is in contact with the Earth's surface is also getting heated, and that air is moving up through convection and turbulence. Convection. When it is moving up in the upper atmosphere with altitude, it is going to lose that heat to the surrounding atmosphere, and that is 9%. So now it is in atmosphere. Now it is in atmosphere. This is also in atmosphere. Okay, 9%. Then 19% is through condensation. How? Earth's surface is also having water. So when the light is falling or radiation is falling on the water, it is getting heated and it is getting evaporated. Along with air, the water vapor is also moving up, and when it is moving up, latent heat of evaporation is lost. Through condensation process, that extra heat is lost, no? That is lost to the atmosphere. Okay. Now, 6%, 9%, 19%. How much it is? It is 34? 34%. Plus, कितना था ये? 14% पहले से ही था. कितना हुआ? 48%. Already 17% चला गया है. Ultimately, atmosphere will also release that 48% back to the space. जो चीजें डायरेक्ट हो रही है वो बहुत जल्दी जल्दी हो रही है. रिफ्लेक्ट जल्दी हो रहा है, रेडिएट भी जल्दी हो रहा है. बट दीज आर स्लो प्रोसेस, कंटिन्यूअस प्रोसेसेस. कंडेंसेशन और टर्बुलेंस, टाइम लगता है उसको. बट अल्टीमेटली हीट मेंटेन्स द बजट और अर्थ मेंटेन्स द बजट. ठीक है. So this is the heat budget, or this is latitudinal heat budget. Latitudinal heat budget means what? The Earth is receiving more or surplus heat in the tropical regions and deficit in the higher latitude. Now, through the movement of planetary winds and ocean currents, this heat is redistributed. Okay, and that's why latitudinal budget is maintained, and that's why tropical areas are not excessively heated or polar areas are excessively cooled. ठीक है. So हाँ बोलो.
The rise in concentration of greenhouse gases is causing global warming. But as per the diagram, only 6% of the total radiation is by greenhouse gases. So what about the rest? So in order to control global warming, should we focus on the rest as well?
Like, see, water content is same.
We can't control any.
ठीक है, वो तो सेम रहेगा. टर्बुलेंस एंड कन्वेक्शन वी कैन नॉट कंट्रोल लार्ज स्केल. तो बचता क्या है? एक ये है जो जहां मतलब ये कंट्रोल कर सकते हैं ना. दैट्स व्हाई वी आर टॉकिंग अबाउट शूटिंग द मिरर्स इन द स्पेस एंड ऑल दिस थिंग्स. यू रिफ्लेक्ट कर दो, है ना. रिफ्लेक्ट कर दो. हम ज्यादा से ज्यादा एब्जॉर्ब कर रहे हैं. हम अब सोलर एनर्जी के प्लांट्स लगा रहे हैं तो और एब्जॉर्ब करके ले रहे हैं हम. ठीक है, रिफ्लेक्ट करना चाहिए तो और एब्जॉर्ब किए जा रहे हैं. वी आर क्लियरिंग द फॉरेस्ट, चेंजिंग द अल्बिडो, ठीक है, तो रिफ्लेक्ट जो हो रहा था वो नहीं हो रहा है, रादर हम और ज्यादा एब्जॉर्ब करे जा रहे हैं. तो ये भी बोलते हैं ना कि क्या बोलते हैं हम, सीडिंग द क्लाउड्स, तो वो भी एक बोल रहे हैं क्लाउड से क्या होगा, रिफ्लेक्ट हो जाएगा, लार्ज स्केल पे होगा. सो वी शुड फोकस ऑन दैट. ऑफ कोर्स वी आर वर्किंग ऑन दैट डायरेक्शन. जियो इंजीनियरिंग टेक्निक्स.
All the major issues that are there is due to the 6%.
हाँ, कम ही है. देखा जाए तो आप देखिए ना कि CO2 का अमाउंट 0.0 इसमें चेंज हुआ है. अगर 0.1 वगैरह हो जाएगा तो खत्म ही हो जाएगा सब. प्रोपोर्शनेट, वेरी लेस प्रोपोर्शनेट अगर देखा जाए तो. दूसरा मैं भी एक प्रपोज करता हूँ टेक्निक जो आप आंसर में लिख सकते हैं. आप CO2 कैप्चर करके क्यों ना स्पेस में दूसरे प्लैनेट्स में भेज दो, उसको शूट कर दो ना. नहीं, एक्सपेंसिव है, बराबर है, बट आप वैसी टेक्नोलॉजी लाओ कि उसको कॉम्प्रेस करके ऐसा कुछ करो कि हम देखो स्पेस को समझने के लिए इतने एक्सपेंसिव चीजें भेज रहे हैं. अब देखिए, अब ऐसे भी स्पेस रेस शुरू हो चुका है, अब प्राइवेट सेक्टर, और वो सस्ता हो जाएगा धीरे धीरे, सब घूमने भी जाएंगे लोग, ठीक है. हाँ, तो ये कर सकते हैं, तो ये तो करना ही चाहिए, ये टेक्नोलॉजी पे वर्क करना ही चाहिए कि आप CO2 आप बीच फिर से अर्थ के अंदर डालने की बात कर रहे हो, वो आएगा बाहर कभी ना कभी आगे भी. कितना आप अंदर रखोगे ना उसको, ठीक है. अब स्पेस में भेज दो उसको, कोई टेंशन नहीं है, वो अर्थ की तरफ आएगा नहीं. ऐसा कुछ सोचना चाहिए. ऑफ कोर्स तो वो भी एक हाइपोथेटिकली सिनारियो है, जैसे ये भी है मिरर्स वाला भी, ठीक है.
So these clouds that we're talking about which are reflecting, these are the ones in the lower atmosphere, right? Because if
Yes, very good. There was question in 2022, I guess. Upper clouds and lower clouds. So lower clouds are generally denser and dark clouds, but their upper surface of those lower clouds is white. Okay, and lower surface is dark, like nimbus clouds. Nimbus clouds, right? So like cauliflower, ऊपर से जो white हो, नीचे से dark base होता है उनका. So these clouds are reflecting more the incoming radiations, while upper clouds like cirrus clouds, so they are rarefied clouds, and these clouds are absorbing the outgoing radiations. That's why keeping warm atmosphere. ठीक है, वो एक क्वेश्चन था. ओके, ये क्या है, फैक्टर्स अफेक्टिंग टेम्परेचर डिस्ट्रीब्यूशन. कॉन्सेप्ट बेस्ड क्वेश्चन बनता है इस पे अगेन. ओके, लैटिट्यूड. Of course, the temperature of place depends on the insolation received. ये visible नहीं होगा ठीक से, यहाँ पे मैं इसको zoom कर देते हैं. Okay, so temperature depends on the place of the place depends on insolation received. Of course, so solar radiation, more the solar radiation, more the temperature. Okay, insolation varies according to latitude. That is also true. In the tropical region, more insolation is received as compared to temperate and polar. Higher the latitude, less is the angle they make, solar rays or sun rays, with the surface of the earth, resulting in slant sun rays. The area covered by vertical rays is always less than slant rays, and that's why they are heating more. Second reason, the slant rays are also passing through longer distances in atmosphere. So there is chance that they are more scattered, absorbed by the dust particles in the atmosphere, and that's why the energy received on the earth's surface is less. ठीक है, if more area is covered, the energy gets distributed and received per unit area is decreased. Also, the slant rays are required to pass through greater depth of atmosphere, resulting in more absorption, scattering and diffusion. Altitude. The atmosphere is directly heated by terrestrial radiation from below. So that's why as there is increase in altitude, there is decrease in temperature. Normal lapse rate, very simple. Then distance from the sea compared to land, the sea gets heated slowly and loses heat slowly. This is because of higher specific heat capacity of the water. Okay, what happens, simple concept है, ठीक है. Suppose this is the solid earth surface, and suppose this is the water. So water is connected continuously with each other, right? And there is scope for convection in the water. So if the upper surface is heated, always there is scope that there is convection within the water. So there is always scope to absorb more and more, क्योंकि वो इतना जल्दी हीट ही नहीं हो रहा है. But land, if you see the upper surface, if it is getting heated, there is no scope for easy transfer. Conduction इतने जल्दी नहीं होगा जितना जल्दी कन्वेक्शन होगा. ठीक है, तो इसलिए अर्थ जो है जल्दी हीट हो जाता है. अर्थ सरफेस, ऊपर का लेयर जल्दी हीट होगा और उतना ही लेयर हीट हो गए वो रिलीज भी कर देगा रात को हीट. ओके, then the places situated near the sea come under moderating influence of sea and land breezes which moderate the temperature. Very simple. And that's why interiors of India, North India, if you see, extremities of temperature during summer and winter. But coastal India, if you see, moderate temperatures. Air mass and ocean currents. Yes, places which come under the influence of warm air masses, higher temperature, cold air masses, cold. Same warm ocean current, cold ocean current. ठीक है. Then duration of sunshine. So during summer there is more sunshine, duration of sunshine, so more heat is received. During winter, less heat is received. Transparency of atmosphere, dust particles, they scatter the light and reduces the amount of. Then aspects of slope. The south slope, if you see, the sun facing slope of Himalayas, it receives more heat as compared to northern slope. ठीक है, so because of that what happens? More heated southern slope as compared to northern slope. Then moderating effect of sea, just now we have learned about that. ठीक है, तो ये हो गए टेम्परेचर के फैक्टर्स. डिस्ट्रीब्यूशन ऑफ टेम्परेचर. नाउ इसी पे क्वेश्चन बनता है आपका. हाँ, आइसोथर्म्स वाला. अब देखिए ये सेम डॉक्यूमेंट मैंने पिछले साल पढ़ाया है. एग्जैक्टली पेपर में ऐसा क्वेश्चन आया है. एग्जैक्टली. तो इसलिए फैकल्टी की थिंकिंग आपको समझनी है क्यों जरूरी होता है. ऐसे ही आया स्टेटमेंट 1, स्टेटमेंट 2, रीजन. और ये यहाँ पे वार्म है ना, ये कोल्ड कर दिया है बस चेंज करके. बट एनसीईआरटी में तो प्रॉपर स्टेटमेंट्स है ना, बट हमें पता है कि वो किस तरीके से क्वेश्चन आएगा, असर्शन एंड रीजन. चांसेस तो है, इतने भी नहीं बढ़ाएंगे. ठीक है, 1-2 अभी आए थे तो 5-6 पूछेंगे, हर सब्जेक्ट से पूछेंगे. देखो वो क्वेश्चन पूछने का स्कोप कहाँ होता है, जहां पे कॉज इफेक्ट है. नहीं तो रैंडम थोड़ी पूछ सकते यूपीएससी. वो चलो 3 स्टेटमेंट दे दिए, कोई रिलेशन ही नहीं है इसका. तो इसी वजह से वो ऐसे 30-40 क्वेश्चन नहीं आएंगे. हमने एक क्वेश्चन इस बार दिया था. दो एक्सप्लेनिंग स्टेटमेंट है ना, तो बिल्कुल ठीक है. तो वो थोड़ा कंफ्यूजिंग है. डोंट वरी, ठीक है. मैं इसलिए बोलता हूँ स्टूडेंट्स को कि ह्यूमन अगर सर्वाइव किया है तो किस क्वालिटी की वजह से. हाँ, वेरी गुड, इतने जल्दी बता दिया. तो वो 2 घंटे में अडॉप्ट क्यों नहीं करते हो आप? वो 2 घंटे में आप अडॉप्ट करो यार, मुझे वो बोलना है. वही सरवाइव करेगा. और ये रियलिटी है. जब अगर वहां पे आप नहीं कर पाए ना अडॉप्ट तो मुश्किल हो जाएगा. सो इन जनवरी मंथ आइसोथर्म्स डेविएट टू द नॉर्थ ओवर द ओशन एंड टू द साउथ ओवर द कॉन्टिनेंट्स. सो इट इज जनवरी मंथ आइसोथर्म्स. And it is more pronounced during January as compared to June during summer. What happens here? What is this ocean current moving here? So this is warm ocean current, Gulf current, and then thereafter North Atlantic drift. It is bringing warmer waters to the higher latitude, and that's why the ocean surface has warmer temperature in higher latitudes, and that's why isotherms deviate to the north. but the land is getting quickly cooled during winter. It is losing more heat, and that's why isotherms deviate south over the land. Very simple. ठीक है, तो ये बट अगर सदर्न हेमिस्फीयर में देखेंगे तो दिस इज नॉट मोर प्रोनाउंस्ड बिकॉज land is less as compared to ocean surface, and ocean surface will always try to have uniform temperatures. Redistribution जल्दी हो जाएगा वहां पे, ठीक है. So it's very simple. Presence of warm ocean currents like Gulf Stream, North Atlantic drift is there, and then over the land temperature decreases sharply. The effect of ocean is well pronounced in the southern hemisphere. Here the isotherms are more or less parallel to the latitude. The variations in temperature is more gradual than the northern hemisphere. In July, the isotherms generally run parallel to the. तो पूछेंगे तो वो जनवरी का ही पूछेंगे. अब लास्ट ईयर पूछ लिया है तो ये नहीं आएगा अभी, ठीक है. इन्वर्जन ऑफ टेम्परेचर, इट इज ऑल्सो पेंडिंग क्वेश्चन, बहुत साल से नहीं पूछा है, ठीक है. सो दे कैन आस्क क्वेश्चन. Inversion of temperature simply whenever we see the change or reversal of normal lapse rate, that is increase in temperature with increase in altitude. So simply that is called as inversion of temperature. Now there are some ideal conditions for inversion of temperature. These are the ideal conditions. Long winter nights. Okay, so long winter nights will help for loss of heat. ठीक है. Cloudless and clear sky will also help in loss of heat. ठीक है. Heat from the earth we are talking. Presence of dry air near the ground surface. किस लिए? हाँ, turbulence और वो नहीं चाहिए हमें. If there is water vapor in the let's say lower air, so it will try to move up. तो हमें क्या चाहिए? Downward movement चाहिए wind का for inversion of temperature. तो वो नहीं होगा ना. Slow movement of air, especially horizontal movement. Otherwise, it will disturb the conditions, redistribute the heat. So that is not suitable. Then snow-covered ground surface that is having high albedo, quickly losing the heat. ठीक है, तो it will cool down the surface. So that is ideal conditions. Now, yes, climatological implications. Of course, first of all, fog will be created that affects the visibility and crops. Okay. Thereafter, it can result into smog, like that Delhi NCR region that experiences during winter. Smog, harmful for human health. Then frost affecting crops, especially in valley inversion. Valley inversion क्या होता है? Yes. So during night time, so during daytime, this extensive surface provides the let's say surface for heating. So what happens is the air from the valley will move like this. This is sun. Okay, so it is moving like this, it is moving like this, and then it is during daytime. During night time, what happens? Exactly opposite of this, and there is no sun. So what happens? This surface and this surface is losing the heat quickly. And because of that, it becomes cool, and the air which is coming in contact with it, it will get heavier, cooler and heavier. And under the influence of this gravity slope, it will move towards the, this is called as air drainage or katabatic wind. Katabatic wind or air drainage. Now here, this cold wind is accumulated in the valley region that may result into excessively low temperature frost formations, valleys. So they are not suitable for crops, not suitable for even human habitations, and that's why we see agriculture practice in the mountainous region in the upper slopes, or human habitations are in upper slopes because of this reason. ये भी assertion and reason आ सकता है. हाँ? ऐसा कुछ नहीं है, जनरली लो प्रेशर वगैरह नहीं है, ठीक है. ज्यादातर ये टेम्परेचर का खेल है, रात और दिन का, ठीक है. डे एंड नाइट टेम्परेचर्स जो होते हैं, मॉर्निंग टेम्परेचर्स आर वेरी कोल्ड हियर, अर्ली मॉर्निंग, सो फॉग एंड फ्रॉस्ट इज वेरी कॉमन, ठीक है. ड्यू एंड मिस्ट तो होता ही है, बट कभी कभी फ्रॉस्ट भी होता है वहां पे. Then at some places it is favorable, like the Yemen hills, coffee plants in Yemen hills of Arabia, which provides necessary moisture conditions through fog, ठीक है, for growth of those coffee plantations. Otherwise बहुत harmful है. Inversion, ये वैली इन्वर्जन है. हाँ, डे एंड नाइट होता है, समझो ऐसे, ठीक है, डे एंड नाइट होता है, बट ग्राउंड इन्वर्जन इज ड्यूरिंग विंटर, ठीक है, जो सरफेस इन्वर्जन जिसको बोलते हैं, ठीक है. ये जो है कंडीशंस किसके लिए? सरफेस इन्वर्जन के लिए. और मैंने जो बताया वो टाइप वैली इन्वर्जन का है, ठीक है. अलग अलग टाइप्स है, टाइप्स ऑफ इन्वर्जन में, तो ये दो टाइप याद रख सकते हैं आप. ओके, एटमॉस्फेरिक प्रेशर एज अ कॉन्सेप्ट यू शुड नो व्हाट इज एटमॉस्फेरिक प्रेशर. It is the weight of air column above the per unit area on the land surface, ठीक है. तो वो क्या हो गया आपका? Weight of column of air contained in unit area from the mean sea level to the top of atmosphere is called as atmospheric pressure. Okay, it is expressed in the unit of millibars and it is measured with the help of mercury barometer or aneroid barometer. Then at sea level the average pressure is 1013.2 millibar. So whenever you will see the isobars, they are around this figure, okay, 900 to 1000 something like that, okay, millibar. And due to gravity the air at the surface is denser and hence the higher pressure. So why do we have higher pressure near the Earth's surface? Because of density of the air. Density of air is more near the Earth's surface as it is getting attracted due to gravity. ठीक है, तो इसलिए वहां पर सबसे ज्यादा एयर प्रेशर होता है सरफेस पे. एंड दैट प्रेशर गोज ऑन रिड्यूसिंग एज वी मूव इन द एटमॉस्फेयर. Our body is also subjected to this atmospheric pressure, but the pressure from inside our blood vessel balances that, and that's why our body fluids are not coming out. That's why there is bleeding through nose and ears of the mountaineers. Mountaineers जो ऊपर हाइट पे जाते हैं हाइकिंग करके, तो चांसेस होता है उनको. Why? Pressure decreases. Outer pressure is less, body pressure is more. The fluids flow from high pressure to low pressure. ठीक है. Then सेम इंक पेन वाला एग्जांपल एरोप्लेन का देते थे हम स्कूल में, है ना. इंक पेन एरोप्लेन में लेके नहीं जाना चाहिए, इंक बाहर आ जाता है, बोलते हैं ना. हाँ, pressure decreases with height because air gets rarefied with increasing height. If we reach to the higher altitude, the blood may come out of nose. ठीक है, ये हो गया. Air in horizontal motion is wind. ठीक है, air in motion is wind, simple ऐसे याद रख सकते हैं. And when the air is moving in the horizontal direction and transferring the heat, that is called as advection. That is called as advection, है ना. Radiation, conduction, convection, advection, ऐसे याद रखिए आप. ठीक है, wind moves from high pressure areas to low pressure area, that is for sure. ठीक है. Now why don't we experience strong upward winds as compared to horizontal winds? We say that there is high pressure near the ground and low pressure near the upper atmosphere. So ideally the wind should move from high pressure to low pressure, but such kind of updrafts are not common as compared to horizontal high pressure low pressure. Quickly there will be movement, but ये नहीं होता है. क्यों? Simple, gravity is counterbalancing that. ठीक है, क्या हो रहा है? Counterbalance कर रहा है. So the vertical pressure gradient force is much larger than the horizontal pressure gradient, but it is generally balanced by nearly equal and opposite gravitational force. Then the low pressure system is enclosed by one or more isobars with the lowest pressure at the center. Low pressure system has closely spaced isobars. So if I want to show the low pressure system, it will be somehow like this. सेंटर पे लो प्रेशर होगा ऐसे, एंड इफ आई वांट टू शो हाई प्रेशर लाइक दिस, ये क्या होगा, फार्दर डिस्टेंस पे होंगे ये ऐसे आइसोबार्स, ठीक है। लो प्रेशर पे क्विकली प्रेशर चेंज होता है शॉर्ट डिस्टेंस पे, दैट्स व्हाई दे आर क्लोजली स्पेस्ड आइसोबार्स, ठीक है। हाई प्रेशर के यहां पर बहुत ही धीरे धीरे प्रेशर चेंज होता है डिस्टेंस के साथ, ओके। तो ये कॉन्सेप्ट है हाई प्रेशर सिस्टम, आइसोबार्स लोकेटेड कंपैरेटिवली एट फार डिस्टेंसेस. Now this is given, some of them are given in GC Leong, some of them are, I have also let's say taken from internet. समझो मैच द फॉलोइंग क्वेश्चन आ भी गया आपको, तो वैसे आजकल पूछते तो है नहीं ऐसे क्वेश्चन. Atmospheric pressure measuring instrument barometer and the line joining the places having same pressure isobars. Rainfall, rain gauge, आइसो हाइट, ठीक है. टेम्परेचर थर्मामीटर आइसोथर्म. ह्यूमिडिटी हाइग्रोमीटर, ह्यूमिडिटी इज हाइग्रोमीटर, आइसोह्यूम, ठीक है, ये याद आ जाएगा आपको, ये मुश्किल है थोड़ा. एनोनोमीटर, विंड एनोनोमीटर आइसोटैक, ठीक है. देन सनशाइन, सन डायल, आइसोहेल. Clouds, isoneph. Atmospheric density, isostare. Depth, isobath. Intensity of radiation, isodose. ये आप रिवाइज करेंगे बाद में, ठीक है, इसको आप रिवाइज करिए. सैलिनिटी, आइसोहेलाइन, वो तो याद रहेगा, ठीक है. आपके पोर्टल पे मैं 3 डॉक्यूमेंट अपलोड करवा रहा हूँ. दिस वन, देन वन फॉर रिसोर्सेस ऑफ इंडिया एंड वर्ल्ड, and other is industries of India, ठीक है. and they will be largely map based, map पे delineation किया हुआ है, and some facts I have written there, तो उससे रिवीजन हो जाएगा आपका बेसिक चीज का, ठीक है. ओके, then wind circulation around the low and high pressure regions, ठीक है, एरियाज. ये NCERT में ऐसा टेबल दिया हुआ है आपको, ठीक है. व्हाट इज दैट टेबल? This is northern hemisphere, this is southern hemisphere. Now how the wind circulates direction around the low pressure in northern hemisphere? It is anti-clockwise, ठीक है. low pressure anti-clockwise, and in southern hemisphere clockwise. ये pictorial representation है उसका. Then anticyclone is basically high pressure. Anticyclone is high pressure, and in northern hemisphere it is clockwise, and in southern hemisphere it is anti-clockwise. ऐसे याद रख, कोई भी एक याद रखना है, चारों याद आ जाएंगे, ठीक है. कोई भी एक याद रखना है. जनरली लो प्रेशर इन नॉर्दर्न हेमिस्फीयर याद रखना है, एंटी क्लॉकवाइज, क्योंकि वो साइक्लोन में भी काम आएगा, ठीक है. देन व्हाट इज दिस इंफॉर्मेशन? डिड यू नो halos around the sun or moon are caused by both refraction and reflection of sunlight by ice crystals in the cirrus clouds. Have you seen that? बचपन में कभी देखा होगा हेलो तैयार होते हुए सन के अराउंड. मतलब कभी कभी बहुत ही क्लाउडी हो जाता है, बट वो व्हाइट क्लाउड्स टाइप के छोटे छोटे क्लाउड्स होते हैं ना, फीदरी क्लाउड्स से भर जाता है, और सन उसके अंदर से छोटा सा ऐसे दिखता है. कभी कभी उसके अराउंड एक हेलो तैयार होता है ऊपर. कार्टून में देखा है? वेरी गुड, चलो कहीं तो देखा है. तो वो जो क्लाउड्स होता है वो सिरस क्लाउड्स है, हायर क्लाउड्स. सिरस क्लाउड्स होते हैं हायर क्लाउड्स है, वो तैयार करता है. ये मून को भी करता है, कभी मून का भी आप देखेंगे, ठीक है. तो ये रिफ्रैक्शन एंड रिफ्लेक्शन ऑफ सनलाइट बाय आइस क्रिस्टल्स इन सिरस क्लाउड्स. Then rainbow is caused due to reflection, refraction, dispersion, total internal reflection of the light by water droplets. तो rainbow, ठीक है. रेनबो कैपिटल ऑफ द वर्ल्ड सुना है कभी? अभी मैंने रिसेंटली कोई प्रीलिम्स मंत्रा में कहीं तो द हिंदू में आया हुआ था आर्टिकल एक.
It's in USA, the location. I guess.
हवाई, हाँ हवाई में है, बराबर है. ठीक है, द हिंदू में आया था, ऐसे एक कॉर्नर पे आता है ना साइंस पेज पे नीचे. ठीक है, तो वहां पे एक्सप्लेन बोल के आया था वो. हवाई. ओके, रेनबो कैपिटल ऑफ द वर्ल्ड. एक लाइटनिंग कैपिटल ऑफ द वर्ल्ड भी है, कोई एक साउथ अमेरिका में प्लेस है. ठीक है, तो वहां पे सबसे ज्यादा लाइटनिंग होता है, मतलब कंटिन्यूस होते ही रहता है लाइटनिंग वहां पे. चलो वो हो गया आपका. ठीक है. ओके, जनरल सर्कुलेशन पैटर्न, ट्राइसेलुलर सर्कुलेशन. इसमें समझने वाली का ज्यादा कंफ्यूजन है इसमें कोई? ये क्लियर है, बट इससे हम एक चीज समझ के लेंगे कि प्रेशर बेल्ट्स कैसे तैयार हुए हैं. ओके, सो देयर आर टू टाइप्स ऑफ प्रेशर बेल्ट्स ऑन द अर्थ. वन इज थर्मली created and other are dynamically created. Okay. ठीक है, thermally created, dynamically created. तो thermally created, there are two such pressure belts. One is, we can say, equatorial belt, and other is polar high pressure belt. And dynamically created, these two are dynamically created. ठीक है, सब ट्रॉपिकल हाई प्रेशर बेल्ट एंड सब पोलर लो प्रेशर बेल्ट, दे आर डायनामिकली क्रिएटेड. ओके, डायनामिकली इज बेसिकली बिकॉज ऑफ रोटेशन ऑफ द अर्थ. इतना ही याद रखा उसको, ज्यादा सोचो मत आगे का. ठीक है, सिंपल है, अर्थ रोटेट होता है तो उसकी वजह से क्या होगा कि कुछ जगह पे जो विंड है नीचे आएगा, कुछ जगह पे विंड जो है नीचे से ऊपर जाएगा बिकॉज ऑफ रोटेशन ऑफ अर्थ. इसके आगे यूपीएससी पूछेगा भी नहीं, so don't worry about that. And because of these, let's say, pressure belts, the wind that is moving from high pressure to low pressure in these areas, they are called as planetary winds now. Okay, along the surface, they are called as planetary winds. So these are like from subtropical high pressure to equatorial low, they are called as, yes, trade winds or easterlies. Trade winds or easterlies. And of course they are deflected because of Coriolis force, to the right in the northern hemisphere, to the left in southern hemisphere. So from subtropical high to subpolar low, they are westerlies. And from polar high to subpolar low, they are easterlies. ठीक है, इस तरीके से. So and then accordingly what happens is there is a cell created. This one is Hadley cell, this one is Ferrel cell, and this is polar cell. ठीक है, आपको ये पता है तो बेसिक. Periodic winds. So first is planetary winds, of course, trade winds and planetary winds. So उस 2-3 चीजें मैं बता देता हूँ applied. Trade winds, why they are called as trade winds? So during ancient times, it was very useful for trade, for all those traders, especially Arab traders. Because trade winds are continuously blowing in one direction throughout the year, so that helps for ships. That's why trade winds. Then thereafter you should understand how it affects the climate. For example, monsoon phenomenon. So monsoon is nothing but the reversal of trade winds, a seasonal reversal of trade winds. ठीक है, तो वो उसका एक सिग्निफिकेंस है ट्रेड विंड्स का. और इफ यू सी द ईस्टर्न मार्जिन्स ऑफ द ट्रॉपिकल एरियाज, they receive rainfall throughout the year because of trade winds. I told you कौन सा बोल रहा हूं मैं, ईस्टर्न मार्जिन्स ऑफ ट्रॉपिकल एरियाज. But western margins of tropical areas, they remain dry. Why? Because offshore trade winds are there. Offshore trade winds. And that's why you can see the tropical deserts, they are along the western margins. Western margins pe hai, tropical areas mein, this thing. Then thereafter, the horse latitudes. 20 to 30, they are horse latitudes, 20 to 30. And this region is basically subtropical high pressure belt. Subtropical high pressure belts. So, जब high pressure है तो wind arrives and stays there. मैं हमेशा क्लास में ये बताता हूँ टेक्निक याद रखने का. Pressure, how to identify the high pressure and low pressure. If the wind is coming at a place and staying there, that is going to create high pressure. If the wind is leaving the place, that is going to create low pressure there. Okay. So subtropical high pressure, so it is high pressure, the wind is coming from let's say top and it is staying there near the ground, and that's why it is creating high pressure, and that creates a kind of stable environment, atmospheric stability, and the wind is feeble, मतलब speed नहीं है wind movement का. And that's why the traders during ancient times, they used to throw the horses into the ocean to reduce the weight for rowing purpose. Horses are natural swimmers. ठीक है, वो swim कर लेते थे. तो ये technique use करते थे. That's why it is called horse latitudes. Then there is westerlies. Westerlies. So how, let's say, westerlies affect the climate? The major impact is, we can say, Mediterranean climate. Mediterranean climate. So Mediterranean region is 30 to 40 degree north and south. And in that region, during summer, this region comes under the influence of offshore trade winds. And during winter, it comes under the influence of onshore westerlies. Onshore westerlies bring the rainfall, moisture with it, rainfall, and that's why the unique climate is the dry summers and mild and wet winters. ठीक है, तो ये है Mediterranean type of climate. Then westerlies also bring the warmer temperatures along the western margins of higher latitudes or higher continents, like western margins of Europe. So it is bringing the moisture also, warmer conditions as well as moisture also. ठीक है. Along with that warm ocean currents are also reaching there. That keeps that region warmer, and also we can say the ports all around the year. ठीक है, even in higher latitude. ये westerlies का significance है. Westerlies and polar easterlies, they together help in formation of, we can say, extraterrestrial cyclones or temperate cyclones. Now, in southern hemisphere, these westerlies have specific names. At 40 degree latitude, furious 40s, 50, roaring 40s थे ना, roaring 40s, furious 50s, shrieking 60s. ठीक है, तो southern hemisphere में ये तीन याद रखना है, 40, 50 and 60. Thereafter, ठीक है, ये आपको समझ गया है. Now the periodic winds. ये planetary winds हो गया, तो periodic winds देखना है. Periodic means, of course, after certain time period they are changing the direction. For certain time period they are blowing in one direction. So they can be divided into two parts. ठीक है, तो ये क्या है? Seasonal wind. ठीक है, ये seasonal है, ये diurnal है. Seasonal मतलब क्या है? 6 महीने के लिए, 4 महीने के लिए. Diurnal मतलब daily, day and night. So example, monsoon winds. आज हम end में पढ़ेंगे monsoon अलग से. ठीक है, monsoon phenomenon. Here you can see that particular time period the winds are moving in this direction and then reverse. What happens here? day and night phenomenon. During daytime, what we see here, the land is quickly heating, it is becoming warm, and that's why low pressure is created here. Comparatively, sea is cooler, and that's why high pressure is created here, high pressure to low pressure. So there is sea breeze during the daytime. And during night time, what happens? This is quickly cooled. तो ये हाई प्रेशर हो गया, कंपैरेटिवली दिस इज वार्मर, लो प्रेशर हो गया, लैंड ब्रीज. ठीक है, लैंड ब्रीज सेम अभी जो हमने पढ़ा था माउंटेन्स और वैलीज में. ठीक है, वैली इन्वर्जन जो वाला कॉन्सेप्ट सेम है, वही है. ठीक है. एंड देन लोकल विंड्स. लोकल विंड्स आपने पढ़े हुए हैं, क्विकली आप ये रिवाइज कर लेना बाद में. लोकल विंड्स ऑफ मेडिटेरियन रीजन आर इम्पोर्टेंट, तो उसको ज़्यादा इम्पोर्टेंस देना है. ठीक है. जीसी लियोंग से और नेट से मैंने 2-3 और भी लिए, ट्रेमोंटेन, ग्रिगेल, ये पढ़ लेना आप नोट्स में से. ठीक है, ये है, आप ये वाले याद रखना है ज़्यादा. तो ये ठीक है. कंडीशंस फेवरेबल फॉर फॉर्मेशन ऑफ ट्रॉपिकल साइक्लोन्स, वेरी इंपॉर्टेंट. ठीक है. ट्रॉपिकल साइक्लोन्स आर बेसिकली द लो प्रेशर सिस्टम्स wherein the wind is moving around the low pressure point over the ocean surface in the tropical areas. ठीक है, in the tropical areas. तो उनको क्या बोलेंगे हम? Tropical cyclones बोलेंगे. Important conditions: large sea surface with temperature higher than 27 degrees Celsius. Why? Because it is source of energy. Latent heat of condensation. ठीक है, latent heat of condensation, that is the source of energy here for driving the cyclone, and that's why when it makes landfall, its source of energy is cut off, and that's why cyclone dissipates once it make landfall. Second, presence of Coriolis force. Now why it is important, Coriolis force? इस साल भी एक क्वेश्चन कोरियोलिस फोर्स पे था, वो सिंपल क्वेश्चन था वैसे. ठीक है, तो इसी टॉपिक के ऊपर वो था, हमने कवर भी किया था मुझे जितना याद है. ठीक है, कोरियोलिस फोर्स. व्हाई साइक्लोन्स आर नॉट ऑब्जर्व एट द इक्वेटर? So at equator we have low pressure, but still the wind will try to move and fill in that low pressure directly, instead of deviating or circulating around it. Now here 20 to 20, suppose it is low pressure. What happens when the wind is moving and trying to reach that low pressure? It is deflected like this. It is deflected, and then it creates a kind of anti-clockwise circulation around that low pressure instead of filling that low pressure. This is how cyclone is formed. That's why Coriolis force is very important. And at equator Coriolis force is 0, and ऐसा एक स्टेटमेंट था शायद उसमें, at equator it is 0 and it is maximum near poles. ठीक है, okay. Then small variations in the vertical wind speed. Vertical wind speed जो है ये यूनिफॉर्म होनी चाहिए. इसमें अगर वेरिएशंस हो गए तो कन्वेक्शन इंटरप्ट होगा. Convection is spiral movement of wind in upward direction like this. If that vertical speed is not constant, then there will be obstruction. ठीक है, and that will not intensify the cyclone. Okay. Pre-existing weak low pressure area, this is an ideal condition because that will intensify into cyclone. Upper air divergence above the sea level system. Look at this. When there is upward movement, there is need of outflow like this. This will result into, when there is upper air divergence present here, then only there will be outflow. If there is upper air convergence, that will obstruct the outflow. And if it obstructs the outflow, that means it obstructs the upward movement of wind. So it will not intensify into cyclone. That's why these are the important conditions. ये दो कंडीशंस ही जो हम बोलते हैं 20 to 30 आइडियल, 20 to 30 नहीं, 10 to 20 जो आइडियल लैटिट्यूड्स है इन दो कंडीशंस की वजह से, ठीक है। है ये क्यूमुलस एंड निम्बस क्लाउड्स है, ठीक है। स्ट्रक्चर में भी देख लेंगे, चलो 3 पार्ट होते हैं स्ट्रक्चर में, आई वॉल एंड रेन बैंड्स। आई इज द सेंट्रल रीजन ऑफ लो प्रेशर and generally it is cloudless region with feeble wind speed and warmer conditions, warm air is moving down, subsiding down.
I low pressure.
Low pressure
Subsiding warm air.
नहीं देखो, मेन लो प्रेशर जो होता है वो सेंटर में होगा ना साइक्लोन के। ये सबसाइड इसलिए हो रहा है क्योंकि यहां पर वैक्यूम काइंड ऑफ क्रिएट होता है, तो ऊपर से एयर धीरे धीरे नीचे आ रहा है, ठीक है। क्योंकि मैक्सिमम विंड आई वॉल में ऐसे ऐसे घूम रहा है ऊपर, तो सेंटर पे विंड ही नहीं रहेगा, तो ऊपर से वो तो हल्का हल्का वार्म विंड आता रहता है एंड इट इज क्लियर स्काई देयर। ओके, आई वॉल इज द मोस्ट टर्बुलेंट रीजन एंड हियर देयर इज वी कैन से फॉर्मेशन ऑफ let's say cumulus clouds, cumulonimbus clouds, sorry, towering cumulonimbus clouds are formed here, and you can see that there is outflow from this eye wall region. Now extending from eye wall there are rain bands. Rain bands look like this, ठीक है। ये रेन बैंड्स है, यहां पे देखिए, ये तो क्यूमुलोनिम्बस क्लाउड हो गया आपका मेन, बट उसके बियॉन्ड अगर देखते हैं तो दीज आर द निम्बस क्यूमुलस क्लाउड्स एंड यू कैन सी द साइज गोज ऑन डिक्रीजिंग अवे फ्रॉम द आई वॉल रीजन। अब देखिए यहाँ पे क्या हो रहा है, व्हेन द विंड इज मूविंग अप हियर, सम अमाउंट ऑफ विंड मूव्स डाउन हियर एंड देन इट बिकम्स पार्ट ऑफ दिस रेन बैंड। Then it moves up and some amount of it is moves down in that particular gap, and then again it is moving up. So yes, there is continuous movement of convection movement in these, let's say, rain bands also, but at shorter level as we move away, ठीक है। तो इसलिए वहां पर क्यूमुलोनिम्बस क्लाउड्स नहीं बनते हैं, क्यूमुलस एंड निम्बस छोटे छोटे क्लाउड्स बनते हैं। Understood? So rain bands. Temperature at eye is more comparatively. So eye wall is a cooler region comparatively because of, let's say, cloud formation, turbulence and rain. Cumulonimbus will bring the thunderstorm and lightning and rain. These will also give rain, but the amount of rain goes on decreasing from eye wall towards outside. ठीक है, ये ऊपर से ऐसे दिखता है। ऑल राइट, नाउ द रीजन्स वेयर वी हैव ब्रीडिंग ग्राउंड्स ऑफ साइक्लोन्स, लार्जली दीज आर द एरियाज बे ऑफ बंगाल, अरेबियन सी, साउथ चाइना सी एंड वेस्टर्न पैसिफिक। देन यू कैन सी दिस इज ऑल्सो अ रीजन, and this is the major region, this is also one of the region. So what cyclones are called regionally here? Yes, hurricanes. Here we have cyclones, here we have typhoons, and here willy willy, regional names. ट्विस्टर्स ये होते हैं, टोर्नेडोज होते हैं, टोर्नेडोज नहीं टोर्नेडोज काइंड ऑफ साइक्लोन, बट टोर्नेडोज आर काइंड ऑफ, लेट्स से लैंड पे ज्यादा मिलते हैं। हाँ, ठीक है, बहुत मैक्सिमम स्टूडेंट ने साइक्लोन लिखा होगा, ठीक है। थोड़ा एवरेज मार्क्स दे देंगे वहां पे, 2-3 मार्क्स दे देंगे। मैक्सिमम स्टूडेंट्स ने ऐसा ही लिखा है, ठीक है, ट्विस्टर्स। और उस साल न्यूज में भी था वो, मैक्सिमम टोर्नाडोज वेयर वो ऑब्जर्व इन दैट सीजन। हर साल सीजन होता है यहाँ पे टोर्नाडोज का, सदर्न यूएस में, टेक्सास एंड दैट रीजन, गल्फ ऑफ मैक्सिको रीजन, ठीक है। तो वो देखो ये कॉम्पिटिटिव एग्जाम है।
सर वो आपने कराया था, मैंने क्लास से पूछा था, तो आपने क्लास में बताया था टॉर्नेडो।
हाँ हाँ, मैं टोर्नेडो तो बताया होगा क्लास में, वो नहीं बोल रहा हूँ, बट ये कॉम्पिटिटिव एग्जाम है तो मैक्सिमम स्टूडेंट्स को अगर नहीं पता है तो आप कंपटीशन में सेफ हो, ठीक है। यही मैं बोलता हूँ, इसलिए जो भी मंथली कंपाइलेशन मैक्सिमम स्टूडेंट्स पढ़ रहे हैं, अगर आप वो पढ़ रहे हैं तो आप सेफ हो। करंट अफेयर्स में तो वही सोचना है ना, बट बाकी चीजों में आपको ध्यान देना है कि नहीं, आपकी कंपटीशन तो जो लोग 4-4 साल से मेंस लिख रहे हैं, इंटरव्यू दे रहे हैं, उनके कॉन्सेप्ट्स तो बहुत हाई लेवल के हैं, ठीक है, आप उनके साथ कॉम्पीट कर रहे हो कॉन्सेप्ट्स में, तो वहां आपको काम करना है, वर्क करना है। चलो ठीक है। नेक्स्ट, व्हाई मोर ट्रॉपिकल साइक्लोन्स इन बे ऑफ बंगाल? ये स्टैंडर्ड मेंस का क्वेश्चन है, इट कैन बी आल्सो आस्क्ड इन प्रीलिम्स। व्हाई मोर नंबर ऑफ लो लेवल डिस्टर्बेंसेस आर फॉर्म इन बे ऑफ बंगाल? ठीक है, यहाँ पे ज्यादा होते हैं। देन सी सरफेस वाटर टेम्परेचर आर मोर इन बे ऑफ बंगाल as compared to Arabian Sea. Why? It is more enclosed nature of sea. So redistribution of heat from land to ocean happens. Then high influx of fresh water in Bay of Bengal, that is also true. What happens because of this?
So the water is not mixed, so the surface water it gets heated, so that is why the temperature is comparatively higher.
So when there is thick layer of surface water, fresh water, and fresh water it is having less density, so it will float on the more saline water and it will remain on the top layer. So there will not be more intermixing within the ocean layers. Surface water का temperature ज़्यादा ही रहेगा all time. It's not the case in Arabian Sea. ठीक है, high speed monsoon winds over the Arabian Sea drives away moisture. Horizontal winds होता है, they will drive away the moisture. Moisture supply is the source of energy. तो इसलिए साइक्लोन्स जो है नहीं बनते अरेबियन सी में ज्यादा, ठीक है। ऑनलाइन स्टूडेंट्स जागते रहो, ठीक है। हाउ आर साइक्लोन्स नेम्ड? आई कैन अंडरस्टैंड थोड़ा मोनोटोनस होता है, ठीक है। पॉलिटी का कैसे हुआ? 2 दिन लेक्चर खत्म हुआ 2 दिन में, ठीक है।
सर पॉलिटी में वाज मोर ऑफ अ क्वेश्चन आंसर सेशन ना, तो बार उसका दिमाग एक्टिव रहता है पूछने के बारे में। यहाँ पे मतलब सर टीचिंग ना।
नहीं, मैं भी पूछता, बट मेरे को 1 दिन में खत्म करना है, ठीक है। प्रॉब्लम वो है थोड़ा सा, मैं ज्यादा क्वेश्चन पूछता हूँ ना तो कंप्लीट नहीं होगा, ठीक है। मुझे कंप्लीट करना है 1 दिन में, इसलिए मैं ये कर रहा हूँ। दैट्स व्हाई आई एम लीविंग सर्टेन थिंग्स व्हिच आर इजीली अंडरस्टैंडेबल या रीड वाली चीजें हैं। अब जैसे ये रीड वाली चीज है, इसमें समझने वाली कोई चीज है नहीं, एंड ये पूछ चुका है मेंस में एक बार। दैट्स व्हाई आई एम टेलिंग देयर इज प्रोबेबिलिटी कि ये मेंस प्री में आएगा फिर से, ठीक है। हाउ साइक्लोन्स आर नेम्ड? देयर आर रीजनल ऑर्गेनाइजेशंस फॉर्म अंडर यूनेस्को प्रोग्राम, World Meteorological Organization and UNESCO, and they are basically naming, like for Indian Ocean we have our old IMD that gives that name. 13 countries are there, Indian Ocean, and these 13 countries give 13 names, and there is a list of 169 names, and these names are given column wise to the cyclones. Column ऐसे खत्म होता है तो next column, row wise नहीं होता है। Then there are certain provisions here, specific provisions, right? So what are the? Name will be used sequentially column wise. First name will start from the first row. Name will have been already used in the list are highlighted. Name of tropical cyclone coming from South China Sea and crossing Thailand and emerging into Bay of Bengal will not be changed. अब ये बहुत ही specific है. Names of tropical cyclones will not be repeated. Proposed name should be neutral to politics, political figure, religious beliefs, gender. Maximum length 8 letters. बहुत ही specific है ये, ठीक है। All 13 members they give 13 names, ठीक है। इंडिया के नाम देखे होंगे आपने, ज्यादातर अग्नि, वायु, ये ऐसे कुछ होता है, ठीक है, पाकिस्तान के नाम देखना आप कैसे फूल, कमल या ऐसे पत्ते, इनके नाम होते हैं. साइक्लोन वार्निंग सिस्टम ऑलरेडी आस्क्ड इन मेंस एग्जामिनेशन. ठीक है, 2022 का क्वेश्चन है GS 1 में. कलर कोडेड वार्मिंग सिस्टम ऑफ साइक्लोन फॉर IMD बाय IMD. तो ये कलर कोडेड सिस्टम है. प्री साइक्लोन वॉच, येलो अलर्ट, ऑरेंज अलर्ट, रेड अलर्ट. एंड व्हाट आर द स्पेसिफिक प्रोविजंस, ये पढ़ लेना है आपको एक बार फिर से, बिकॉज देयर कैन बी मैच द फॉलोइंग टाइप ऑफ ओशन. एयर masses. So air masses are basically large bodies of air having common uniform properties in, we can say that, horizontal direction. Okay, what kind of properties? Generally temperature and moisture. Temperature and moisture. Okay, extensive air bodies. Now, air masses. Now, types of air masses depending on the geographical location, thermodynamic conditions and mechanical classification. Like tropical air masses को capital T नाम दिया है, polar air masses को capital P. Thermodynamic, warm, cold. Mechanical classification, stable, unstable. That means stable अगर है तो simply we should understand that it is not going to yield any rainfall. Unstable है तो there is probability of condensation, cloud formation and precipitation. Now within tropical, oceanic tropical, continental polar, oceanic tropical, continental tropical होना चाहिए यहाँ पे. ठीक है, ये tropical होना चाहिए. And then polar, oceanic polar or MP, maritime polar, and continental polar, CP. They are very significant. Okay, these air masses have impact on the climate of different regions. Especially CP is more prominent. ठीक है, CP and MT, maritime tropical. So impact of air masses, they bring precipitation in the continents. So whenever the maritime tropical air mass is moving from ocean to the land, generally it will carry the moisture and it will create instability also, and that will result into precipitation. Then latitudinal transfer of heat. So the way planetary winds or ocean currents are transferring the heat, these air masses are also transferring the heat latitudinally. Formation of temperate cyclones. When two air masses having contrasting properties like warm air mass and cold air mass, when they confront each other from opposite direction, then that may result into formation of temperate cyclones. ठीक है, 60 to 65 degree. Then extreme temperatures. Yes, that is also possibility. Why? Because when the air mass is staying near the ground for long time period, and if it is having too much of cold temperature or too much of warm temperature, or for example CP, continental polar, it is continental and polar, it is extremely cold air mass. Now during winter what happens? This CP moves towards the tropical regions, like where we have CP in Central Asia. So during winter from Central Asia, the winds are blowing towards the Indian subcontinent. These cold winds are brought by this CP. The same is with Canada. CP is there in Canada, and during winter the cold winds are brought by this CP towards the northeastern part of USA. That blizzards are because of this. Very cold winds. ठीक है, तो वो है. Then bomb cyclone, if you remember, कभी न्यूज में पढ़ा होगा, bomb cyclone. It is a kind of temperate cyclone. But here there is significant drop in temperature within 24 hours. तभी उसको bomb cyclone बोलते हैं. बहुत कम टेम्परेचर हो जाता है 24 आवर्स में, तो तभी उसको बॉम्ब साइक्लोन बोलते हैं. ठीक है, ओके. नाउ लेट्स टॉक अबाउट एक्स्ट्रा टेरेस्ट्रियल साइक्लोन्स क्विकली, और टेम्परेट साइक्लोन्स. So temperate cyclones are formed in 60 to 65 degree north and south, and they are formed because of these air masses contrasting properties cold and warm air masses. Warm air mass is coming from the temperate region, cold air mass is coming from the polar region, and they are confronting each other at that particular latitude. And of course, that is subpolar low pressure belt. So there is low pressure form along that region. Now what happens is the sequential formation of different fronts happens there as a part of this cyclone formation. So what is front? Yes, when two air masses of contrasting properties, they meet each other, there is formation of front. So there are four types of fronts. One, stationary front. Second, cold front, then warm front, and then occluded front. Okay, stationary front looks like this. ये देखिए, cold air mass इधर से है, warm air mass इधर से है, and अभी क्या है? जैसे मैं हमेशा एग्जांपल देता हूँ कि वॉर चल रहा है और वॉर शुरू होने से पहले आर्मीज खड़ी होती है, सामने एनिमी की आर्मी, इधर एनिमी, ठीक है, तो वो जो पोजीशन होती है स्टेशनरी. ओके, सो अभी तक इन्होंने अटैक नहीं किया है एक दूसरे पे, इन्वेड नहीं किया है, तो वो स्टेशनरी पोजीशन. नाउ द कोल्ड एयर मास और कोल्ड फ्रंट, सॉरी, ठीक है, तो ये समझो कोल्ड एयर फ्रंट है और कोल्ड फ्रंट वेयर suppose this is, we can say, stationary front. कोल्ड एयर मास है, वार्म एयर मास है. अब यहां पे देखो, यहां पे क्या हो रहा है, कोल्ड एयर मास इज मोर एक्टिव, ठीक है, एंड इट इज एक्टिवली स्वीपिंग द वार्म air mass area covered by warm air mass. ठीक है, it is actively sweeping the warm air mass from its ground. That region is called as cold front. This is called as cold front. Now, the warm air mass also tries to invade the area of cold air mass by climbing above it. ठीक है, तो वो क्या होगा, वार्म एयर मास क्या करेगा, ये कोल्ड एयर मास के ऊपर चढ़ जाएगा, क्योंकि वो तो उसको रिप्लेस नहीं कर पाए. कोल्ड एयर मास इज डेंसर वन, इट विल स्टे नियर द ग्राउंड, सो इट विल रिप्लेस, इट विल ट्राई टू क्लाइंब अबव इट. दैट फ्रंट इज कॉल्ड एज वार्म फ्रंट. ठीक है, तो जहां पे जो एयर मास एक्टिव है उसको वो फ्रंट नाम दिया गया है. नाउ along the cold front, when the cold air mass is active, it is completely lifting the warm air mass suddenly, and because of that it looks like this. तो क्या ये क्या कर रहा है, ये वार्म, सॉरी ये कोल्ड है इधर से और ये वार्म है, तो ये ऐसे ऊपर लिफ्ट कर रहा है इसको, and because of that there will be thunderstorm and lightning cumulonimbus clouds. Okay, along the cold front. Along the warm front, what we see? Yes. So the warm air is moving slowly above the cold air. ठीक है, the cold air के ऊपर चढ़ रहा है पीछे से, और यहाँ पर क्या हो रहा है, लेयर्ड क्लाउड्स तैयार हो रहा है, अलग अलग हाइट पे अलग अलग कंडेंसेशन हो गए टाइप्स. So these are layered clouds and they give drizzle over the long period of time. लॉन्ग टाइम ड्रिजल. ठीक है, तो ये ड्रिजल काफी हेल्पफुल होता है व्हीट कल्टीवेशन के लिए टेम्परेट रीजन में. स्टेपीज, प्रेरीज, वही तो रीजन है, तो वहां पर ये रेनफॉल जरूरी होता है. और वैसे ही हमारे यहां पर क्या है, यही तो आते हैं एक्स्ट्रा टेरिटोरियल साइक्लोन्स, टेम्परेट साइक्लोन्स एज अ वेस्टर्न डिस्टर्बेंसेस, एंड दे गिव रेनफॉल नॉर्थ वेस्टर्न इंडिया फॉर व्हीट कल्टीवेशन. ठीक है, तो ये भी याद रख सकते हैं. देन फाइनली देयर इज ऑक्लूडेड फ्रंट. ऑक्लूडेड फ्रंट लुक लाइक दिस. ठीक है, तो दैट मीन्स द कोल्ड एयर मास हैज गेन्ड मोर एरिया एंड वार्म एयर मास इज गोइंग टू कंप्लीटली डिसिपेट और शिफ्ट अबाउ द कोल्ड एयर मास. तो ऑक्लूड हो चुका है अभी. ठीक है, तो इट लुक्स लाइक दिस. ये देखिए, और occluded front, this is occluded front. वार्म एयर मास छोटा सा बचा है, मैक्सिमम जगह पे अभी कोल्ड एयर मास है. एंड फाइनली देयर इज डिसिपेशन ऑफ साइक्लोन. सो देयर आर 6 stages of cyclone formation. 4 fronts are formed within that. ठीक है, स्टेशनरी फ्रंट, कोल्ड फ्रंट, वार्म फ्रंट एंड occluded front. They are part of that cyclone formation. Okay, fine. चलो next. Differences, quickly we can see the differences between tropical and temperate cyclone. Origin due to thermal factor, due to dynamic factor. Okay, then location or latitude 10 to 30 degree, 35 to 65 degree. Formation on land or ocean surface, only on sea surface with temperature above this. Can be formed on both land and ocean surface. Driving force, latent heat of condensation. Temperature and density differences in two contrasting air masses. Size, small area, larger area. Rainfall, cumulonimbus cloud, torrential rainfall. Long drizzle from layered clouds. Travel path, from east to west under the influence of trade winds. West to east under the influence of westerlies. Lifetime, 1 week, 2 to 3 weeks, longer time period. Level of destruction, more destructive, comparatively less. Impact in India, both coasts are affected, but eastern coast is more vulnerable. Brings rainfall in northwest, western disturbances. चलिए नेक्स्ट, वर्ल्ड डिस्ट्रीब्यूशन ऑफ रेनफॉल. इससे भी क्वेश्चन बनता है, स्टेटमेंट्स. ओके, फ्रॉम इक्वेटर टू पोल इट गोज ऑन डिक्रीजिंग ओवरऑल रेनफॉल. कोस्टल टू इंटीरियर्स ऑफ द कॉन्टिनेंट गोज ऑन डिक्रीजिंग. मोर रेनफॉल ओवर द ओशंस एज कंपेयर टू लैंड. मोर इवेपोरेशन, मोर क्लाउड फॉर्मेशन, दैट्स व्हाई मोर प्रेसिपिटेशन ओवर द ओशन. Due to trade winds and westerlies when they are onshore. Onshore होगा तो ज़्यादा rainfall होगा, offshore होगा तो नहीं होगा. Windward sides of mountains receive more rainfall, like western slopes of Western Ghats, southern slopes of Himalayas, than the leeward side. ठीक है. Köppen's classification. ठीक है, तो Köppen has considered the classification based on relationship between the vegetation and climate of particular region. There are 5 types of climates. ठीक है, A, B, C, D, E. Okay, capital letters he has given, and let's say small letters further categorization. And B types are unique because they are dry climates, and here he is considering evaporation and precipitation criteria. While A, C, D, E, only temperature is the criteria. ठीक है, तो ये अलग है उसमें. Okay, so quickly we'll have a look at these climatic types, and also it is advised to go through your GC Leong book for all types of climates. GC Leong में हर एक क्लाइमेट के ऊपर एक सेपरेट चैप्टर है, सेकंड पार्ट जो है ना GC Leong का, तो वो करना है हमें अच्छे से. ठीक है. Okay, so what is the meaning of small f? Rainfall throughout the year. Small m, monsoon type of climate. W, winter dry. So winter there is no rainfall. Small s, there is rainfall. Summer dry. ठीक है, समर में रेनफॉल नहीं होगा. तो इस तरीके से उसको याद रखने हैं टेक्निक. ठीक है. Then tropical wet AF, rainfall throughout the year, no dry season, wet equatorial type of climate. ठीक है, इंडोनेशिया, कॉन्गो बेसिन, ब्राजील और अमेजोन बेसिन. ट्रॉपिकल मॉनसून AM, मॉनसून शॉर्ट ड्राई सीजन, इंडिया, नॉर्थ ऑस्ट्रेलिया, जहाँ पे मॉनसून फेनोमेनॉन है, साउथ ईस्ट एशिया. ट्रॉपिकल वेट एंड ड्राई सवाना टाइप ऑफ क्लाइमेट AW. ठीक है, सवाना टाइप ऑफ क्लाइमेट AW. वी आर मूविंग फ्रॉम इक्वेटर टुवर्ड्स द पोल्स. ठीक है, इसको अलग से करते हैं बी टाइप ऑफ क्लाइमेट को. सी टाइप देखिए, ह्यूमिड सब ट्रॉपिकल, CFA. So F is throughout year rainfall and A is we can say moving towards maximum rainfall. ठीक है, उसके आगे जो A, B, C, D आएगा तो वो क्या है, डिपेंडिंग ऑन द रेनफॉल टाइम पीरियड और द अमाउंट ऑफ रेनफॉल थ्रू आउट द ईयर हम बोल सकते हैं. देन वी हैव टू चेक इट इज टेम्परेचर और रेनफॉल, आई विल टेल यू. ठीक है, थोड़ी देर में. Then no dry season and warm summer. So F is there, so no dry season, rainfall throughout the year. What type of climate is it? Is China type of climate or Natal type of climate? China type, Natal type और Gulf type of climate, तीनों type है उसके. So what happens during summer? Onshore trade winds are bringing the rainfall. During winter the returning monsoon is also bringing the rainfall. ठीक है, रिटर्निंग मॉनसून जिसको हम बोलते हैं वो भी रेनफॉल ला रहा है, और यहाँ पे साइक्लोन्स भी रेनफॉल देते हैं. ठीक है, मेडिटेरेनियन समर ड्राई, विंटर रेनफॉल. ठीक है, ड्राई हॉट समर, CS टाइप, ये पूछा गया है प्रीलिम्स में क्वेश्चन, CS टाइप. ठीक है, देन मरीन वेस्ट कोस्ट, समर ड्राई. Marine West Coast climate, CFB. Okay, so F is throughout the year, rainfall throughout the year. Marine West Coast like British type of climate. British type of climate. No dry season, warm and cool summer. British कभी भी बारिश होता है ना यूके में, वो वाला है throughout year. Cold snow forest climates, D type. Humid continental and subarctic. ह्यूमिड कॉन्टिनेंटल हम बोल सकते हैं DF तैगा टाइप. नो ड्राई सीजन, सीवियर विंटर. सो दैट्स व्हाई वी हैव एवरग्रीन काइंड ऑफ फॉरेस्ट देयर एंड सीवियर विंटर्स. ओके, कोनिफेरस ट्रीज, तैगा. सब आर्कटिक DW, विंटर ड्राई एंड वेरी सीवियर. सो सब आर्कटिक फर्दर इन द हायर लैटिट्यूड्स वी आर टॉकिंग. देन E and cold type, tundra vegetation, no true summer. Polar ice caps further in the higher latitude. H is for highland, altitude. Okay, highland with snow cover. Now B type of climate, within that you can see differentiation. Subtropical steppe, BSH, and subtropical desert, BWH. H is for hot. Hot means tropical region or hot deserts. Okay, and capital S is for steppe. Capital S is for steppe. Capital W is for arid region. ठीक है, capital S is for semi-arid region, not steppe, sorry. ठीक है, capital S is for semi-arid region and capital W is for arid region. And small k is for cold desert. Okay, subtropical steppe मतलब semi arid region, low latitude semi arid or dry region like run of Kutch region or the region which is surrounding our Thar desert. ठीक है, semi arid region जिसको हम बोलते हैं. Then subtropical desert, Thar desert. यहाँ पे देखिए ना, BWHW, BSHW. ठीक है, तो BWH क्या है, डेजर्ट है प्रॉपर, एंड BSH क्या है, सेमी एरिड. मिड लैटिट्यूड स्टेपी, BSK, मतलब क्या है ये, स्टेपी ग्रासलैंड्स एंड दैट रीजन. मिड लैटिट्यूड डेजर्ट, कोल्ड डेजर्ट. ठीक है, तो मिड लैटिट्यूड और कोल्ड डेजर्ट हमारे यहाँ पर लद्दाख रीजन में जो है वो हम बोलेंगे कोल्ड डेजर्ट है. ठीक है, तो ये हो गए क्लाइमेट टाइप्स. इंडिया के क्लाइमेट टाइप्स आप देख सकते हैं वहां पर. ठीक है, ये इंपॉर्टेंट ये है, AS कोरोमंडल कोस्ट, समर ड्राई, मॉनसून डज नॉट गिव रेनफॉल हियर, रिटर्निंग मॉनसून गिव्स रेनफॉल हियर. ठीक है, दैट्स व्हाई AS समर ड्राई. ठीक है. Okay, then other important phenomenon. समझा है एल नीनो ला नीना? हर साल न्यूज में होता है ये, और हर साल लगता है हमें कि क्वेश्चन आएगा. 2017 के बाद मेरे ख्याल से नहीं पूछा है उन्होंने. एल नीनो मोडुकी के बाद पूछा ही नहीं है एल नीनो. बोल रहे होंगे कि प्रेडिक्ट तो ठीक से कर नहीं पा रहे हैं कि क्या होगा एल नीनो या ला नीना. चलो ठीक है. Let's try to understand the basics. El Nino and La Nina. First of all, what is normal condition in Pacific Ocean? That we have to understand. ठीक है. So, see here. This is Pacific Ocean. Okay. And in Pacific Ocean, during normal time period, what happens is the trade winds. यहाँ पे देखिए trade winds क्या हो रहे हैं? Normal time period पे ऐसे चल रहे हैं. Right. Because of these trade winds, what happens is it generates very strong equatorial currents. And these equatorial currents are carrying that warm water towards the western margin of Pacific. ठीक है? Western margin of Pacific. And that is piled up there. Now, I told you oceans are containers. So, if the surface water is moved towards one part, from bottom it has to be compensated. ठीक है, तो वो कंपेंसेट करेगा कहां पर? इस साइड में, बॉटम वाटर. एंड बॉटम वाटर इज कोल्ड वाटर. बॉटम वाटर इज कोल्ड वाटर. सो दैट्स व्हाई इट इज अपवेल्ड हियर. यहां पे क्या हो रहा है? अपवेलिंग हो रहा है पेरू कोस्ट पे. राइट, कोल्ड वाटर इज कमिंग अप. सो दिस इज द फेनोमेनन ड्यूरिंग नॉर्मल ईयर इन पैसिफिक ओशन. अपवेलिंग हो रहा है, यहां पे पाइल अप हो रहा है. राइट. नाउ प्रेशर कंडीशंस बिकॉज ऑफ दिस. As there is more and more warmer water here, there will be, low pressure created here. Because the wind is getting heated, it is moving up. So at surface it is creating low pressure. This is cold one, so here there will be high pressure. These are the normal conditions. Now Walker cell circulation, because of this, the wind is moving up here. Look at this. It is moving up. This is low pressure. Moving up, and then it is subsiding down here at high pressure, Peru coast. This is called as Walker cell circulation. Walker cell circulation. Okay. Now, what happens during the El Nino year? El Nino reverses or weakens this condition. Okay. So what happens here? So when I say weakens, that means there is weak trade winds. Weak trade winds are not carrying or pushing that water towards this particular western margin. यहाँ पे देखिए बहुत ज़्यादा पानी था, अब कम है. And because of that, it creates a strong counter equatorial current in this direction, as that piled up water earlier moves in this direction and spreads over Peru coast. Earlier there was upwelling going on there. Now that is suppressed because of this warm water coming at that. So this sudden arrival of warm water, I will not say sudden, it is unusual arrival. Usually these are the conditions. So unusual arrival of warm water along the Peru coast is called as El Nino. It is called El Nino. ठीक है? So ये वाला कंडीशन होता है. अब ये समझो बहुत ही स्ट्रांग हो रहा है, तो it reverses the Walker cell circulation. Why? Because the pressure condition changed. Here now the warm water has come, तो यहाँ पे low pressure होगा, comparatively यहाँ पे high pressure होगा. So here we have high pressure, यहाँ पर low pressure है. Low pressure है तो wind is moving up. This is the opposite circulation. Okay, Walker cell circulation is reversed. Now because of this reversal of Walker cell circulation, there are effects on the climatic, let's say weather conditions and climate of different regions. So what happens here? During normal time period, as there is upward movement here ऑस्ट्रेलिया रीजन, दैट रीजन देयर इज मोर रेनफॉल, ठीक है. बट यहाँ पर क्या है अभी, हाई प्रेशर. हाई प्रेशर promotes stability and that's why there are dry conditions in Australia and Indonesia, ठीक है. Similarly यहाँ पे desert conditions है, Somalia and that region, that experiences upward movement of wind and there is rainfall. नहीं होना चाहिए, वहाँ पे हो रहा है. That is also problematic. And in India, what happens in India, I will explain that here. So when we have high pressure here, there is low pressure created along the eastern ocean, eastern Indian Ocean, and western Indian Ocean, high pressure created here. Okay. Now this high pressure created here creates problem in monsoon. कैसे? Let's try to understand. ठीक है. What happens in monsoon? On land there is low pressure created. Near Madagascar here there is high pressure created. South of equator, Mascarenes high. ठीक है, तो ये क्या हो गया? हाई प्रेशर हो गया. अब अगर समझो ये हाई प्रेशर से विंड्स यहाँ पे जा रहे हैं लो प्रेशर की तरफ. The winds are trying to move from high pressure to low pressure. Suddenly they are encountering high pressure here in their path. They are encountering high pressure. So winds from this region do not have vigor to move towards this low pressure. ठीक है, वो वीगर से नहीं जाएंगे. जितना वीगर से वो इंडियन सबकॉन्टिनेंट पे आएंगे उतना वो मॉइस्चर लेके आएंगे. ठीक है, और बारिश भी देंगे. So what happens in El Nino year? This is the situation. But during normal time period, what was the condition here? Low pressure, high pressure, low pressure. यहाँ पे भी लो प्रेशर है इंडिया में, यहाँ पे भी लो प्रेशर है, यहाँ पे हाई प्रेशर. अब देखिए हाई प्रेशर से लो प्रेशर अट्रैक्ट करेगा ये विंड को, एंड फर्दर ये लो प्रेशर इसको अट्रैक्ट करेगा विंड को. ऑल्सो लो प्रेशर, दिस रीजन विल हैव वार्मर ओशन टेम्परेचर्स, surface temperatures, and that will lead to more moisture content by these winds. Here high pressure means somehow colder conditions are there, and that is not bringing more moisture with the winds. Both conditions affect the amount of rainfall and the vigor of monsoon. जो बोलते हैं ना monsoon delay होना, burst जो था वो नहीं होता है, डिले हो जाता है इस रीजन से. ठीक है, क्लियर है? एल नीनो एवरीवन. आएगा क्वेश्चन तो इसी कॉन्सेप्ट पे आएगा. ठीक है, और कुछ नहीं है इसमें. कुछ कहा गया? ला नीना कहा गया? चले. हाँ, अच्छा अच्छा. हाँ, okay. La Nina, during normal year, whatever the conditions are there, they are strengthened. ठीक है, they are reinforced. So that is basically what La Nina is. ठीक है, opposite condition El Nino के. तो क्या हो रहा था? upwelling हो रहा था. There was upwelling of cold water in Peru coast. That is strengthened, and Walker cell circulation is strengthened. Now this is favorable for the conditions are there, they are strengthened. तो इसका impact भी और strengthen हो जाएगा. तो generally La Nina years are good for monsoon. Then El Nino Modoki, ये पूछा था prelims में आपको. El Nino Modoki is the unique kind of conditions we can say that is created because of warming of Central Pacific instead of Eastern or Western. ठीक है, सेंट्रल पैसिफिक वार्म हो जा रहा है तो वहां पे क्या होगा? यहाँ पर लो प्रेशर क्रिएट होगा. मूविंग अप, विंड इज सबसाइडिंग डाउन, हियर सबसाइडिंग डाउन, हाई प्रेशर क्रिएट होगा, हाई प्रेशर क्रिएट होगा, कोल्ड वाटर, कोल्ड वाटर. सो अर्लियर देयर वाज ओनली वन वॉकर सेल, नाउ इट इज डिवाइडेड इनटू टू वॉकर सेल्स. ओके, नाउ इट इज डिफरेंट देन बोथ एल नीनो एंड ला नीना, क्योंकि यहाँ पे देखिए दोनों हाई प्रेशर हो गए. It was either high pressure, low pressure or low pressure, high pressure. यहाँ पे दोनों हाई प्रेशर बन गए, तो ये अलग थर्ड टाइप को कंडीशन लिया गया है अलग अलग एरियाज में. So it is rare, but okay, the way we have El Nino after 3 to 7 years, this is the cycle. And generally El Nino time period is within 1 year it ends. El Nino conditions within 1 year ends, but La Nina can extend into 2-3 years. जैसे ट्रिपल डिप ला नीना था पिछले साल तक, फिर बाद में एल नीनो आया, ठीक है. अब बोल रहे फिर से ला नीना आएगा, कुछ बोल रहे कि अभी भी चल ही रहा है एल नीनो, तो वो कंफ्यूजन चल रहा है ना, अभी न्यूज में आता ही रहता है. ओके, देन MJO.
How there is El Nino Modoki? Is there also La Nina Modoki?
ला नीना मोडोकी का शायद है, ठीक है, मैंने सुना तो नहीं है, पढ़ा नहीं है, बट है शायद, कहीं तो सुना. ठीक है, देखते हैं, शायद हो सकता है, क्योंकि अगर ये है तो वैसा भी होगा और अंदर वो लो प्रेशर हाई प्रेशर तैयार होगा. जितना मुझे पता है कि एल नीनो मोडोकी ही टर्म स्टैंडर्ड यूज होती है. मदन जूलियन ऑसिलेशन, सो व्हाट इज दैट? MJO. Yes, again it is a kind of the wind, so cloud bearing wind systems moving from Indian Ocean region towards the Pacific Ocean region along the equator. ठीक है, it originates above the Indian Ocean and it moves towards we can say Pacific Ocean and it dissipates there. Now what happens here? ये देखिए, यहाँ पे ओरिजिन हो रहा है समझो इस तरीके से, और ये इधर मूव कर रहा है और यहाँ पे डिसिपेट कर रहा है. बट ये ऐसे नहीं होता है एक्चुअल में. एक्चुअल में ये ऐसे चल रहा है, कैसे चल रहा है, और ये साइकिल है 30 to 60 डेज की. इट डिसिपेट्स इन 30 to 60 days. Okay, so when the wind is moving up, it is called as active phase. When the wind is moving down, it is called passive phase. Active phase is good for Indian monsoon because it will create favorable condition for cloud formation and precipitation. Passive phase will promote stability. ठीक है, तो if we have active phase of MJO during the monsoon time period, it will yield more rainfall. ऐसे याद रखना है इसको, ठीक है. ठीक है, तो climatology is done. Oceanography is a smaller part comparatively now. Let's quickly cover that and then we'll take a break, small break, tea break, and then static portion of your mapping part. ठीक है, वो कवर कर लेते हैं. इंडिया का भी कर लेंगे कवर, ठीक है, थोड़ा सा पार्ट है. हाँ, मॉनसून भी है. चलिए, ओशन फ्लोर mapping, or we can say relief features. So generally we can divide them as a continental margins, deep ocean basin, mid oceanic ridge, or simply continental margin. It is continental shelf, continental slope and continental rise together, they will be called as continental margins. Now what is continental shelf? It is the shallow extension of continental landmass into the water body, ocean water body. That is called as continental shelf. Generally the slope is around 1 degree only. ठीक है. Then maximum life is observed on the continental slope because the photic layer is there in the continental slope. ठीक है, marine life. Then there is continental slope. At the end of that continental slope is there. It is steeper. And the major feature observed on continental slope is submarine canyons. The way we have canyons on the land, we also have canyons in the ocean. They are called as submarine canyons. There are different theories for formation of submarine canyons, but the most approved theory is that most of the canyons are observed near the mouth of rivers, major river systems. अब क्यों ऐसा क्यों है? It is said that during the ice age time period, the sea level fell down. Okay, ice age के टाइम पे क्या हो गया? Sea level नीचे हो गया, क्योंकि ice ट्रैप हो गया ना वाटर लैंड पे, आइस में. So what happened because of that? When the rivers were flowing into the ocean, now they have to cross further more path, and there was more capacity to erode vertically near the mouth region by these rivers, and they started suddenly eroding that region as valleys. Now they are called as submarine canyons because after warming time period that got submerged under the ocean. ऐसे उसको समझना है. Like Hudson River, at its mouth we have huge submarine canyon. इंडिया में भी मेजर रिवर सर देखते हैं, कावेरी रिवर, कडलोर के यहाँ पर वहाँ पर भी सबमरीन कैनियन है. And they have huge river sediment deposits also. ठीक है. Then continental rise, a slight rise in the, let's say, altitude or we can say height ऐसे होता है because of all that debris that is brought from this continental shelf and slope, it is deposited here and that creates continental rise. ठीक है. Now, deep ocean basins. Deep ocean basins have features like abyssal plains, extensive featureless plain. They are more extensive than the plains on the land. Okay, then we have sea mounts and guyots. Sea mounts are more pointed and more heighted as compared to guyots. Guyots are flat tops, hills, residual hills. And then there are mid-oceanic ridge. We have learned about them. Divergent plate boundaries. ठीक है? So mid-oceanic ridge, they are also important features. Factors affecting temperature distribution. ठीक है? तो ocean temperature we are talking. So which factors affect? Latitude surely affect the amount of insolation received. Unequal distribution of land and water. Northern hemisphere has more land as compared to water. So that's why isotherms north में ज़्यादा ये होता है, influence होता है. Then prevailing wind, of course, when we have onshore winds, then the coastal waters are supposed to have more warmer temperatures because the warmer surface water is piled up there. Now, if there are cold winds or offshore winds, rather, not cold winds, offshore winds, what happens because of offshore winds? Surface water is driven away towards the ocean and that leads to upwelling of cold water. So that's why colder temperatures will be there. ठीक है? Then ocean currents. So ocean currents, warm ocean currents bring warmer temperature, cold ocean currents bring colder temperature. अब ये question expected होता है. Standard question. Enclosed seas in the lower latitudes record relatively higher temperature than the open seas. Best example, Red Sea, Mediterranean Sea. Enclosed है. Red Sea पे जो question आया था last year, एक यही था. Temperature ज़्यादा होता है या ऐसे कुछ? Rivers था. No river drains and no rainfall. हाँ ठीक है, वो भी question अजीब ही क्वेश्चन बनाते हैं. लॉजिक से भी क्वेश्चन किया करो यार, थोड़ा सा लॉजिक यूज कर लिया करो. डेजर्ट है, वहां पीने के पानी नहीं मिलता है, पानी जाएगा ही नहीं वहां पे, कहां से रिवर आएगा? इथियोपिया और वहां से कोई रिवर फ्लो हो सकता है क्या? सोमालिया से, सऊदी अरेबिया से, तो वो रेड सी है समझो. ऐसे लॉजिक लगाओ ना थोड़ा सा. Enclosed seas in the lower latitudes record relatively higher temperature. The reason is simple. It exchanges that heat, land exchanges heat with the ocean temperature and that leads to warmer conditions as compared to open seas. Open seas exchange कर रहा है बाकी temperature, बाकी water से. Enclosed seas in the higher latitude have lower temperature than the open seas. What is the reason? Enclosed seas in the higher latitude have lower temperature. Best example is Baltic Sea and North Sea. North Sea experiences higher temperature than Baltic Sea. Why? North Sea receives warmer waters from warm ocean currents, open seas. ठीक है, Gulf current और North Atlantic drift, but enclosed sea will not receive that. ठीक है, तो इसलिए ये वार्मर रहता है. ये important है assertion and reason. Horizontal distribution of temperature. Average temperature above 20 degrees Celsius, 27, gradually decreases from equator to poles. Rate of decrease of temperature standard 0.5 degree per latitude. Average annual temperature for the northern and southern hemisphere are around 19 degrees Celsius and why more? More land. ठीक है, more land है. Highest temperature is not recorded at equator but slightly north of it. What is the reason? Clouds. हाँ, तो clouds भी है वहाँ पे, cloudy है ज़्यादा, तो heat receive नहीं करता है वो. ठीक है. Then vertical distribution, 3 layers, thermocline. This is the region 500 to 1000 where there is sudden drop in temperature. Thereafter very simple decline. Here also very normal decline is happening. That region is called as thermocline. बाकी upper layer, middle layer, lower layer ऐसे याद रख सकते हैं. But it is not reaching to zero. याद रखिए ये. Why? कितना भी आप डीप जाइए यहाँ पे जीरो को टच नहीं करेगा ये. What is that reason? Simple. Anomalous behavior of water, density. 4 degrees पे क्या होगा? Maximum density होता है. And because of that, if there is lesser temperature than, it will move up. ठीक है, तो ये reason, major reason मतलब. Then factors affecting ocean salinity. Okay, salinity से related देखिए, evaporation. Tell me, if there is more evaporation, it will increase the salinity. Clear है? If there is more precipitation, it will decrease the salinity. More influx of fresh water, it will decrease the salinity. Online students, wind. Suppose there is onshore winds, it will pile up the warm water, that will increase the salinity. And if there are offshore winds, then there will be upwelling of cold water, decrease in salinity. Warmer waters will have more salinity. ठीक है, जो इवेपोरेट हो चुका है ना, इवेपोरेट हो चुका है तो ऊपर के लेयर में ज्यादा salinity होता है. ठीक है. Then ocean currents, same, warmer ocean currents bring more salinity, cold ocean currents less salinity. ठीक है, तो ऐसे याद रखना है. Then probable question, this one. ठीक है, salinity ranges between 33, what is this symbol? Parts per 1000. Okay. In the landlocked Red Sea, it is high as 41. In hot and dry regions, salinity sometimes reaches to this one. Salinity decreases from 35 to 31 on western parts of northern hemisphere. Why? ट्रॉपिकल रीजन्स में अपवेलिंग की वजह से ऐसे रखो. ठीक है, जनरली अपवेलिंग की वजह से होता है, तो वो कंडीशन है. ठीक है, प्रोमिनेंटली मैक्सिमम सैलिनिटी इज ऑब्जर्व बिटवीन 20 to 30 एंड 20 डिग्री वेस्ट एंड 60 डिग्री वेस्ट. इट ग्रेजुअली डिक्रीजेस टुवर्ड्स द नॉर्थ. मैक्सिमम सैलिनिटी कहां पर है? जहां पे सबसे ज्यादा इवेपोरेशन है. यहाँ पे सबसे ज्यादा इवेपोरेशन है क्योंकि यहाँ पे क्लाउड्स ही नहीं है, मैक्सिमम सनलाइट रिसीव हो रहा है. ओके, तो मैक्सिमम सैलिनिटी है. एंड सेकंड इज वेरी लो प्रेसिपिटेशन है, तो इसलिए फ्रेश वाटर ऐड ही नहीं हो रहा है. देन देयर इज नॉर्थ सी, डिस्पाइट इट्स लोकेशन इन हायर लैटिट्यूड रिकॉर्ड्स हायर सैलिनिटी. व्हाई लिखा नहीं है मैंने डिलिबरेटली क्वेश्चन पूछने के लिए. हाँ, North Sea, despite of its location in higher latitude, record higher salinity. Ocean currents, warm ocean currents. Then Baltic Sea records low salinity. Why? Very good. Melting of glaciers and fresh water. So many streams, thousands of streams are adding fresh water. Mediterranean Sea records higher salinity. Why?
Rivers, many rivers.
Higher salinity.
It is surrounded by land, so evaporation.
Very good. Evaporation of sea. Why?
Freshwater rivers.
Black Sea receives so many rivers. यूक्रेन से जो अभी रिवर्स जा रहे हैं, डेन्यूब एंड ऑल, ठीक है, वो चल रहा है ना वहाँ पे ब्लैक सी में. ओके. एवरेज सैलिनिटी ऑफ इंडियन ओशन इज दिस वन, एंड लो सैलिनिटी ट्रेंड इज ऑब्जर्व इन बे ऑफ बंगाल. ऑन कॉन्ट्ररी, अरेबियन सी शोज हायर सैलिनिटी. व्हाई? फ्रेश वाटर इनफ्लक्स. ठीक है. ओके. Vertical distribution of salinity. Now this is very unique. Okay, salinity at surface increases by loss of water to the ice or evaporation, or decreased by input of fresh waters from rivers. High salinity sea water generally sinks below the low salinity water. ये तो standard है, आपको पता है. Low salinity water rests above the higher salinity dense water. Salinity generally increases with depth, and there is distinct zone called as halocline, wherein salinity increases sharply. Now, increases salinity of seawater causes density to increase. But this salinity increase is not common throughout, let's say, equator to poles. In lower latitude and higher latitude, it is different. Pay attention here. यहाँ पे देखिए, ठीक है, तो ये क्या है, समझो लोअर लैटिट्यूड रीजन है, यहाँ पे हायर सैलिनिटी है, इक्वेटर और ट्रॉपिकल रीजन में. हायर सैलिनिटी किस वजह से है? इवेपोरेशन की वजह से. अब ये सैलिनिटी जो है धीरे धीरे कम हो रहा है, समझो ये 40 डिग्री नॉर्थ है, ठीक है, 40 डिग्री नॉर्थ तक क्या हो रहा है, सैलिनिटी कम हो गया, एंड देन देयर इज कांस्टेंट. इन पोलर रीजन समझो ये क्या है, 90 डिग्री नॉर्थ है, यहाँ पे सैलिनिटी बहुत कम है, and rather here now salinity is going to increase. Now why it is situation that why we have low salinity in polar region surface level पे? Melt water is fresh water, zero salinity, fresh water. Okay, but as we are moving towards the lower latitude now, what happens is there is increase in salinity. See, when the water is moving towards the polar region and when ice is getting formed, ice is not going to have any mineral. Ice is converting pure water into ice. Remaining minerals are going down. They are sinking down. Try to understand this. ठीक है? And when they are sinking down, only pure ice is there. When that is melting, very pure water, or we can say pure water is there, and it is not going to have any salinity. ये उसमें difference है. Temperature का ऐसा नहीं है. Okay, ocean water movements. 3 types of ocean water movements: waves, tides, and ocean currents. Okay, so waves are formed because of what? Yes, prevailing wind. So prevailing winds are giving its energy to surface water, and because of that the water is basically releasing that energy towards the coast in the form of waves. So what happens here? This is the movement of, we can say that ये ऊपर जा रहा है, नीचे आते वक्त वो एनर्जी अगले वाले पार्टिकल को देगा, अगला पार्टिकल ऊपर जाएगा, उसको नीचे देगा. This is how the wave train moves. It is transfer of energy and not actual movement of water molecules. It is not actual movement of water molecules. Wave में क्या है? Transfer of energy होता है सिर्फ. So crest and trough, these are the wave and wave energy. Prevailing wind is the source. Then tides. 3 forces: gravitational force of moon, gravitational force of sun, and centrifugal force of earth due to rotation of earth around its axis. So simple when the tide is channeled between islands or into bays or estuaries, they are called as tidal currents. Narrow channel होता है तो tidal current बन जाएगा वो. Time between high tide and low tide, it is called as ebb. The time between low tide and high tide, it is called as, or when the tide is rising, it is called as flood or flow. ये terminologies NCERT में दी हुई है. ठीक है, these are given in NCERTs. Types of tides, neap tide and spring tide. Very simple. When they are in one single line, all three bodies, it is spring tide. When they are in perpendicular manner, it is neap tide. Neap tide is lower in height as compared to spring tide, but higher than the normal tide. ठीक है, but higher than the normal tide. डेली वाला टाइड जो होता है उसको मैं नॉर्मल टाइड बोल रहा हूँ.
ये सर मंथ में दो ही बार होगा, नहीं दो बार.
यस, 15 days और 14 days लूनर साइकिल के साथ. हाँ, ओशन करंट्स ऑफ कोर्स. सो फर्स्ट ऑफ ऑल द फैक्टर्स रिस्पॉन्सिबल, प्राइमरी फोर्सेस, सेकेंडरी फोर्सेस. 3 बार उन्होंने मेंस में क्वेश्चन पूछा है ये. ठीक है, हाउ ओशन करंट्स आर फॉर्म. ठीक है, तो first and primary force is heating by solar energy in the tropical areas. Heating is very important. There is expansion of water. Natural gradient is created. Under that natural gravity, the water moves from equatorial region to polar region. Then winds, especially prevailing winds like trade winds. So they are dragging the surface water towards eastern margins of continents. That leads to let's say equatorial currents. Okay, equatorial currents. Then they are diverted to their right in the northern hemisphere and to the left in the southern hemisphere because of Coriolis force. Then secondary forces. Shape of coast. Like for example, this Brazilian coast. Look at this. So this south equatorial current is divided like this and this because of shape of coast. Then ocean bottom relief. Ocean bottom relief also affects the movement. Like for example, here you can see that this Gulf Stream, it is moving like this, divided like this because of the presence of mid-oceanic region here, like this. Mid-oceanic ridge is playing role in the direction of that ocean current. Seasonal variations. Here, Indian Ocean region, especially North Indian Ocean. So there is reversal of these ocean currents because of seasonal reversal, and that is the only region where we have such kind of changes. See, in the equatorial region, it is receiving maximum energy and it is getting heated. When it is getting heated, so there is expansion of water. When there is expansion, the water level here, it is rising as compared to cold water, the polar region. There is natural gradient created on the earth's surface from this region to this region. So water will try to slide down under the gravity along that gradient. Okay, so physical geography of India. You can read this, all the information I have added from NCERT and some additional information. Types, and we can say Himalayas and the physical geography aspect. Okay, northern plains. I have highlighted also few things. जो facts जिसको बोलते हैं हम, जैसे ये islands है तो 10 degree channel, 9 degree channel, 8 degree channel, वो सब चीजें highlight की है मैंने. चलिए मॉनसून पढ़ लेते हैं 2 मिनट में, then we will stop for tea break. ठीक है? So monsoon phenomenon, it involves important aspects like distribution of land and ocean surface, then role of jet streams, then role of Tibetan plateau. ठीक है. Then one more aspect here, ITCZ और monsoon trough. ये distribution में मैं बोलूँगा, उसको cover करेंगे. So what happens here? Pay attention. During winter time period, the sun is basically south of equator. ठीक है, sun is south of equator. Now, when the sun is moving towards Tropic of Cancer during summer, this region is getting heated slowly, and the land is getting more heated as compared to ocean surface. Well, the southern hemisphere is now cool, winter is going on, and same Indian Ocean south of equator is getting cooled. When it is cool, there will be high pressure built up there. When it is getting heated, low pressure is going to be created here. So somewhere here, Peshawar in Pakistan, the low pressure is created on the land, the Indian subcontinent. Now, what happens here? Pay attention. When there is low pressure and there is high pressure here somewhere in the south, high pressure, the winds will try to move from high pressure to low pressure. Ideally, this is the condition. But we are now understanding it at more advanced level. Kaise? First, concept of ITCZ, Intertropical Convergence Zone. What is that convergence zone? It is the region where trade winds are converging, right? And it is not a stationary line, rather it is moving along with apparent movement of sun. ठीक है, तो वो क्या हो गया? ITCZ. As the sun is moving towards, we can say, Tropic of Cancer, the ITCZ is also shifting there. Okay, when ITCZ is shifting, that means the trade winds from south will also try to follow that ITCZ. Okay, now when the trade winds from south will try to follow that, they will cross the equator and they will change the direction. So earlier the trade winds were like this, towards the east in the southern hemisphere. When they cross the equator, they are entering into northern hemisphere. This is the direction of monsoon winds. Pehla concept, ITCZ. Now, when the ITCZ is shifting to the north and it is set over the Indian subcontinent like this, in June month or first week of June month, there are going to be few changes. What changes are going to be there? There is one jet stream in the upper atmosphere that is traveling like this. Earlier, this was the condition during winter for this jet stream. During winter, this was the condition. That means it is divided into two branches because of Himalayas and Tibetan Plateau. Northern branch and southern branch. During winter. During summer, especially in the first week of June, this southern branch is shifting to the north. Okay, it is shifting to the north, and that leads to condition like this. Okay, this is the position now. It has shifted to the north of Tibetan Plateau. And because of this condition, what happens is, there is sudden arrival of monsoon winds on the Indian coast. That is called as burst of monsoon. Now, why only when it is shifting to north? When it shifts to north, the upper atmosphere over the Tibetan Plateau, there is setup of one important jet stream called as tropical easterly jet stream. Upper atmosphere of Tibetan Plateau. Okay, I will explain that, Tibetan Plateau, how it plays role. And that tropical easterly jet stream that is formed here in the upper atmosphere is moving towards this high pressure. And it subsides down above this high pressure. That means it is pressurizing this high pressure. And it is asking these winds to move it creates a kind of circular motion of wind like this. ये क्या कर रहा है? ये lower atmosphere में, ये upper atmosphere में. This is how monsoon circulation happens. ठीक है, तो jet stream का रोल समझ में आया? Now, Tibetan Plateau. So what happens here in Tibetan Plateau region? During summer, that plateau region which was covered earlier by ice during winter, it is now exposed because of melting of ice, exposed to sun rays, and that gets severely heated. When such huge landmass is severely getting heated, there is low pressure created on the surface. While the wind is moving up in the upper atmosphere, there is high pressure created. And from that high pressure region, the wind is creating circulation towards this high pressure. Okay. Now, if the ice cover in the Tibetan Plateau changes, that changes the situation of tropical easterly jet stream. Okay. That means if suppose the ice cover is less, if ice cover is less during winter, so it is going to get heated more and more strong low pressure at surface and strong high pressure at. So that is a good condition for monsoon in India. ठीक है, वो प्रेशर करेगा ऊपर से. तो ऐसे इस फेनोमेनन को समझना है, रोल ऑफ टिबेटन प्लेटो. नाउ यू मस्ट बी थिंकिंग कि फर्स्ट वीक ऑफ जून में ही क्यों हो रहा है सर? ये लो प्रेशर तो स्ट्रेंथन मई में ही हो गया. Ideally, it should be happening in May month only. So why monsoon is arriving in the first week of June only? Why not in May? Monsoon in Myanmar reaches in May month only. That's why there is a typical climate of India. Southeast monsoon is different. It starts in May month only. Yes. What happens to subtropical jet stream?
It's preventing the winds from coming.
Very good. So, suppose let's say this is the subtropical jet stream, and suppose this is the Peshawar low pressure. ठीक है, और ये विंटर वाला कंडीशन है, नॉर्दर्न ब्रांच एंड सदर्न ब्रांच, ऐसे. Now, when there is position of subtropical jet stream like this in the upper atmosphere, it does not allow the wind from the surface, low pressure, to move up. Why? Because of clockwise circulation in upper atmosphere. There is no outflow. There is inflow rather. So, it pressurizes the wind from the upper atmosphere towards the surface. Ideally, if the low pressure is created on the surface, it should rise up, and that place will be taken up by the wind from surrounding. अगर ऐसा होता तो तभी सराउंडिंग से, यानी कि इंडियन ओशन से विंड्स आ जाती, बट ऐसा हो नहीं रहा है. क्यों? Because of this positioning of subtropical jet stream. Now what happens when this southern branch shifts to north? This position completely changes like this. And this low pressure at Peshawar is going to have anti-clockwise condition in the upper atmosphere. That means there is some kind of outflow created here. Suddenly, the wind from the surface near Peshawar will rise up, and the surrounding winds will gush in to fill in that low pressure. ये first week of June में ही हो रहा है. That's why we observe burst of monsoon. ठीक है, अगर ये मई में आता तो शांति से आता, ठीक है, तो उसको रोक के रखा था इस कंडीशन ने. And now there is burst of monsoon in the first week of June because of this condition. Then of course how it proceeds. So there is onset or burst of monsoon, then there are breaks in monsoon. there are breaks in monsoon, but before that, you know, there are two branches of monsoon majorly.
So tropical easterly jet stream is a seasonal jet stream.
ट्रॉपिकल, हाँ सीजनल है, वो मानसून के टाइम पे ही ज्यादातर होता है, बट ये थ्रू आउट ईयर है.
So what is the reason of shifting of this southern branch towards?
Because of ITCZ. ITCZ is moving towards Tropic of Cancer, and that means it is shifting all the pressure belts and wind belts to the north, including jet streams. ठीक है, तो ऐसे समझना है उसको. Okay. Now what I was telling you, this ITCZ itself is also called as monsoon trough. Okay, and that monsoon trough actually vibrates like this over the Indian subcontinent. Now, if the monsoon trough is located at particular location, the wind will come and rise, and there will be cloud formation and precipitation, because it is ITCZ. Now, if monsoon trough shifts from this position to this, there will be break in monsoon at that location. Like monsoon trough shifts to the north over the Himalayas, then Indian Peninsula experiences break in monsoon. जैसे जनरली अगस्त मंथ में होता है, देखो ऊपर बारिश ज्यादा होता है और यहाँ पे ब्रेक हो जाता है. ठीक है, सो इस तरीके से. एंड सेकेंड इज दैट व्हेन these winds that are coming, when these winds are blowing parallel to the coast, okay, especially these winds, Arabian Sea, so that region, this region experiences break in monsoon. Generally two branches we learn about that, right? दो branches कौन से होते हैं? एक Arabian Sea branch, and this branch reaches directly northeast, then it turns like this and it reaches this Arabian Sea branch. Further is divided into two branches, one moves like this and other is perpendicular to Western Ghats. Parallel to Aravallis, it is reaching to northwest India, and other comes from this direction like this. ठीक है, तो ये बेसिक कॉन्सेप्ट है मॉनसून का. एंड रिट्रीटिंग मॉनसून, ऑफ कोर्स ड्यूरिंग मॉनसून टाइम, विंटर टाइम पीरियड, व्हाट हैपेंस? द विंड्स डायरेक्शन चेंजेस, राइट? सो इट डिफ्लेक्ट्स टू देयर लेफ्ट, राइट इन द नदर्न हेमिस्फीयर. अब ये देखिए, ये क्या है? मैक्सिमम एरिया पे लैंड से मूव कर रहा है, बट यहाँ पर ओशन से मूव करके लैंड पे आ रहा है, तो दैट इज ब्रिंगिंग मॉइस्चर. सो कोरोमंडल कोस्ट रिसीव्स मोर रेनफॉल फ्रॉम दिस. अक्टूबर नवंबर में देखिए वहां पे फ्लडिंग हो जाती है. एक्स्ट्रा मॉनसूनल रेनफॉल, देयर आर फ्यू इंसिडेंसेस ऑफ साइक्लोनिक रेनफॉल, ओडिशा एंड आंध्र प्रदेश, राइट? देन देयर आर वेस्टर्न डिस्टर्बेंसेस कमिंग फ्रॉम दिस साइड, एंड देयर आर प्री मॉनसून शावर्स. प्री मॉनसून शावर्स लाइक बारडोली चेरा, आसाम, और नॉर्वेस्टर्स, वेस्ट बंगाल, मैंगो शावर्स, कर्नाटका, केरला, चेरी ब्लॉसम्स, कॉफी ब्लॉसम्स वहां पे कर्नाटका. ठीक है, सो